let me just have a pen. Okay. So quantity is all about the materials and the cost of the project. Okay. You can say the materials used in project will be just calculating the quantities, or you can say the estimation, okay, of quantities for the same project, and then the cost of the same project. Cost of the same project cannot be determined if you don't have the quantities of materials. Now, quantities of materials can be in different, you can say, form. It can be in terms of length. It can be in terms of area, because if you remember plaster, okay, it is just an example. Like you can say the tile work, maybe the whitewash, okay, and then maybe pointing. Okay, these are just the examples. So these things, or you can say these materials, are determined in terms of areas. Now, length, you can say maybe pipe, okay? Pipe is calculated in terms of length, okay? So that's not our actually approach in the same video. Length, it is just simple thing. You can say how many meters, how many feet, kilometers, okay? So this is known by the length. Now, our approach is actually the area, because area is really important, okay? And it can give us multiple, you can say, options. Now, next we have the volume. Okay, volume is also very important, because if you remember PCC, RCC, and you can say brickwork, these things are determined in terms of volume. And after that, we can of course just calculate the cement, okay, from the volume, maybe the number of bricks. Other participants are also joining. We are not gonna just wait for them, okay? We'll just carry on. So what we do actually in volume, we determine the other things, maybe that is just known by the analysis then. Like you can say, let's say PCC. If we have PCC, what does PCC means? It is actually plain cement concrete. Now in PCC, there can be three materials. Like you can say cement, then there can be sand, and there can be, you can say, coarse aggregate. Sand is actually just the defined aggregate, okay? So let's say coarse aggregate. It means there are three materials. Now, in order to determine the quantities for these three materials, you should know the calculation for volume, okay? That's why volume is really important, okay? So we'll just move ahead straight forward toward the area and volume, and this is just the review, you can say, okay, in overview of the previous video, because that video was just you can say in Urdu, and many of the participants don't understand about the same language, Urdu, you can say. That's why I'm going to repeat those things in English. Now, as you can see, the first thing we have actually area of the square. And remember, square is just the same thing, okay? A 2D geometrical shape with two equal sides. Not two equal sides, four equal sides. You can say this is A, this one is A, okay? All sides are just having the same length. Let's say A is 10 centimeters, okay? That means the other side should be 10, the other one should be 10, okay? That's not 100, it's 10, and this one should be 10 as well, okay? Now the area of E square can be its side square. A means the side of the square, okay? It is so simple. Now in order to determine the area, it can be actually 10 times 10, okay? Because A square means A times A. It is very basic and you already understand this, but I'm just reminding, okay? I'm recommemorating these things to you because these things gonna help us, okay, little late in the same, you can say course. Because let's just consider a column, okay? Let's say this is a column, a square column, okay? And it is just like this. Now, how do you determine the PCC work for the same column? You can just determine the area of the base, which is a square, okay? It should be a square. And then you just multiply this area with the height of the column. So you can have the PCC work in terms of, you can say, volume. It means the square area is very important over here. Okay, so this is just an example. Okay, moving ahead. Next, we have a rectangle, and which is actually a geometric shape with sides. Those are parallel, must be same in length, and there must be actually 90 degrees angle between them. If this angle is not 90 degrees, it means it is not a rectangle. It can be any other thing like parallelogram, okay? Can be any other thing. So area of the rectangle can be actually AB. A means one side of the rectangle, B is actually another side. You can say the length of the rectangle, okay? So length times width, it should be the area of the rectangle. Very simple, okay? You can say area equals the length, and then we have the width or maybe the breadth, okay? Let's say area, you can say the parameters, let's say this one is 5 and this one is 10. So it means area is going to be 5 or maybe let's say 10 times 5, okay, which is 50 units. Why I'm typing units over there? Because we don't know what is 10 and what's 5, okay? We don't know the, you can say the measurements units. If that is just in feet, it means the unit can be square feet. If those two parameters are in meters, it means the area is going to be in square meter, okay? If that's in kilometer, it means the area should be in square kilometer, okay? Okay, moving ahead. As you can see, we have a parallelogram. Now, parallelogram, it is also something like a rectangle, but it does not have 90 degrees over there, okay? At corner. This angle can be different. Now, area of the parallelogram can be AB. Let's say this is A, okay? Let's say this is the base, okay? And I'm going to represent that with A. Now, B is actually the height, okay? Just the distance between those two parallel sides. So this is the height, not this side, okay? The inclined one. It is never the inclined one. Okay, let me ask you a question, okay? Are you guys with me or not? Where are you?
Yes, sir.
Yes, sir.
Okay, okay, I'm gonna ask you very interesting question. Okay, let's say if we have a rectangle, okay, and this is A, B. These are the sides. And there we have a parallelogram, okay? This is A, this side is B. And let's say this is A1, area 1, and this one is A2, area 2. Now, I'm gonna ask you which area is, you can say, more. Is A1 greater, okay, than A2, or A2 is greater than A1? Or you can say A1 equals A2. Which one is correct?
Second,
Equal, sir.
It is very simple question, okay? Okay, जिसने भी ठीक कर दिया ना, मैं 10 रुपए इनाम दूंगा. चलो.
Equal, sir.
A1 is equal to A2.
अच्छा, okay.
A1 is greater than A2.
Okay, let me just undo this thing, okay? It's not working, so I'm gonna erase these things. A1 is never equal to A2. Why? Because area of the rectangle, that is actually, let me say here is a rectangle AB, okay? Area of the rectangle is actually A times B. Now, area of a parallelogram, okay, if you consider this side, let's say this is B this time, and this one is H, okay? Now, area of the parallelogram should be AB times sine alpha, okay? This angle should be involved in parallelogram, okay? This area is also correct. If you take B is the height. Now, if you involve sine theta, it means if sine theta, let's say if sine theta is 45 degree, if it is 30 degrees, if it is 60 degrees, it can be anything. It means the value of sine degrees, that should be less than 1. Okay, it can be 0.5, 0.75, anything it can be. So if you involve sine theta, it means the value is decreasing. Value of AB that is just decreasing. It means the area parallelogram that is just less than the area of a rectangle. Okay, moving ahead. Next we have
Yes, sir.
trapezium. Okay, you can see the shape. Okay, let's say the top one that is A, the bottom one that is B. Okay, these are the parallel sides, and here we have height H. Okay, now area of the same trapezium can be actually the summation of the parallel sides. Okay, you can say in average value, this should be average value, and we will just multiply that with the height. It is very simple. Okay, now this trapezium can be in another form like this one as well. Okay, if you have the same thing like this one, you can also use this formula as well. Okay, no problem. All right, next we have quadrilateral. This is a very important thing. Okay, and most of the properties. Okay, if you are, let's say, a patwari, you know about patwari? A person who measure, you can say, measures the lands, okay, the property, or you can say, if you are a person to determine the area of a land, it means you are patwari. Okay, it is simple. Okay, a person who keeps the record of properties, you can say it is patwari. So quadrilateral, it should be actually the area of quadrilateral should be the, you can say, product of its diagonals. Let's say this is diagonal 1 and this one is diagonal 2, and we will multiply this with, you can say, an angle which is formed by these two diagonals. This is, let's say, alpha, and we're gonna have actually 1/2. Okay, so this is going to be the area of a, you can say, quadrilateral. Okay, there can be another quadrilateral as well. Okay, most of the patwaris, have you ever seen this formula? Let me just erase these things. Okay, if you have seen this formula, okay, what they do actually, if you have, let's say, A, B, C, and this one D. Okay, most of the patwaris, they actually take average of the opposite sides, like A plus C. Okay, this is average, and then multiply with B times D by 2. Okay, have you seen this formula? Most of the patwari use this formula, which is actually wrong. It is completely wrong. I never recommend this formula. Okay, what I actually recommend is, if you have a quadrilateral or an irregular shape like this one, you should just split this into two triangles. Simple. Okay, determine area of each triangle and then add them. It is the same area as the quadrilateral area. Okay, very simple. All right, next we have circle. Pretty cool thing. Okay, कोई कोई अगर दूसरा बंदा इस बंदे के सवाल को पूछ ले तो शायद मैं सुन सकूं।
सर ये कह रहे हैं कि ट्राइपीजम का फार्मूला इस पर नहीं लग सकता।
ओए नहीं 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 नहीं, इसलिए नहीं लग सकता क्योंकि ट्रोपीजियम में टू पैरेलल साइड्स है। देखो भाई, दो साइड्स पैरेलल है। ठीक है, अच्छा, मैं एक अनदर फार्मूला मेरे पास है एक्चुअली। ओके, जिसको एक एक बंदे ने चैलेंज भी किया हुआ था मेरे साथ। एक सेकंड, मैं उस फार्मूले को थोड़ा आप लोगों के साथ शेयर करूं, क्योंकि आप लोग भी चैलेंजेस फेस कर सकते हैं।
उर्दू में बस लेक्चर कर लें तो बहुत अच्छा हो जाएगा सर।
Oops,
बहुत बड़ी मेहरबानी।
sorry, I'm gonna have in English that because few students don't understand about Urdu.
पूछ नहीं
Okay,
कह रहे हैं
मेरी अपनी
बाकी
उर्दू मेरी बहुत वीक है यार।
सर आपको
बहुत
सुबह भी हमने कहा था कि कोई मसला नहीं है, हम खैर कॉम्प्रोमाइज कर लेंगे।
नहीं नहीं, इसमें ना 2-3 बंदे इंटरनेशनल है तो उन लोगों के लिए मसला है ना। एक बांग्लादेश का है शायद और श्रीलंका के एक बंदे हैं, 2, तो इस वजह से।
सही।
And I think my English is very simple. Okay, there is nothing
सर
complicated.
हमारी तो सिंपल भी नहीं है।
अल्लाह के बंदे, मैंने कोई मुश्किल वोकैबुलरी भी इस्तेमाल नहीं की अभी तक। वही सारी
कोई
पुरानी
बात नहीं,
चीज।
कोई बात नहीं है सर,
ओके
आप
तो
कंटिन्यू।
ठीक, एक सेकंड, एक क्वाड्रेटरल ये भी है। अगर आप एक सर्कल में, लेट्स से एक सर्कल है हमारे पास, ये ठीक है, जो कि मैंने बड़ा फजूल से ड्रा किया। अच्छा, वी हैव ए सर्कल लेट्स से, एंड देयर इज ए क्वाड्रेटरल लाइक दिस वन लेट्स से, which is never square, okay? It is never square, all sides are different. Now you can use a very nice formula, like you can say s minus a, s minus b, s minus c, s minus d. Have you ever read or have you ever seen this formula? Okay, it is very different from the other formula. Okay, you may have seen s into s minus a, s minus b, and this is b, okay, and then s minus c. Okay, these things are very different from each other. Okay, now this thing it is like a second hero formula. It should be used for a quadrilateral, which is just inside. You can say inscribed quadrilateral. Now this formula, however, it is called hero formula, and it is used for a scalene triangle, which is a very important thing. Okay, everywhere there is scalene. When you calculate area a triangle, maybe in irregular shape. Okay, we will discuss that maybe in other lecture, because this time we are just you can say repeating the previous thing, so I'm just in hurry. Now again, next we have circle. Circle is important because we have we have, you can say, uh elementary structures. Okay, like maybe you have seen dooms. Okay, maybe you have seen cylindrical columns, maybe you have seen slabs, okay, which are circular, maybe for water tank, right? And there can be actually designs like, let's say this is the slab, and here we have curvature. Okay, so it means circle is everywhere, right? That's why it's important to know about circle. Let me just erase these things. Okay, and most of the student, even my students from the college, they don't know about area of the circle. I every time tease them. Okay, and those who correct the answer to the area of a square, I just give them 20 marks in practical. Okay, that's my wow with them. Okay, so area of a circle can be actually pi d squared divided by 4. Very simple thing. Now what is this d? Okay, it is actually, let's say here we have center. Okay, oops, here it is, we have circle, and here is the center. Now if you draw a line which is passing through the center and it touches the circumference or maybe circumference, okay, this line is known by the diameter. Okay, if you have that, then you can use pi d squared divided by 4. Now as you can see, here is the center. Okay, if you just divide this diameter by 2, it means we got radius. Like you can say, let's say if we have a circle, this is the center, and a line toward the circumference, that is just the radius then. Okay, you can use pi d squared divided by 4, or you can use pi r square, no problem. You can use both formulas. Also, there is another thing which is actually the parameter. Okay, or you can say the circumference. You can use pi d or maybe 2 pi r. Okay, and yeah, of course, you know about pi, which is 22 by 7. Are you guys familiar with this? 22 by 7. What is 22 by 7? Anyone, please?
3.4.
3.4.
It is
Yeah,
circumference.
3.4.
yeah,
Right,
it,
equation.
yeah, it is that thing, 3.14, blah, 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 blah. But what is 22? What is 7? I'm just asking about that thing.
Circumference divided by diameter.
Exactly, it is the ratio, okay, of circumference and the diameter. Now, this ratio is very important, okay? Let's say if we have, you can say the pi, it means the circumference by the diameter. Now, if you take any circle, the ratio should be 22 by 7 for any circle. If you determine its circumference and then divide it by the diameter of the same circle, you're gonna have the value of pi. Okay, I'm just moving ahead for an ellipse, and area of the ellipse can be actually pi AB. Now A is actually the major axis. Okay, an ellipse can be actually a 2D geometrical shape having two centers which are known by the foci. Okay, I'm not gonna go into geometry. This time, as you can see, we have pi AB. It means A is actually the major axis. You can call this major axis. And then B, that is the minor axis, like this one. Okay, if you can represent it over here. This is B, and this one, whose dog is barking. Next, we have a polygon. Okay, there are many structures. You can see this is pentagon. Okay, pentagon in United States. So this is pentagon. It is a regular pentagon. It can be different, like polygon. Maybe let's say this is hexagon. Okay, there can be nanogon, there can be octagon. Okay, it means the area of a polygon is going to be very simple. Okay, here is a trick. In books, there is a complicated formula. However, I'm gonna just show you a very simple formula. Let's say this is the center of the pentagon. Okay, now if you are able to draw a line from that center to where the, you can say, vertices maybe are the corners, okay, like this, so we can have a triangle. Now area of this triangle can be actually, let's say, if this is the height, okay, of the same triangle, and here we have the base. Okay, let me just mute this person. Who's he? So area of this polygon can be now, okay, if you just split this into more triangles like this, a triangle like this one. It means we have 1, 2, 3, 4, 5. We have 5 triangles, and area of the one triangle, you can say it can be 1/2, and then BH. Okay, for the second one, we can have area of the 1/2 and BH again. For the third one, we can have 1/2 BH, okay, and so on. 1/2 BH plus 1/2, and then BH for the fifth one. It means it is the total area of the polygon, but it is very long. Okay, nobody's gonna do it. Or maybe if you calculate area of a polygon, it's gonna take you maybe much time. Okay, that's why we can just reduce this formula into a short form. Okay, how? Let's just say if area of the triangle is the same, it means, as you can see, we have 1/2 and then BH. Okay, B can be the parameter of the same polygon. What do you say? It is the same thing. Okay, so I can say 1/2, and for B, it is summation of B. You can say 5 B's. We can add them. It means it is just the parameter of the same polygon. Okay, as you can see, H is common for all. So I'm gonna say H, which is perpendicular. It is just a short form of the formula. Okay, what you have to do is just to determine the parameter, and then just multiply that parameter with the height, so you can have the area of a polygon. Okay, very simple. All right. Okay, polygon AB. Okay, this is some mistake. It is AB is actually for the an ellipse. Okay, now next we have actually volume, but I think we missed about triangle. What do you say? Should I go for triangle? Now there can be actually many types of triangles. Maybe 6 types of triangle there are available. Okay, and we'll be just looking into each here are all types triangle. It is a very old video of mine on the same channel, Engineer Boy. Okay,
Sir,
so
can you stop it?
are you sure? What about now?
Show yes.
Okay, so triangle is very important, right? And I believe you guys are just familiar with it, because it is the same thing. You may have seen it. Okay, a 2D geometrical shape having 3 sides. Very simple. and it should be closed, okay? If I say there is a triangle like this one, let me just draw it. If this is, okay, this thing has three, you can say, sides, but it is never a triangle because it is open over here, okay? It is never closed. So triangle should be closed because it is 2D geometrical shape. All right. Now, let's say we have different types of triangles, okay? Some are based on sides, some are based on angles. Now, as you can see, we have scalene, then we have isosceles, equilateral, acute, right angle triangle, obtuse. I'm not going to waste my time with this because you should study these things, okay? I'll be just working an example. Let's say we have a right angle triangle. A right angle triangle is a triangle having one at least. Who's he? अलग बंदो माइक्रोफोन का अपने आप कर दो ना. So it is a right angle triangle, you can say. Now, a right angle triangle can be 1/2 base times perpendicular. Now, if you remember base times perpendicular, it was just area of a rectangle. If you remember, let's say this is base, this is perpendicular. Now, as you can see, a right angle triangle. Hello, are you guys with me?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so a right angle triangle is actually half of a rectangle. You can see it, right? That's why we can just, let's say, if we have area like base times perpendicular of a rectangle, so we can just divide that by 2 to have area of a right angle triangle. It's very simple, okay? All right, next. Now, it is also very important to know, if you have base and you don't have the perpendicular, okay, or if you have perpendicular and you don't have the base, then of course you can determine one of these from the hypotenuse, okay? Let me just explain it a little bit, okay? Let's say if we have a right angle triangle like this one, okay, and you have the hypotenuse, which is, let's say, 5, the perpendicular, which is, let's say, 4, but you don't have the base. And remember, in area, the right angle triangle's area can be 1/2 base times perpendicular. It means we need the base. That's why you can use the Pythagorean theorem, okay? Are you guys familiar with the Pythagorean theorem, which is actually c square
Yes,
equals
sir.
a square plus b square. Now c is known and we need b. It means we're gonna have to just make it, okay, or you can say a single thing which should be b on one side of the equation. It means we're gonna just bring this guy over, like c square minus a square should be b square, okay? We can also take square root just to remove the square. It means b is going to be now the square root c square, which is 5. It means 5 that is 25 minus 4, which is 4 4s are 16. Am I right? It means we're gonna have b, which should be 25 minus 16, and it is square root 9. It means we're gonna have 3. Okay, so this is how you can calculate the, you can say, base. Okay, if you have perpendicular and then if you have the hypotenuse. Now, most of the time, as you can see, you guys may be a little bit familiar with quantity surveying, and you may be just very bored why I'm teaching about area and volume. It is because I guarantee you, just to learn area and volume, okay, if you learn these two things, it means you have learned 50% of quantity survey. It's my challenge, because we have these two things, only these two things in quantity surveying. That's why I'm just focusing on these things, okay? And let's say we have an equilateral triangle, okay? It is a triangle with 3 sides equal to each other, and a very simple formula can be used, square root 3 by 4a square. A here is actually the side of the same triangle. Now, square root 3 by 4, that can be actually 0.433, okay? And a, that is actually the side of this triangle. So this formula can be used, and a derivation is also available on my channel. If you guys need to derive this formula, I can also carry this guy on, but I think it is not important, okay, in the same course. All right. And you can also actually use area of a right angle triangle. If you remember 1/2 A times H, if you have the perpendicular, okay, perpendicular, then of course you can just use this formula as well. No problem. All right, next we have the isosceles triangle. ठीक है, जिसमें of course two sides equal होते हैं एक दूसरे के and one base. Okay, so in order to determine area in a isosceles triangle, you can use of course the same thing which has been used for a right angle triangle, like maybe 1/2. We're gonna have base and then we will multiply that with the height. Okay, so we can have area. Now remember, most of the time you don't have the perpendicular. You have to just work out that. And you can just work out that by using a Pythagoras theorem, because you have the base, okay? You can take one side of the triangle, let's say this side. It means you have the base, which is 1/2 of the base, and then you have one side. It means you can just calculate this side, which is perpendicular, okay? And you can do that just by using the Pythagoras theorem. All right, next we have the scalene triangle, and this is very important because if you have irregular shape like this one, maybe a land, okay? Now, a land can be triangulated. Let's say I'm gonna triangulate this the same way like this, okay? This is called triangulation. Triangulations means just splitting or dividing the whole property into triangles. Now, as you can see, we have these triangles, and it is very likely impossible just to draw a right angle triangle, or maybe to draw an equilateral triangle, or maybe just to draw a square, maybe just to draw a rectangle, okay? It is likely very, you can say, impossible to draw regular shapes in in irregular land, you can say, okay? That's why whenever you just triangulate a land, it should be, each triangle should be scalene triangle. That's the reason a scalene triangle is very important, okay? So let's just determine area of a scalene triangle. And area of a scalene triangle can be actually कौन है ये बंदा? एहसान भाई म्यूट पे रखे यार इसको आप.
ओके सर.
ठीक है, तो स्केलेन ट्राइंगल के लिए आप क्या कर सकते हैं, आपने हीरो फार्मूला ही इस्तेमाल करना होगा. ठीक है, मैं पेन को जरा डालूं. तो हीरो फार्मूला which is actually just the square root of s into s minus a s minus b. If you remember, just few seconds ago, I mean few minutes ago, we had just discussed this thing. Okay, now s over here is actually the semi-perimeter. Perimeter mean just to add all sides. You can say a plus b plus c and just divide that by 2, so you can have the you can say semi-perimeter at the same triangle. Now put s over there, and a b c, those things are actually the sides of the triangle. Okay, and after doing some mathematics, you're gonna have the area of the scalene triangle. That's very simple thing. Okay, all right, moving ahead, and I'm gonna jump into the same slide. Okay, just the old one. Okay, here's a question in the chat.
Yes, sir.
If we can use Hero formula for isosceles triangle, of course you can use Hero formula for any type triangle, for right angle triangle, isosceles, equilateral, for a scalene, for all types triangles you can use it. Okay, Hero formula is very important and it gives 100% accurate value. Next we have volume. Let's just discuss it. And volume is actually the property of a where is it? Where is my pen? We're here. It is actually the property of a 3D geometrical shape. And area, it was just the property of 2D geometrical shape. So in order to determine volume, you're gonna have to learn only one formula. And that formula is gonna just, that is just enough for you to determine volume of any geometrical shape, okay? Maybe volume of a wall, a room, a foundation, that's enough for you. So volume should be actually the cross-sectional area, okay, or you can say area of the base times length of anything. Very simple formula, okay? So this is the basic formula and you should learn it. Now, let's just move ahead. The volume of a box or maybe cube, okay? Now, the cube can be rectangular as well according to AutoCAD, right? However, cube is something different in mathematics. Now, the volume of cube can be actually a cube, because all sides of a cube are just equal to each other. Let's say this is A, this one is A, this one is A. Now, cube, if I just draw a dotted line over here, okay, like this one, this is actually the base of the cube, okay? That side is actually A, this side is actually A. It means area of the base, okay? Area of the base is actually A times A. If you remember, some time ago, we have just learned it. Area of a square, right? And then we just multiplied that with its length or height, if you remember it from the previous slide, okay? And that side is also A. It means the volume of a cube or maybe box should be A times A times A, and we can simply write that by A cube. Very simple, right? Now, you also have to learn about the surface area. Why surface area is important? Because let's say if you have a wall like this one, it is a wall. Now, wall is actually a rectangular prism, or maybe it is a rectangular cube, or it is just a box according to AutoCAD. Okay. Now, each side is just plastered. We plaster each side and we just whitewash each side, right? It means we need the surface area of the same wall to just determine the cost of whitewashing, maybe the cost of painting, right? So it's really important. Next, we have slender, right? And volume of slender, it is also very important because in this form, you may have seen, you can say columns, pillars, piers, piles. You have seen those things. And in order to determine the quantity of pile, in order to determine the quantity of pier, okay, and then column, it is really important to know about the volume of a slender, because slender is all about these you can say structures, okay? And it is actually area of the base, okay? Area of the base. The base can be actually elliptical, it can be circular as well. So as you can see in the same formula, we have taken pi d squared divided by 4, which is actually area of the base, right? And then we can multiply that with the height. So we can have the volume of a slender. Now, if you have base is in ellipse, then you can use, of course, pi AB, if you remember. That's why I just covered that part, okay? The part of area. Now, the surface area, as you can see, let's say this is column and you need to, you can say, have some tiles on the same surface, okay? Tile work, maybe paint, maybe distemper, okay? So it means you need to determine the area or the surface area of the same slender, the same pile, maybe pier, okay? And that's gonna be actually pi d, which is actually the circumference of the base, because that is circular, and times the height, which is actually the surface area then. Now, if you see, we have pi r square. Pi r square, that is actually area of a circle. If you remember, times height, it means it is the volume of a slender. Just a few seconds ago, it's just been covered over there. Now, divided by 3, it means if you divide it by the 3, or the volume of a slender by 3, that means you got a cone, right? Now, volume of the cone should be 1/3 of the volume of a slender. Okay, very simple. Okay, let me just include another thing. You can say the surface area. I have messed it in the slide. Now the surface area can be actually this area, which is the perimeter of the base, which is pi d, right? And then we will multiply this perimeter with the height, but not with the height of the slender. Okay, we will just multiply that with this inclined height, and let's just say this is small h. Okay, so this is the surface area. And next we have the pyramid. It is pyramid or pyramid, no problem. Okay, so we have 1/3 area of the base times the height. It is the same thing as a cone, right? Over there we had area of the base times height. Over here we have the same thing, area of the base times height, and it is actually the volume of a cylinder, if you remember. However, 1/3 that is taken because it is just pyramid. Okay, so it is the volume of a pyramid. And next we have actually area and volume for the prism of cone or pyramid. This thing is very important, and most of the time it is little bit confusing. Okay, previously we just covered that the volume of this prism. Okay, prism of cone, have you ever seen it? Okay, let me just give you some example. Let's say, look at this pyramid. Okay, if I extend it a little bit like this, it means we are gonna have a column. Okay, this can be you can say isolated footing. If you're a little bit familiar with construction or RCC design. Okay, so this is isolated footing and it's everywhere. It means you have to determine the quantity of this thing. Okay, now in order to determine the quantity of this thing, you need to determine you need to just learn the formula for this thing, right? And let's say if we have prism of cone like this, right? This design is also available, okay, maybe in residential buildings. So it's really important. And a prism of cone, you guys may have seen that in form of, you can say, slump cone. Okay, have you seen that slump cone? Anyone?
Yes, sir.
Okay.
Workability के लिए इस्तेमाल की जाती है
Exactly, yes. Okay, so slump cone is a cone which is used to determine the workability of a fresh concrete, right? Okay, now in order to determine the volume or the quantity of a prism of cone, what the only formula and a single formula that is actually h by 3, and then we will multiply that with a1 plus a2. The formula is a little bit long, but I really like this formula. And then square root a1 a2. Okay, it is never confusing. Okay, now h, that is known, which is just the height. And remember, this is just the vertical height. Okay, it is never that inclined height, right? And a1, a2, these two are actually the ends areas. Let's say the top area, you can call that with a1, and then the bottom area, okay, let's say that is just a2. You can take them inversely, no problem, right? So this is how you can determine the volume of a prism of cone, or you can say the volume of a prism of pyramid. Okay, let me just have some explanation. Okay, little bit explanation so you guys can understand it very well. Okay, so as you can see, we have the volume, which is h by 3, and then we have a1 plus a2, and there we have a1 a2, right? Now a1, let's say this is the top area. Now the top, as you can see, that is actually you can say pi d squared divided by 4. Okay, and the bottom, let's say a2, that is the same thing as pi d squared divided by 4. You can also just keep that capital, and let's say d2. If this is an ellipse, okay, you can say elliptical, you can use, of course, pi ab. Now, as you can see, we're here, that base is just square. That's why you have to use a square for the bottom, and for the top, that is actually the same thing as a square. Okay, next, we will be just discussing about the the volume determination maybe for the dooms, okay, or maybe for arches.
सर ये सेकंड ईयर डब्ल्यू के बुक में भी है, क्वांटिटी के बुक में एग्जांपल है इसके ऊपर.
Okay, so you guys should check that, okay? And here is a chat. Sir, we will be needed previous and current recorded lectures after this class because I want to revise after class. Okay, we'll send that. Okay, वीडियो रिकॉर्डिंग से रिलेटेड एक प्रॉब्लम है मेरे साथ, क्योंकि हम बहुत सारे बातें करते हैं ऑनलाइन क्लास में, ठीक है? तो मैं अगर इस वीडियो को बगैर एडिट करके सेंड कर दूँ तो फिर मेरे ख्याल से ये अच्छा इंप्रेशन नहीं जाएगा, क्योंकि आप लोग शेयर कर सकते हो आगे अपने दोस्तों के साथ, और मुझे पता है आप लोग शेयर करते हो, ठीक है? तो इसी वजह से मैं थोड़ा बहुत इसको एडिट करता हूँ, और जितने भी हम आगे पीछे की बातें करते हैं उनको मैं रिमूव कर देता हूँ, ठीक है? तो ये सारा एडिटिंग इस पे काफ़ी टाइम लगता है, तो आप लोग प्लीज़ ना डायरेक्ट डिमांड ना करें वीडियो की। वीडियो एक दिन बाद आ सकती है, 2 दिन बाद आ सकती है, ठीक है? तो इसी वजह से प्लीज़ नेवर आस्क फॉर वीडियो ऑन द सेम डे और मे बी आफ्टर ए डे. Okay, next, let's just talk about one another thing, that is spare. Okay, are you guys familiar with spare? That is just the same thing as ball. ball नहीं होता इस तरह का ये, ठीक है? तो इसका क्या होगा? वॉल्यूम V equals we have 4/3 and then pi r cube. Okay, r, which is just the radius. Okay, let me change the color, and this is actually the radius. Okay, r. Now its surface area should be, you can say area, I'm gonna say S area. It means surface area. It should be pi r square, but we're gonna multiply the area of this. It is actually pi r square is actually area of the circle, if you remember. Okay, so it is actually the area, it's greater circle, right? And we can multiply that with 4. It means 4 times area of a circle is actually the surface area of a ball. Now, most of the time, many students ask why this sphere or ball is important. It is very important because if you remember, we're gonna have some dooms like this, okay? Maybe in masjids like this, okay? So as a quantity surveyor, you have to determine these things. However, the doom can be hollow. Now, in order to determine the PCC work or the RCC work for the same doom, it is really important for you to understand about the volume of sphere or maybe ball. Okay, now this is hollow. It means we're going to subtract this inside. Okay, very simple thing. Let's say if we have a maybe doom, okay, a semicircular doom, which is actually hollow inside. So what should be its volume? It is actually the same thing as like this one, but it is half. It means the you can say 4/3 pi r cube. This can be actually the external volume. You can say this ball, and we're gonna subtract the inside, right? It means we're gonna subtract 4/3 pi, and let's say small r cube. Okay, and I'm gonna write this formula again over here because we have something common like the volume. Okay, for a hollow ball should be actually what is common over here? It is 4/3 pi. You can say 4 pi by 3, and there we have actually r cube minus small r cube. Okay, so this is for a hollow. Now, as you can see, we have you can say semicircular doom. It means you can just divide this thing, the whole thing by 2. Very simple. However, it can be a little bit tricky if you have segmental, like this one. It is just segmental. And most of the time, we always face segmental dooms because they look beautiful and they are, you can say, architectural, right? And we will just discuss that maybe when you guys are not beginners and you are little bit familiar with quantity surveying, ठीक है? So इन चीज़ों को हम फिर बाद में इंशाल्लाह देख लेंगे। इस बंदे ने जो सवाल पूछा है, कोई और बंदा इसको रिपीट कर सकता है प्लीज, क्योंकि इस बंदे की वो माइक्रोफोन शायद काम नहीं कर रहा। मैं इस स्लाइड को शेयर कर देता हूँ, ये जो व्हाइट बोर्ड है ना, इस चीज को मैं शेयर कर देता हूँ और लोगों के साथ, ठीक है?
ठीक
सर
है
बार
सर।
का दोबारा लेके सर, बार का वो जो वॉल्यूम एरिया, ये डोम का पूरा रिपीट दे सर।
नहीं, मैं कह रहा हूँ ये जो स्लाइड है ना, ये अच्छा ये, तो इसको मैं शेयर कर सकता हूँ आप लोगों के साथ। यहाँ पे मेरे पास डाउनलोड का ऑप्शन है, मैं इसको पीडीएफ में सेव कर सकता हूँ, ठीक है? आप लोग फिर इसको डाउनलोड कर ले उस जगह से, क्या कहते हैं उसको, व्हाट्सएप ग्रुप से, ठीक है? तो यू गाइज आर गुड टू लीव
ठीक है
and
सर।
see you tomorrow. Let's just start it, okay? And the first thing which we will discuss in today's session is actually about dooms, because previously it was just remained, okay? And then secondly, we will just work with arches. And then lastly, we'll just determine the quantities of different materials, okay? Just in a, you can say, straight wall, okay, with foundation. All right, and tomorrow, then we will have a small project, okay? You can say detail estimate of a room, okay? Okay, you have to just mute your microphone, okay? So we don't have disturbance in our class. And I think we should skip this straight wall and foundation as well. I would like to have the rough cost estimate, okay, instead of that. What do you say? And we will have just an example, because there are two types of quantities, okay? You can say quantity survey, or you can say estimation. One is known by the rough cost estimate. The other one that is known by the detail estimate. So we will discuss these both things, but in the same video, we will just focus on the rough cost estimate, because this is just straightforward and takes little bit time, okay? However, detail estimate will take much time. Now, for a detail estimate, what's important is actually three things, okay? You must have drawings for the detail estimate, and secondly, you must have specifications, okay? Are you guys familiar with these things? And then thirdly, you must have market rates, okay? For that, you can use, of course, MRS, okay, which is just a schedule. You can say market rate schedule or material rate schedule, okay? It does not matter how you just abbreviate that, okay? So I think drawing is really important, because how can you determine PCC work, maybe RCC work or plaster, if you don't have drawings? Because drawings contains all the dimensions. Okay, let's say this is a wall, okay? And let's say we need the brickwork for the same wall, okay? Now, in order to determine the brickwork, we just multiply 13.5 with the volume of the same wall. So we can have the number of bricks, okay? It is just simple. But in order to determine the volume of the wall, we need its length, then the width, and its height, okay? And these things, okay, these three parameters can be determined or can be, okay, just, you can say noted from the drawings, okay? That's why drawing is just important. And then we have specifications, you can say. Why is specification important? Because from the drawing, let's say if we have, you can say elevation like this one, okay? This is just elevation of a room, you can say. Now, it is known that the width of the door is 3 feet and its height, let's say this is 7 feet. But in the drawing, it is never mentioned that what the door is made of. You can say, is it wooden door or it's aluminum door, okay? It is never shown in the drawing. This thing can be just determined or maybe just noted from the specifications, okay? And lastly, rates. Rate is very important for estimation, Because in order to determine the cost of the building, okay, you have to determine the rate or maybe the cost of a, you can say separate or elementary elements, you can say elements, okay, like maybe there can be different materials, cements, okay, that's not working, okay, cements, maybe bricks, blocks, etc., coarse aggregate, fine aggregate, okay. So you have to determine the rate of each separately, and then you have to just sum them. So you can have the cost of the total building. That's why rate is very important, okay. So let's move ahead. And if you remember previously, in the same session, we have covered something about area, and then we have covered many things about volume, okay. But one thing that is just remaining is actually about the dooms, okay. And this is a very important thing. You may have seen many dooms, okay, around your area, okay, maybe in masjids, maybe in mandars. Mandar, they may use actually something like this one, okay, like a cone or maybe pyramid, okay. However, in masjids, okay, we may have experienced dooms like this, okay, if you have seen, and maybe in different residential buildings, maybe in other buildings, okay. So it means that we have dooms, okay, in our structures. Then how can we determine the quantity of doom? Because in order to determine the quantity of doom, what we look for is actually, let's say this is a doom, okay, and let's say this is RCC doom, okay. It means there are almost 4, okay, let's say cement, and then fine aggregate, coarse aggregate, and then of course steel, okay. These 4 things are being used in the same doom. It means we have to determine these 3 materials, okay. Now in order to determine these 4 materials, sorry, we need the volume of the same doom, okay. It is very important. Now, you cannot determine the volume of a doom just by simple formula, okay? You have to do some, like maybe other steps, some mathematics, you can say, okay? Let's just consider from the basic a ball, you can say, like this one, okay? Because doom can be half of the ball, maybe it can be segmental, okay, segment, it can be half, okay, there are different types of the doom. Okay, now the volume of a ball, it is already just covered from the previous video. In the previous video, maybe in a class, it is actually 4/3 and pi r cube, okay. Now r is actually the radius from this point till that, okay. If I just change the color so you can see it, okay, this is the radius. All right. Now, as you can see, if the sphere or the ball, if it's hollow, then how can we determine its volume? It's hollow. Like maybe you can say, this is solid, this one. What if it is like maybe hollow? How can I represent it? Okay. Maybe let's say if we have half section like this one, okay, and let's say this section, the remaining one, this is solid, okay. So this is just half section. As you can see, this is hollow. Inside it is just, you can say, empty, okay. So then we can of course determine the same volume. You can say we're going to subtract the internal, okay, volume, the inside volume, like this red shaded, from the external one. So it means the spare volume, if it's, you can say, hollow, it must be 4/3, which is the same thing, okay, and then pi, and we will just subtract the inside radius, you can say, r cube minus small r cube, okay. Now the capital R, that is actually the radius for the external, you can say, surface, like that. And the small one, that is actually the radius for the internal, you can say, this guy, okay. Okay, it's simple. Any question? And further, the surface area must be, if you remember, 4 times pi r square, or maybe pi d square divided by 4, okay. All right, now next, as you can see, it is very complicated to determine the quantity of a segmental doom. Like maybe we have types of doom. Let's say this is a whole circle, and let's say we have just split it into two, okay, equally. It means this is circular doom, you can say, okay, semicircular. Now, what about segmental? Let's say this is a sphere, and segmental, okay, semicircular, it is very important. Most of the students don't understand it, okay? A semicircle is actually, you have to look to the chord, okay? Let's say if I have some doom like this, okay? And this is 10, it's, you can say chord, and then the rise, let's say this is 5. How can I confirm if it's semicircular or maybe if it's segmental? Okay, as you can see, this is 5 units. It means it is twice of the diameter. So this can be radius. Okay, it's simple. It means this is just semicircular. However, if here we have another doom, let's say this guy, okay, and let's say this is 10 feet maybe or 10 meter, and let's say the rise that is just only 1 feet. It means the circle may form the same way like this, okay? The chord is not just passing the same way like this one, okay, from the center, okay? It is just maybe above the center. So it means this is just segmental, right? And we have different formulas for both. Okay, let's just consider an example, okay? So you can understand it better. Let's say we have a doom like this. We will just have an example, okay? And I think this example is very good to understand this thing better. Let's say we have a doom like this one. And it is, you can say we are just informed that the thickness of the doom, that is just T, and let's say that is 6 inches. Okay, you can have the same example in MKS system. Maybe you can say in metric system. This time I'm taking inches, no problem. All right, and then let's say it is known that the span, okay, span is actually the distance between two supports. Okay, if you remember it, and that is, let's say 14 feet, and then we have actually the height of the same doom. Okay, and I'll take that internal. Let's say the internal height, that is 7 feet. Okay, what do you see? It means the doom is just semicircular because the rise of it is just, you can say, half of its span. It means the span can be the diameter. Okay, so we can say that is just the radius, okay, which is 7 feet. Now, if you remember, just a few seconds ago, we said a solid doom can be actually 4/3 pi r cubed. But this time it is, as you can see, hollow. It means we can use 4/3 and then pi, and we will just subtract the internal radius, you can say. Okay, you can say the capital R cube, you can say, and then minus the small r cube. Okay, to make things little bit easy. Okay, now the capital one, I'm gonna say the capital one can be, let's say this is the small one, the internal one, and for the external one, I'm gonna say this is, you can say, capital R, and that can be actually the small r, okay, plus the thickness, you can say this thickness, which is 6 inches, okay. So it means the capital R is now 7.5 feet because we have added 6 inches over there. Okay, so let's just do it. You can say the volume of the doom can be now 4/3, then pi. Remember, pi is just 22/7. Oops, what happened? 22/7. Okay, and then the capital R, that is just known, which is 7.5. Okay, we're gonna put that value over there, and there is remaining one thing, which is cube actually. Okay, we will subtract the internal, which is actually this thing, and that is only 7 cube. Okay, you have to do some mathematics. You can get the volume. Maybe if I use my calculator, let's say, okay, where's my mobile? Let's go here. Okay, it's almost 165 point maybe or 195, okay, cubic feet. Because all these dimensions are in inches, maybe in feet, okay? That's why the volume unit can be in cubic feet. Okay, it's very simple. There is nothing complicated over here. So this is how we can determine the volume of a dome which is semicircular. But the thing which is really challenging, that is actually a segmental dome. And most of the time, all the domes which I have seen, they are segmental. It means we have to learn about it. Okay, and how it works. Okay, let me just have a very simple formula you can say for a segmental doom. Okay, doom volume, and that is segmental. Now, okay, if we have a doom, let's say something like this. Now, segmental means something like this guy. It is segmental now. What do you say? So it means we have to determine the volume of this thing. And this should be actually, you can say the volume must be something like pi, and there is actually h square by 3. Okay. And then you have to multiply that with 3r and then subtract h again. Now, r is actually radius of the same dome. Okay. This can be like this thing. Okay. And the radius is actually from the center to the circumference, maybe like this. So this is the radius. Now h is actually the height of the same dome. Let me change the color to red. And this is actually from this center till the top, which is the rise of the, you can say, dome. And this is h. You can say the rise. Okay. And this is simple. And pi is pi. Okay. So you have to put only these two parameters in order to have the volume of a segmental dome. Is it clear? Hello, are you guys with me?
Yes, sir.
Okay. Any confusion? Any confusion you can ask?
सर कंफ्यूजन ये है कि इंग्लिश में लेक्चर है तो बस काफी मुश्किल आता है
अच्छा, मैं क्या करूँ, ये तो प्रॉब्लम है क्योंकि इसमें कुछ बंदों को नहीं आती ना, फिर उनको समझ नहीं आएगी मेरी
सर
उर्दू।
कुछ के लिए हम खैर कुर्बानी दे रहे हैं
नहीं ना, वो इंटरनेशनल स्टूडेंट्स है ना, तो उनको बिल्कुल समझ नहीं आएगी। मेरे ख्याल से कुछ है इसमें, क्या कहते, बांग्लादेश के है एक दो बंदे, और वो श्रीलंका के भी है ना बंदे, तो इसी वजह से उनको फिर नहीं आएगी समझ अगर मैं उर्दू बोलूँ। और मेरे ख्याल से मेरे ये जो इंग्लिश है ना, बड़ा सिंपल है, इसमें कोई कॉम्प्लिकेटेड वोकैबुलरीज मैंने कभी इस्तेमाल नहीं की। बस ही शी वाला वो इंग्लिश है, ठीक है, तो इतना मेरे ख्याल से कंफ्यूज ना हो। अच्छा सर, इट्स ओके, वकासुल्ला, व्हाट इज ओके इंग्लिश, ऑलराइट। नाउ नेक्स्ट, so this was actually for the solid segmental. Okay, now if we have a hollow, because dooms cannot be you can say solid, because that can be a heavy structure then, and supporting that can be like maybe something like impossible. Okay, so always dooms are, you can say, constructed, okay, are modeled, you can say hollow like this. So we will have an example so we can understand the problem. Okay, so this is segmental dome because the curvature may go like this. Okay, and it is something whose center is just, you can say, above the center of the ball, or maybe sphere like this. Okay, so this is now segmental. It means we should have different parameters now. Let's say we have the center over here. Okay, and the radius which is known, actually, let's say that is maybe I'm gonna take the internal one. Okay, let's say this one, and let's say that is 9.5. Okay, anything it can be. And now let's say the height, which is actually internal, this one, and let's say that is just only 4.5. Okay, my handwriting is very good, but because of the touch pen, it is a little bit complicated, okay, to handle these things. So just never challenge it. Now, all right, so we have these informations and we are asked to determine the volume of the same dome. Okay, this is not arch, okay? It is dome. Now, let's just calculate it. So the volume of the dome can be now, if you remember, for a solid, it was actually pi h square by 3, and then it was 3r minus h. Okay, but this time, as you can see, it is segmental as well as it is hollow. Okay, this formula is for segmental, but it was just solid, you can say. Now, अच्छा ये भी प्रॉब्लम है ना, क्वांटिटी में इतने ये मुश्किल चीजें इतने नहीं होती, ये कभी कभार आ जाती है। आप इस चीज को ना AutoCAD में मॉडल करके फिर AutoCAD में एक फंक्शनैलिटी है मास प्रॉपर्टीज की, ठीक है, आप उस कमांड को अप्लाई करके ना आपको मिल जाएगा इसकी जो वॉल्यूम है, ठीक है, इसका वॉल्यूम बड़े इजी तरीके से, इतने फार्मूले वगैरह ये कोई इस्तेमाल नहीं करते साइट पे, ठीक है, लेकिन मैं आप लोगों को समझा रहा हूँ ताकि आप लोगों को थोड़ा बहुत अंदाजा हो कि ये कहाँ से आता है, ठीक है। तो मैं क्या करूंगा अब, मैं ये जो इंटरनल है ना इसको मैं सब्ट्रैक्ट करूंगा एक्सटर्नल से, तो हमें ये वाला एरिया मिलेगा जो शेडेड है ब्लू में, ठीक है। तो सिंपल वॉल्यूम अब आ जाएगा हमारे पास। लेट्स से मैं कहता हूँ कि भाई ये जो रेडियस है ना, ये मैं इसको कहता हूँ कि भाई ये R2 है, ये वाला हाइट R2 है, ठीक है। ये जो एक्सटर्नल होगा मैं इसको R1 से चलो डिनोट कर देता हूँ, और इसका ये जो एक्सटर्नल रेडियस है मैं इसको सॉरी H1 को इसको H1 कर देते हैं, ठीक है, हाइट 1, ठीक है। ये वाला भी हाइट है, एक सेकंड में इसको थोड़ा हटा लूँ क्योंकि मुश्किल हो जाएगा। ऑलराइट, सो ये क्या बन गया भाई, ये बन गया H2, ठीक है, which is of course 4.5 feet, and this one that is actually H1, which is 5 feet. Okay, and here we have another radius which is R1, and that is going to be 10 feet because the thickness, okay, this thickness T is 6 inches. Okay, the slab, it means 6 inches slab. Now the volume can be actually pi h square divided by 3 and then 3r minus h. Okay, so this is for a solid, and I'm gonna say, let's say I'm gonna subtract the internal one from the external. So let's say this is h1, this is r1, this is h1. What do you say? Okay, we will just subtract the internal, okay, just in this form. Pi, I'm gonna say h2 square, right, and then divided by 3, and then 3 times, that is R1, but this time we can have R2 and minus H2. Is it clear? Okay, so after putting all these information in the same formula, okay, over here, you should get 147, okay, it's 45 maybe, 145.56 CFT. Okay, you have to try this and then give me the answer in you can say WhatsApp group. Okay, if you have this answer, it means you are correct. If you don't get this answer, it means you are wrong. You are doing something wrong, right? So this was about dooms, and now we will just switch into arches. Okay, you may have seen arches, maybe in verandas, maybe in bridges, okay, like these things. What do you say? Have you guys seen these things? So determining quantities of these arches can be a little bit challenging if you are not that good with volume calculation. Okay, and these dooms can be actually RCC dooms. These can be brickwork as well. Okay, now in order to determine other materials from RCC and then brickwork, maybe like you can say number of bricks, maybe cement, maybe fine aggregates or coarse aggregates if it's RCC. you have to determine the volume of the same arch. Okay, it means knowing about arch's volume is very important for a quantity surveyor, right? Okay, so we will start from the basic, and it's actually because arch can be part of a circle. Okay, let's say we have a circle like this one. Okay, and let me take only like this position, you can say. Okay, this part. Now this part, it is known by an arc. Okay, now if you make it 3D like this, okay, and if you consider it is a welding member, then this is just known by an arch. Okay, so these are just the same things. One is 2D, 1D, sorry, and one is just 3D. Okay, so but the mathematical calculation for both, like let's say if I need to determine the length of this arch, it is the same thing to determine the length of this arc. Okay, so it means there is nothing complicated here. Okay, now remember from the previous video, length of of a circle should be pi d, right? Or it should be 2 pi r. Okay, now if I have a center point over here and there is one radius and another radius like this, okay, radius is always same, remember. Now, if we have an angle over here, let's say that is alpha, you can also annotate that with theta, no problem. Now, if I need to determine this distance, okay, this distance should be actually this angle, okay, let's say this length should be alpha and times the radius. That's very simple, okay? But this alpha is now in radian. You can say it should be in radian. You can also convert this into degrees, okay? If you have this angle in degrees, then of course you can use pi r and alpha r and then pi, and then divide that by 180. Okay, this is how you convert radians into degrees. Okay, let me just have that. Okay, if you need to convert radians into degrees, you have to multiply radians, okay, by pi by 180. It's simple. And now if you have degrees and you want to convert that into, you can say radians, you can also do that. Okay, just plug and check in or maybe rearrange these things, and I think that is 180 by pi. Okay, so it means, like, let's say if we have that arc and we need to determine the length of an arc, and let's say we have theta over here in radius. Now the length of this arc should be pi, you can say theta, and then r and 180. Okay, this is the length. Okay, there is another method you can just work out the length. Okay, and that is very simple. You have to just divide this theta by 360, and then if you remember, the circumference are perimeter. Okay, just multiply that. Okay, there is also another method. If you need to determine the length of an arc or maybe arch, you can just divide the theta or maybe the central angle. This is known by the central angle, okay, by 360, and then multiply that with 2 pi r. What do you say? That's very simple. Okay, so moving ahead, and we will just have an example so we can understand the problem better. Okay, now let's say if we have a maybe something like that, like something oops, where is it? Like maybe if we have a circular arch over here, okay, and let's say this is just a brick wall. Then how can we determine the quantity of brickwork for the same arch? Okay, arch can be circular as well, okay? Never be confused with that. Okay, so how can we determine the quantity of this arch? If its diameter is known, let's say the diameter that is actually maybe 2 feet, okay, and the thickness of an arch, let's say that is 9 inches. Okay, And let's say the wall thickness, if this wall, if I can make it 3D like this and like this, the thickness of the wall, that is also 9 inches. Okay. So what should be the volume of the same arch? It is very circular. Okay. So there can be different methods. Okay. You can determine the central, let me just change the color. If you can determine the central length like this one, and then multiply that with the cross-sectional area, so you can have the volume of the same arch. It is one method. Another method is actually if you determine this shaded area, which is area of the ring. Okay, remember from the previous video, area of the ring. Just determine this area and then multiply it with the thickness of the wall. Okay, to have the volume. Okay, so let's just work it. It's never that complex. Okay. Okay, let me just know which method should I use. Anybody? Let's try with the center line method because I know you guys are just sleeping. This is the same thing. Okay, so we have to determine the center line. This is the center line. Okay, and you can also use this methodology for a क्या कहते हैं इसको well और कुआं, जिसको हम कुआं कहते हैं. ठीक है, the thing from which we pump water. Okay, or you can say the construction from which we pump the water. So इस I mean, अच्छा प्रॉब्लम ये मैं कभी कभी स्विच हो जाता हूँ उर्दू पे. तो if I need to determine the central length, okay, this is actually also a circle which should be pi d. Okay, now this diameter should not be 2 feet, because 2 feet, that is actually the internal diameter. Okay, we have to take the effective diameter, which is actually up to the center line. It means half of the weight can be added to one side and half of the weight can be taken to another side. It means we have to add one weight with the diameter, so we can have effective diameter. What do you say? Okay, it is very simple. It means the effective diameter can be now 2 feet plus the weight of the, you can say, arch, and that is 0.75, and that is just 9 inches. Okay, 9 inches means 0.75 feet. Okay, so the diameter is 2.75 feet. Just put that over here, pi and times 2.75. It means we have just the same thing, the length. Okay, and let me just calculate that. If I can have 2.75, that should be L, and that should be 8.63. Okay, now we have the length. Okay, so we can determine the quantity of the same arch. Very simple. Okay, I'm gonna make some room for myself. Okay, just by removing these things. Okay, so we can calculate. Right, now the volume of the same arch should be actually the area times the length. Now area, if you remember, the thickness of the wall, that is known, which is 9 inches, and that is actually 0.75. Okay, now the width, the width or maybe the breadth of the same arch, that is also 9 inches. Okay, so multiply that with 0.75 again times the length, and that is just 8.63. And if I'm not wrong, the volume should be 4.85 CFT. Okay, that's very simple. Any question? If there is no question, then I can move ahead, okay, to another problem.
Sir, it how can calculate by long wall and short wall method?
Okay, that topic is for tomorrow. Long wall, short wall method, we will discuss that thing tomorrow, okay? And we will have just a small project of a room, and we will just determine the complete quantity for that room. What do you say?
नो सर, ये जो आपका जो वेल का आपने जो सेंट्रल लाइन मेथड पे निकाला, तो ये लॉन्ग शॉर्ट वाल मेथड पे किस तरह निकालते?
हालांकि बंदे, ये सर्कुलर चीज में लंगवाल शटवाल कहाँ से आ गया? ये तो बस सर्कुलर है। लंगवाल शटवाल तो इसमें आएगा ना। ये चलो मैं कहता हूँ कि ये लंगवाल हो गया, ठीक है, और ये जो रिमेनिंग है ये वाला ये शॉर्ट वाल हो गया। तो लॉन्ग वाल शॉर्ट वाल ये तो लेंथ के बेस पे डिपेंड करता है ना। अब सर्कुलर चीज में तो सेंटर लाइन ही आएगा, समझ रहे हो आप?
सर तो वो शेप वाल में तो आता है ना।
नहीं, ओ शेप वाल में भी लॉन्ग वाल शॉर्ट वाल नहीं है। आप अगर ना, ये चलो ओ शेप वाल है, ठीक है, इस तरह का वाल है ना ओ शेप वाल, तो इसमें लॉन्ग वाल शॉर्ट वाल किधर से आ गया? कोई लॉन्ग वाल शॉर्ट वाल नहीं है। इसको आपने सेंटर लाइन के मेथड से ही सॉल्व कर देना होगा, अगर इसके वॉल्यूम को आपने फाइंड कर देना है, ठीक है।
ठीक है सर।
Okay, we will have just a complete room estimate. Okay, there we're gonna have cross section of the walls. We will have some deduction for the windows, doors, and just consider it is a small project. Okay, that will be just very simple, right? Okay, just coming back to the
ओके।
coming back to the arches. Okay, let's say we will have just an example of the same arch. This is not doom. Okay, it is an arch. And let's say if we have the span, and let's say that span is 10 feet, okay, then we have the rise, or maybe this guy, which is, I'm not gonna take it 5, because then the arch will be just a, or you can say semi circular arch, okay, and that is very simple, because from the previous one, let's say this one, if you just divide this video by 2, it means you are calculating the volume of semicircular arch. Okay, so we will not just waste our time calculating those things. Now this is just going to be segmental, right? And let's say this is 2 feet. Okay, any problem? All right. Now, in order to determine the length, okay, I'm gonna have the center line length for the same thing. Let's say this guy. Now, who's gonna tell me what should be the center line length for the same arch? Who's gonna tell me? Anyone?
सर इसकी थिकनेस कितनी है?
Let's say if we have thickness of the same arch, that is 6 inches.
नो, थिकनेस मींस विड्थ जो हमें सामने एलिवेशन से नजर आ रही है।
अच्छा, ये वाला,
जी
ये,
जी जी।
अच्छा चलो, ये भी 6 इंचेस है।
हाँ, तो फिर ये 2.25 हो जाएगी सेंट्रल लाइन।
ये वाला, let's say this is, oops, what's going on? Okay, let's say the up to center line, you mean this is going to be 2.5?
2.25 सर।
This is going to be 2.25?
जी सर।
Yes, because that is 3 inches. You are very good.
यस
Thank you. Now next, how do you calculate its length? Because
सर
we
सर आर्क के लेंथ होती है, आर्क के जो लेंथ है।
फार्मूला
look, there is something very, you can say, important that is just missing. Okay, if you see, the length should be pi r theta by 180. Is it okay? But this time we don't have the radius, we don't have the theta. So how can we calculate the length of the same arc? You can say arch. It is almost impossible. Okay, if we don't have these two things, the radius, okay, because the radius can be something over here, it is just segmental, so the center can be somewhere over here. Okay, this is the radius, this is the radius, and over here we need the theta. It means, okay, never be confused with this thing. All these things should be known. Okay, you can just look at in the drawings, because drawing is must. Okay, so theta must be known, the radius must be known. But I'm just challenging, okay? I'm just confusing you So I want you to be a little bit expert with mathematics as well, okay? Now, if you have something like this, some conditions, if you have the card, let's say this is L and let's say this is H, okay? Then of course, you're gonna calculate the radius of the same curvature, okay? And you can do that if you have the radius, you can say Pythagoras theorem. This is just Pythagoras theorem. You can calculate radius by this formula. Now, it's about the theta, okay? It means we have just calculated the radius for the same formula, which is this thing. The only thing which is remaining is actually the theta. And you can also just do that by some trigonometric ratios, sine, cos, tangent, okay? Are you guys familiar with those things, sine, cos, tangent?
Yes, sir.
One is sine, okay, that is not, one is sine theta, there is cos theta, and there is tangent, okay? And these are actually trigonometric ratios for right angle triangle. Let's say this is theta, and here we have the base, this is perpendicular, and here we have hypotenuse. So sine is actually the perpendicular by hypotenuse. You can say P by H. Okay, cos should be actually base by the hypotenuse, B by H, and tangent should be the ratio of perpendicular by base. Okay, everybody should know about these ratios in order to be a good quantity surveyor. Okay, so if we have radius, then of course we can determine the theta, and that is very easy, okay? As you can see, we have chord that is known, which is 10 feet, okay? And I think I should do that in separate. Like you can say, if we have something like this, if we have chord, this is 10. Here, the height that is known, it was, if I have not forgot, that is just 2, okay? This is 2, okay? Now, the radius that is known, okay, it is something, let's say, question mark. Okay, now, as you can see, we have the chord. Remember, the chord should be 2r sine theta by 2, okay? Do you remember this from the land surveying? From the curves chapter. Okay, it means there is theta, and we can just calculate this theta, okay, from this point. So now we have theta, and then we have the radius. It means we can calculate the length. And then if we have length, we will just multiply that with the width and then with the height, okay, to get the volume of the same arch. Is it clear?
सर ये आर कैलकुलेट करने के लिए इसके अंदर ए की वैल्यू क्या है?
ये 2 है ना? Sorry, ये a जो है ना, it's very important question. Okay, thank you very much. Okay, a is actually half of the span. That is a. Okay.
Okay.
And do you guys want me to derive this formula for you? And I think it is not just related. Okay, so derivation is not that good. I can even derive this formula for you if you don't understand, or if you don't agree with the same formula, okay, the radius formula. I can derive it. It is just Pythagoras theorem, okay?
Yes.
So never be confused with it. All right, next. Okay, so this was all about arches and dooms. And now next, we will just move ahead for the rough cast estimate of the building, okay? Okay, who is he? Sir, kindly use meters and centimeters, then mm instead of feet and inches. Okay. All right, let me just save this thing. Okay, the whiteboard, so we can have another whiteboard because our 20 slides are already been covered over here. Okay, is it clear?
Yes, sir.
Okay,
Yes, sir.
the rough cost estimate. We will just have an example, okay, so you guys can understand it better, okay? And the rough cost estimate that is just taken normally, okay? I'm just talking about the normal practice, okay? That is just taken based on the plant area. okay, of the building. So what you have to do is actually to determine the plinth area first of the building, okay, and then multiply it with the unit rate, okay, of construction. Unit rate of construction, you can say. So this is going to be you can say the cost. However, with the same cost, we then add the cost for electricity, maybe the cost for gas supply, maybe for the water supply, okay? So this is all about the rough cost estimate, okay? And let's see how we can do it. And normally for electricity, we take the cost to 8%, okay, for the building. And then for the water supply, / sanitary, that should also be actually maybe 4%, okay, for each. It means 8% for both. Now, for gas supply, the rough cost estimate should be, and actually this percentage, let's say 8%, this is actually 8% of the total cost, right? TC means total cost, okay? Now for the gas supply, this should be 4% of the total cost, right? It means total cost means just the cost of construction, right? And there we can have contingencies, and that should be 3% maybe, okay? And can be sometime 5%, okay? Now we will have an example so we can understand this problem better, okay? And let's say we are asked to determine the rough cost estimate. We are just asked the rough cost, rough cost estimate of a building whose plinth area, let's say the plinth area that is known, which is maybe anything. Okay, let's say 1,000 square feet. Okay. Now, cost of the construction that is also known, which is, you can say, the unit rate that is known. And let's say the unit rate is just 1,400 RS per square feet, okay, per square feet. That's so simple. It can be different, okay, because it depends on the materials which are being used in the construction of the building or structure, okay. So this time 1,400, it is just normally taken, okay, for normal residential buildings, okay. Now, another thing which is known, actually, we are asked to determine the rough cost estimate if we have electricity supply, that is 8%. If we have water supply and sanitation, 8%. Then we have gas supply, that is, let's say 4%. And we are asked to have contingencies, let's say 3%. And contractor, you can say profit, let's say that is maybe anything can be used over here, okay? Maybe like you can say 2%, maybe 5%, okay? It depends on the size of the project, okay? So for the contractor, we have only 2%. Okay, so now how can we determine the rough cost estimate of the same building if these are the informations? Okay, so let's move ahead to the solution, or you can say calculation. In calculation, the first thing which I'm going to calculate is actually the cost of construction. It is cost of construction. And that should be the plinth area times the unit cost, you can say, which is known, and that is 1,400. Okay. Now the area that is known, 1,000 times 1,400, that should be actually the rough cost estimate for the construction. You can say the construction cost, okay, which is just simple 1,400 and in thousands. Okay, so these are the RS. Now next, we have the let me have another slide, okay, so we can understand the problem better. So we have cost of construction, which was just calculated a few seconds ago, and that was 1400 and 000. Okay, RS. Now we will just calculate the cost for electricity. Okay, cost for electricity, and that is actually 8%. Okay, now 8%. We always just remove the percentage sign. Okay, and that's why we just divide that by 100 just to remove this thing. Okay, and times the total cost of construction, which is 1400 and 3 zeros. Okay, so you have to take 8% of the cost. Okay, and that is actually something like maybe 112000. Okay, if I'm not wrong. You can also confirm these videos, okay, little late after the class, okay, and then let me know in the WhatsApp group, okay. So we have cost of construction, one thing. Another thing is actually the cost for electricity. Now the cost for gas, okay, and that is actually 3%. 3% can be actually 0.03, okay. I'm not going to divide it by 100 because it is the same thing, okay, times the cost of construction, because it is 3% of the total cost of construction, okay. The gas supply can be 0.03 times 1400 and 000, and that should be 42,000 if I'm not wrong. Next, we have actually the contingencies, or maybe let's say water supply and sanitation. Now, water supply and sanitation, that percentage is the same for the is the, you can say, electricity, okay, which is 8%. So I can directly say 112000. This is going to be the RS for the water supply and sanitation. Okay. Now we're gonna have contingencies, but remember, before calculating the contingencies, we must add all these costs, you can say. Okay, like maybe this one plus this one plus this one plus this one. Okay, so adding all these things, let me just add them very quickly. Okay, like 112000 plus again 112000 plus that cost of construction. Okay, so we have total cost, which is actually 166, another 6, and 000 RS. Okay, another slide. I'm gonna have another slide. Now, the total cost, that is just actually now 1 point, wait a minute, it is 166 and 000 RS. Okay, now we will have contingencies. Okay, you can say 3%. So contingencies, if I'm not wrong, that spelling is actually something like this. Okay, that is 3% of this thing. Okay, 1666 and 000. Okay, so we have to take 3% of it. What do you say? It's very simple. Now contingencies are 49980. Okay, RS. So now the total cost, or you can say the grand cost, or you can say rough cost estimate, is now 1,666 000 plus 49,900. Okay, and then 80. And this is going to be actually, if I'm not wrong, this should be 1,715,980 rupees. Okay, so this is the rough cost estimate for 1,000, okay, square feet length area. Anybody have any question?
सर ये परसेंट का हमें कैसे पता चलेगा कि ये चीज इतने परसेंट पे काम?
ये वैसे डिपेंड करता है प्रोजेक्ट के नेचर पे, ठीक है। कुछ प्रोजेक्ट्स ऐसे होते हैं जिसमें इलेक्ट्रिसिटी की जो सप्लाई है ना, वो 8 से ज़्यादा भी हो सकती है, 9% भी हो सकता है, ठीक है। लेकिन ये चूंकि एस्टिमेशन है और फिर रफ कास्ट एस्टिमेट है, ये कभी भी 100% तो छोड़ो, ये 95% भी एक्यूरेट नहीं होता। इससे सिर्फ ये होता है कि आपको अंदाजा हो जाता है, ठीक है। तो नॉर्मली बेस्ड ऑन पास्ट प्रैक्टिस, अच्छा, हम इन परसेंटेज को ना यू नहीं डिसाइड करते कि भाई चलो 5% ले लो। बेस्ड ऑन पास्ट प्रैक्टिस हमने देखना होता है कि भाई चलो, अब आपके घर के नजदीक कोई कोई बिल्डिंग किसी ने अगर तामीर किया हो, है कोई बिल्डिंग?
यस सर।
अच्छा, तो आप उसके मालिक से पूछोगे कि भाई आपके टोटल खर्चा कितने आएगा, वो कहेगा कि भाई 20 लाख आ गया, ठीक है। फिर आप उससे पूछोगे भाई इलेक्ट्रिसिटी सप्लाई पे कितना खर्चा आएगा, वो उसने बताना होगा कि चलो 2 लाख आ गया। तो अब इस 2 लाख को आप परसेंटेज पे कन्वर्ट कर दो, आपके पास एक आइडिया हो जाएगा, कोई भी परसेंटेज आ जाएगा। तो ठीक है, इट्स ऑल अबाउट आइडिया इन पास्ट एक्सपीरियंस। ओके, तो ये परसेंटेज कभी स्टैटिक नहीं होता, ये डायनामिक होता है। डायनामिक मीन्स ये चेंज होता रहता है। अच्छा।
लेकिन इंग्लिश में है तो इंग्लिश में काफी चीजें हमसे मिस हो रही।
ये बात तो भाई,
खैर है, बाकियों से सर।
ये नहीं हो सकता क्योंकि इसमें स्टूडेंट्स है इंटरनेशनल, ठीक है। तो मुश्किल है। आप खैर ईद के बाद एक कवर सेशन है हमारा, मैं आपको उसमें फ्री में इनरोल कर दूंगा, फिर वो उर्दू में होगा इंशाल्लाह, ठीक है।
सर
तो
कोई मसला नहीं है सर।
alright, so in today's lecture, we will be just determining different materials for a room. Okay, we have this small project, you can say, and we will be just working the quantity of each material, and actually those material which can be used in the construction of a single room. Okay, I drew this drawing for you guys just maybe an hour ago, and as you can see, we will be just calculating from foundation till depth, you can say till the top, or maybe till the roof. Okay, as you can see, we have, you can say, PCC work, then we have the stone work, and there is about something about the floor. Okay, and then we have brickwork, as you can see, and then there is of course the roof. Okay, we got a 2D plan, and there we have the foundation plan, and then the front elevation. Now this section is actually about AA. You can see this, okay, if I select it. Okay, so let's move ahead. And in order to calculate all these materials using whiteboard, it will be a little bit complicated, okay? That's why I'm gonna use an Excel sheet, okay? Here, we got an Excel sheet. And normally, okay, people use it, okay? Doing calculation manually, that takes a lot of time, okay? So let's get started. And let's say if we have, the first thing which I'm gonna do is actually just to prepare an Excel sheet for myself. So I'm gonna say the material estimation for a, you can say for a room, okay, which is, you can say 12 by 12, 12 times 12 feet, okay. So this is the thing which I'm gonna do in the same video. And after this, if we got some time, we will have some analysis related to materials. Maybe we will analyze PCC work, okay, and then maybe some plaster work, and we will be just determining the quantity of cement, sand, and then the quantity of crushed stone and the water used in PCC work, maybe, okay. So we will just see if we can cover the room first. Okay, so material estimation, if you remember, we always just provide the serial number first, and then of course we have the numbers, okay, and there we got the length. If you remember, the quantity or maybe the volume of something can be the length times width times its, you can say, height, okay, and then times the number of members maybe, okay. So I'm gonna say the length, and then we have actually the breadth or width, you can say, and then we have the height, okay. And then we will just calculate the quantity, okay, and then remarks. Now, in order to determine the quantities for different materials, let me just make some, you can say, let me just give it, oops, just a minute, some borders, you can say. You can give them borders, okay, all borders, so we can see these things. And let me just select this, and I'll have this style, and then maybe time new Roma, And for this thing, as you can see, I'm gonna have little bit, let's say 14 or maybe 16, okay? And this is actually something, what's going on over here? Something is wrong over here, okay? So we have material estimation for a room 12 by 12 feet. Okay, now I'll just double click over here so we can see the writing. Okay, make sure you are a little bit familiar with Excel so you can have access to all the functionalities or maybe commands. Okay, all right, now let me just have AutoCAD open over here, and as you can see we have this 2D plan. If you see, is it clear? Please somebody can confirm it. Do you guys see it? The foundation plan or maybe the 2D plan?
यस सर सर एक सवाल है
Yes.
सर आज दोपहर को ज्वाइनिंग नहीं हुई थी क्लास में तो ऑटोकैड की तो ये जो अभी रूम का जो डायमेंशंस वगैरह हैं तो ये आज की क्लास में हुआ है
नहीं नहीं, ये हम करेंगे इंशाल्लाह बाद में। आज सिर्फ हमने वो लेयर्स को डिस्कस किया हुआ था, ठीक है?
ठीक है सर
Okay, so now there can be different methods in order to determine the quantities, like maybe the center line method, and there can be elementary methods. Okay, there can be long wall and short wall method. Okay, and I believe you guys have heard these terminologies before. Okay, so I'll be just using the long wall and short wall method. As you can see, I have already labeled the walls, okay, with wall A and then wall B. Okay, now let me just pick my pin so I can make sure that you guys understand about the long wall and short wall. Okay, let me just have maybe whiteboard. Okay, share. What do you mean by the long wall and short wall? Okay, the whiteboard is loading.
सर शो नहीं हो रहा
Wait a minute, it's loading. It's just loading.
यस सर
Yeah, it's done. Okay, so we have this whiteboard. And what do you mean by the long wall and short wall method? Okay, you guys can see the whiteboard?
यस सर
Okay, let's say we have a room like this one. Just ignore the you can say the style, maybe the drawing. It is not according to the scale. It is just NTS. NTS means not to scale. Now, this room is actually, let's say, 15 by 10 feet. Now, what do you mean by the long wall and short wall method? As you can see, we have two types of walls over here, okay, according to the length. And if I change the color, as you can see, let's say if I extend this line to this point and then that one, okay? So if I shade this one, like let's say, okay, I can just call this wall is long wall, okay? Because it is just lengthy with respect to the other one, okay? However, the remaining one, which is this one, this can be just termed as the short wall, okay? Because its length is just shorter, right? It means we have two short walls and then two long walls. In order to determine the length of the long wall, it is very important, okay, that you should have the thickness of the wall, maybe let's say 0.9 or maybe 9 inches only. Okay, now let's just see if we can determine the length of the long wall. Okay, so the length of the long wall, you can say length of long wall, or I'll just annotate this with LW, which means long wall. Okay, now as you can see, we have 15 feet over here, which is this distance. If you see, this is just 15 feet. Now for the long wall, we will just add the width of the wall for one side and the width of the wall for another side. Do you guys see it? Okay, it means the total length of the long wall is now 15 feet plus one wall width, which is actually 9 inches. Okay, and there we have another 9 inches for the other side. So this is the total length of the long wall. Okay, it can be anything, no problem. I'm not gonna label that. Now the short wall remains the same. Okay, the short wall is actually just the same thing. Okay, from this point till this point, and it is just 10 feet. Okay, so this is actually the basic concept of determining the lengths for the long wall or maybe short wall. Okay, I'll again jump into the AutoCAD and Excel.
सर ये 9 इंचेस की जो है तो ये इसमें एक्स्ट्रा ऐड होगी
Yeah, exactly. And that is just because, as you can see, we have extended the long wall's length, okay? Maybe we're here, this corner is also added, and that corner is also added. You can see that, okay? So that corner is actually 9 inches, and this one is also 9 inches. That's why we are adding 9 inches to both sides. Let's share the screen, okay? What about now?
Yes, sir, we can see it.
Okay, very good. Now, as you can see, we have serial number 1. It means, let's just say if we need to determine, okay, something we're here, I need another, you can say column, okay? So I can insert, we're here for the description, because description is very important, okay? And that is because of the analysis. Now, after the estimation or maybe determining the volumes, areas, we do analysis. So description is very important for that analysis. All right. Now, let's just say if we need to determine the earthwork, or maybe we call this in excavation. Okay. And you can also just type in ordinary soil, okay, just for the sake of the description, okay. You can also, if you are a little bit familiar, okay, I'll also teach the functions, okay, and how we work in Excel, okay, because becoming a quantity surveyor and you don't know about in Excel, it will be a little bit hard for you, okay. So select this cell, and as you can see, you can write the text, okay. So as you can see, now the text is just wrapped, and you see it, okay. It's good. All right. Now, excavation can be different, okay, for each wall. Okay. That's why, let me just say, if I need to determine excavation for wall A, and then I'll determine excavation for wall B. Because we have different, you can say, wall A, that is just the long wall. You can just make that short wall, does not matter. It depends on you. Okay. So let's say if this is short wall, no problem. And I'll call the wall B is long wall. Now this is square, okay? And square is something whose each side is just the same in length. So that's the reason we have some difficulties over here. Now, as you can see, if I need to determine wall A, and I have taken wall B is long wall, it means, let me just have something, wait a minute, okay? Let me just change the color to yellow, okay? Now let's see. I mean that the length of the long wall should be extended to this point and then this point, okay? And let me just make it little bit shady for you so you can see it better, okay? I can have shared. You guys can see it. What about you? What about this now? This is actually something, okay, let me just say, if I have annotation and then linear, we have 12 feet this guy and 9 inches this one and 9 inches to the other side. It means this is the total length of the long wall. Is it clear now?
Yes, sir.
सर एक सवाल है सर
Yes.
सर ये आउटर वॉल जो होती है फाउंडेशन पे भी यही अप्लाई होती है इनर साइड हमारे साथ 12 है ना
Yeah, this is just actually foundation can be you can say lengthy. Okay, we will increase
Okay.
the length of the foundation, because if you look to the foundation, as you can see, we have other steps, and those are actually just extended. Okay, as you can see, this represents the wall. However, this step is just extended. So I'm not just doing that yet, okay? I'm just showing that the actual length of the long wall is now 12 feet, 9 inches and 9 inches, which means 13.5 feet, okay, is a total. And you can confirm it, okay? Let's see, outside to outside. This is just 13.5. Okay, 13 feet, 6 inches means 13.5 feet. Because 6 inches can be converted if you divide that by 12, okay, into feet. Okay, just divide any inches by 12, that will be just converted into feet. Okay, this is just basic. You understand it, I guess. Okay, so it means the length of the long wall is 13.5. However, these both, okay, in number, I can say these both are 2 in number. That's just clear, okay? Everybody understand it. All right. However, the length of foundation is, as you can see, we are calculating excavation, so the length for foundation can be different. We are not gonna have 13.5 this time, okay? Now, what should be the length for the foundation? Okay, I'm just gonna say, let's say there is a nice method for that. Okay, just focus on the cross section over here. Okay, the width in the cross section, that is 13 inches. We will just subtract the width of the wall. We will just subtract the width of the wall from the width of the foundation. It means 13 inches minus 9 inches. And then we will add the length of the wall. So this is going to be the length of the foundation. Is that clear? I think that's
सर
clear.
दोबारा नो
No, sir.
सर रिपीट कर लें इसको
Okay, I'm trying to say that the width of the foundation, that is 13 inches. We will just subtract the width of the wall, which is 9 inches. You guys can see that. Okay, if that is small,
Yes,
let me just scale that. Is it clear now? So basically what I'm gonna say is the length of foundation is going to be the length of the wall, which is 13.5. If you remember, that is 13.5 feet. You remember that, okay? And we will just have summation of this ratio, okay? We will subtract the wall thickness from the thickness of the foundation, or maybe width of the foundation. Width of the foundation, that is 13 inches, okay? And we will just subtract 9 inches because that is just the width of the wall, okay? It means, okay, if I just simplify this, it means 13.5 feet minus 13 inches, okay, and minus 9 inches, that is actually just 4 inches, or maybe 4 inches means 0.334 feet. And this is actually addition. Okay, we will just add them, not subtraction. All right, it means 13.5 plus that thing, that is now 13.833. Okay, so we will take the foundation length is 13.833. How? Okay, let me just have a little bit detail over here so you guys can see it. Okay, let's just look to this thing little bit for a moment. Okay, this is the foundation plan, and I'm gonna extend a line from this point till that one. You can see that, okay, externally. So this is going to be the length of the foundation, and let's see if it is just the same thing or not. Okay, so we will have, you can see it, 13 feet and 10 inches. What do you mean by 10 inches? Let me just have calculator. So I'm going to just have 10 inches and let me just divide that by 12. And that is actually 0.833. Now I'll just add 13 feet, okay, plus 13. It means we have 13.833, okay? So this is going to be the length of the foundation for the same wall, for the long wall, you can say, okay? If you don't understand what's going on, so I can switch into the whiteboard. What do you guys say? Okay, should I switch to the whiteboard?
Yes, sir.
Okay, let's see what's going on in the whiteboard. Okay, here is the whiteboard. And let me just have an example over here. The weight of the foundation, okay? Let's say we have a cross section like this for the wall, okay? And let's say this is maybe 60 centimeter. And let's say the weight of this wall is 30 centimeters, okay? Now we have the, maybe the map like this, maybe the drawing like this, okay? And as you can see, this is the long wall. You can see that. That is the long wall, okay? Now, the length of the long wall, we have already determined that is just 13.5 feet. We have already determined that, let's say. Now, the length of the foundation, as you can see, the foundation can be for the same wall. If I change the color, just focus on the red color, okay? The foundation for the same wall can be just in this form, okay? It means we have increased the length for the foundation. How much are we increasing that? That's the point, okay? That is actually just this step, and for the other side, we have just added these 2 steps. And those steps can be determined if you subtract the wall thickness from the width of the foundation. Is it clear now? I have taken these things in centimeters, okay? So that's why this is the reason you guys don't understand. Let me just have the length of the wall in other units as well, okay? Let's say the length of the wall, that is just 3 meters. Oh, okay, just a minute, 3 meters, okay? Now, in order to determine the wait a minute, just a minute. Let's say if we have a straight wall, what do you say about this thing now? If we have a straight wall and the length of the straight wall is 3 meters, okay? And we have a cross section of the same wall, and let's say the cross section that is just, let's say 60 centimeters wide, and the thickness of the wall, let's say this is just 20 centimeter, okay? Now the weight of the you can say foundation, that is 60 centimeter. Okay, we have another color, and let's say the foundation length can be just in this form, okay? Now this thing is actually just this thing. You can say the wall in the section. This is the wall, and here this is the wall. Okay, this thing actually represents the first step, and for the another step, you can say the bottom one. Let's say I'm gonna draw another you can say line like this one. Now we have actually the length of the foundation, which is just this thing. Okay, so that should be actually the length of the wall, which is 3 meters, plus the you can say the factor, which I have is actually 60 centimeters. You can say the width of the foundation, that is 0.6, and we will subtract the thickness of the wall, which is 0.20. Okay, it means this is going to be the length of the foundation. It's very simple. Now 3 plus just 60 minus 20, that is actually 40 centimeters. Okay, so we can say 0.4, and that is going to be now 3.40 meters. So this is going to be the length of the foundation, okay, which is actually just from this point till all the way to the end. What do you say now? Are you guys okay with that? If you guys
Yes,
don't
sir.
understand, if you don't understand, I can even draw this thing in AutoCAD in 3D model. But I think you guys are now clear.
Yes, sir.
Okay, good. Now, let me just again jump into the AutoCAD and then Excel. So in the just focus on the Excel sheet, okay? Now, the width or the breadth of the foundation, okay? You can see that in the same drawing, that is 13 inches, okay? Now, you have to divide that 13 inches by 12 inches to have 1.083 feet, okay, is the width. Now the height of the foundation, okay, where do we excavate and how do we excavate? Can anybody explain that? Actually, you have to look to the ground level, okay? It depends on the ground level. We always dig below the ground level. So how much below are we digging? That's actually the depth of the foundation. And you have to look to the ground level. Look at that. That is just the ground level, okay? You can see GL means ground level. And this is actually the same line like this red one. So we have to just count all the depths below this line. That is 15 inches, and another one that is actually 3 inches. 15 plus 3 inches, that means 18 inches. 18 inches is just actually 1.5 feet. That's simple, I think.
Right.
So that is just the depth of the foundation. Now the quantity, if you remember, okay, that's why we have just wasted our 2 classes on the volume and area calculation. Now here the quantity is actually the volume. And in volume, it means the length times the width times the height. That's going to be the quantity or maybe the volume, okay? So you have to apply a formula, like maybe this thing, okay? We will just, you can say, multiply this with the breadth times the length times the number of the walls, okay? And press enter. Okay, that is 44.94. Now, the quantity can be just in CFT or maybe, okay, I should have another column over here for the unit. So the quantity is now in CFT, okay? In remarks, we can say that, let's say if we have 13, okay, that is 13.833. So how that comes? It means that is just from the, let's say 13.833, okay? That is it just actually from the same thing is 13.5 plus we have just subtracted the you can say weight of the wall from the foundation's weight, okay? Now the foundation's weight, that is just 13 inches, okay? What do you mean by 13 inches? It means just, you can say 1.083 feet, okay? And we have just subtracted 9 inches from that. So this is just remass, okay? You can understand that if something is wrong, like maybe if you're confused with 13.833, so this is the same thing as this one, okay? Now, we will actually decrease the length of the short wall. Oops, wait a minute. We have calculated long wall, okay? So that is just for the below one. It was for the long wall, if you remember, guys, okay? Now, we will calculate the short wall's length. Okay, let's again jump into the AutoCAD. Look at that, okay? If we have long wall, let me just copy this thing again from that point till this point. Now the short walls, if I can just see the short wall length, let me just erase these things. The short wall remains the same as 12 feet. As you can see, this remains 12 feet because from that point, let me just have some dimensions and then linear from this point, maybe you can say till that point, it is the same thing, okay, 12 feet. However, the foundation length should be decreased because some parts of the short wall are already taken over there, okay? How that works? Let me show you. We're here, okay? Let me just erase this thing, and the center line so you guys can understand the problem better. Now, if you see, if I just need to draw a rectangle from this point all the way like maybe till this point, okay? And let me just, as you can see, some parts like maybe this part was just included in the short wall, if you remember. However, in excavation that is already taken, you can see the yellow border, okay? This point is already taken. Similarly, this point can be taken to the other side. It means this time we will be just subtracting the you can say that ratio. Like in the previous thing, you can see this thing, okay? This time we will be subtracting, not adding with the length of the wall, okay? Like let's just see how it works, okay? So the breadth, that is the same thing, okay, for both. So I can just copy that and paste it over there, okay? The height is same for both because foundation can be just the same height, the same width for both walls, okay? However, the length can be changed. And how? Let's just see how it's going to be changed, okay? So the length of this thing can be actually, we will have to subtract 9 inches, which is the weight of the wall, from 13 inches, which is the weight of the foundation. That's clear. We will just subtract this thing is this one. However, this time, as you can see, we have addition over here. Instead of that, we will have subtraction, okay? And this is actually 12 feet, if you remember. It was just 12 feet is the short wall. So what should be the length of the short wall's foundation now? If we just do the same thing. And let me have a whiteboard so you guys can understand this thing a little bit more. Let's say If we have the same, you can say wall, you can say the short wall, or let me just draw the same drawing again over here. Okay, so for the foundation, I'll change the color. Now, for the long wall, the foundation was just the same thing like this, if you see. Okay, for the other side, it was just the same thing like this. Now, short wall, the length of short wall was just, you can say from this point till that point, and it was only, you can say 12 feet. Okay. However, we cannot take 12 feet as the foundation length because some parts, like you can say this part is already taken with the, you can say long wall. What do you say? These parts are already taken with the long wall. Okay. So we have to subtract these parts. It means the length should be now 12 feet minus that thing, if you remember. What we have done is actually that was 13 inches, and here this length, it was, sorry, the weight that was 9 inches, okay? So we will subtract that 9 inches from 13 inches. Okay, this is clear, I think. Is it clear now?
Yes, sir.
Okay, so we have 12 minus that ratio. Now the length should be 11.667 feet for the short wall. Now I'm again going to share the screen, which is this thing.
Yes, sir.
So the length of the short wall, that is just 11.667, if you remember. Okay. Now the quantity can be the same thing. Okay. We can just copy that formula, okay, just by Control C, and we will just paste it over there as a special, maybe as a form. Oops, sorry. We can just paste a formula as well, but no problem. Let's have the formula again. Maybe this times the length, okay, times the width, and times the height. Now the height cell, that is just hidden because of those formulas, so I can specify that by the name, okay? As you can see, the column is F, and the row, that is 4, so I can say F4, and I'll close the bracket. Now the total excavation is going to be, okay, we have total excavation, and that should be actually the summation of the above two. So we can just select with extra cell and just click this summation. As you can see, we have 82, okay, CFT.
Yes, sir.
So we have calculated the excavation. Now the other things, those are very simple. Very simple if you have learned about the excavation, okay? Next, we have actually number 2, and that's going to be, just a minute, that's going to be this PCC work. As you can see, we have PCC work, and that is 3 inches thick, if you see that, this one, okay? So it means PCC work in foundation, and that is, let me just have some correction, maybe wrapping. Okay, we have PCC work and foundation, and let's say that is 1:4:8. Now it is the same thing. Okay, we will have to determine for the long wall and then for the short wall. Okay, let's say first I'm gonna take long wall, and then we're gonna have short walls. Okay, now long wall, those are 2, short walls are also 2. The length of the long wall, if you remember, it is the same thing as that one, okay? The length is just the same. The width is just the same. The height is just difference, okay? There is a difference in the height, but just a minute, I'm gonna show you that, how that is just difference. All right, now look at this point, okay? The weight of the foundation is the same as the weight of the PCC work. Is that clear? You can see that, okay? This is the PCC work, and the weight of the foundation is 13 inches. So the PCC work, that is also 13 inches wide. However, the PCC work is just 3 inches, but the foundation, that was just, you can say 18 inches, which is just 15 inches plus 3 inches. Okay, so that is only 3 inches. It means the PCC work should be 0.25, okay, and 0.25 for the short wall as well. Okay, and here we have to just use the formula. Okay, I'm just gonna have the formula. Okay, let me just copy this cell and here I'm going to paste it. Okay. So these 4 things, okay. If you are confused, if they are not correct, so you can just double click, and as you can see, all the cells are just selected. It means the formula is okay. Now you have to just drag this formula to the wall A, just like that. Okay. So this is now the PCC work in the foundation. Okay. We have to calculate the total PCC work in the foundation, and just by selecting an extra cell, you can say, and that is 13.8 CFT. Now, what do you mean by these things? Okay, like 82 CFT is excavation, 13.8 CFT is PCC work. Okay, this is just like you can say nothing important. It's very important because in estimation or quantity surveying, we do calculate the cost of the project. Okay, how the cost of the project can be calculated? Okay, because of the materials, because of the cost of the materials. Now, as you can see, the total PCC, that is 13.8. It means there are cement in this 13.8, there are sand, there are coarse aggregate, okay, water are used in the same PCC work. So we have to use analysis and just determine those things, cement, sand, crushed stone, okay, from 13.8. Is that okay? Now, about excavation, that is 82 CFT. What do you mean by this? Okay. For excavation, of course, we need labor, maybe equipment. Okay. And labor and equipment, they actually cost us. Okay. Because labor do not work for free. You have to pay them. Okay. So those all things are just included in the cost of the project. So before we have to calculate all these things the same way in terms of volume, in terms of area, okay, in terms of number. Now, it is also important how many labor should we hire for the same excavation work? That is a very good question, okay? And there is actually a special table for that. I'll share it with you, okay? When we are just determining the you can say, we are doing analysis for the same PCC or maybe excavation, okay? All right, now above this, as you can see, we have stonework, right? So number 3, we have stonework in Excel, and I'm gonna say stonework in cement mortar, and that mortar is, let's say, 1:3, and I can even wrap the text. Now, again, I'll be just calculating all these things, okay? So I can even just copy them because of this similarity, okay? Everything are just similar over here. So I can copy those things, okay? And let me just paste them maybe like over here, okay? For the long wall, for the short wall, only the thickness may be changed, right? And that is because, as you can see, just look at over here. The foundation width or thickness maybe, okay, that is just the same as the foundation's width over here, okay? I mean, the weight of the stonework, that is just the same thing as the foundation width, 13 inches over here and 13 inches for the stonework, right? It means if the data is just the same, it means the length is going to be the same, the width is going to be the same, only the height is going to be different, which is actually 15 inches and 12 inches. What do you say?
सर एक दफा
सर
रिपीट
ये
करें.
Okay. Okay. Just look at this thing, okay? The linear, and as you can see, from this point till that point, we have the stonework, which is 2 feet and 2 inches. And as you can see, the width of this thing from that point to that point, that is actually 1 feet and 1 inches width, which means 13 inches. Okay, so it means the weight of the stonework is just the same thing as the weight of the foundation. The only thing which is different is actually the height of the stonework. Okay, this is the height, and which is just shown over here, that is 12 inches and 15 inches. However, as you can see, DPC is also included over there in the 12 inches, okay? So we have to subtract 1 inches DPC. You can see that DPC is 1 inches. It means the height of the foundation, I'm sorry, the height of the stonework is now 15 inches and 11 inches. So DPC
सर वो तो
is
12 इंचेस में नहीं आएगा ना, वो माइनस करेंगे हम.
that's what I'm saying, that we have to take 11 inches, like maybe 15 inches plus 11 inches. That is just 26 inches. You have to divide that by 12 to have the height in feet. It's very simple. And that is going to be just, you can say 2.1667, okay, for both. And the formula was just pre-applied. So this is 64 and 54 as the stonework, okay? And this is actually the summation in CFT. So we have stonework is, you can say that is how much? It is 119.673 CFT, okay? Now from this stonework, further we have to just determine the, maybe as you can see, this is in cement mortar, okay? So it means there is sand, there is cement in the same stonework, okay? But this is not our approach this time. That will be done very, very late, okay? Number 4, and that is actually the DPC work, okay? So I have to just copy these things, right? If you don't mind, I have to copy these things and I'll just rename them, okay, with TPC. And that is just 1 inch thick TPC. And maybe the TPC can be concrete DPC. Okay, you can also mention that. Concrete DPC. You can also mention the ratio. The ratio is, let's say, 1:4. Now, for the long wall, for the short wall, it is just the same thing, okay? As you can see, the TPC is over here, over there. And on the, if you just, let me just delete this thing, okay? So, okay, we don't have to delete. As you can see, this yellow represents, let's say, the DPC for the long wall. And over here, this represents the DPC for the long wall again. However, the DPC for the short wall can be this thing, okay? Let me just change the color and let's just draw a rectangle so you guys can see it. You can see it maybe to green. Okay, so this green rectangle represents actually the DPC for the short wall. And that should be actually maybe 12 feet, okay? Now, the long walls, those are 2 in number. The short walls, those are 2 in number, right? However, if you look to the same thing, the width of the DPC, that is just the same thing as the width of the foundation or maybe the width of the stonework. It means there should not be any changes in the length, okay, for the long wall and for the short wall. However, if you see the thickness of the wall, that is just, you can say, different from the thickness of the foundation. That means while calculating the brickwork in the same wall, the length for the long wall and short wall will be different from the length of all these things. So let's see, right? However, as you can see, the thickness should be just removed. What do you guys say? Because DPC is always calculated in terms of area, okay? We don't calculate DPC in terms of volume, okay? It is calculated in terms of area, and that is because the thickness of DPC is always very minimum value, okay? We have to just change the formula because one column is just been removed. Okay, again, over here, we will subtract the last column, okay? Now, this is going to be SFT, or you can say square feet. So this is just the quantity of DPC. Now, we will just move ahead for the quantity of the brickwork, okay? Let's say number 5, and let's say that is brickwork superstructure. SS means superstructure. Superstructure means the structure which is just above the plinth level, okay? And let's say that is in ratio 1:3. Now, there is actually long wall and short wall. So let me just copy and paste them as well. Now, long walls are 2, short walls are 2. That is just clear, okay? You can see it is clear. These 2 yellow are, you can say, long walls, and the short walls are just the remaining, like maybe the short walls are wall A, okay? This one, and on the right-hand side, there's also a wall A, you can say. Now, the length this time is going to be different, which was already been calculated. If you guys remember, maybe, okay? We have done that. You can see that, okay? So let me just use maybe the AutoCAD so you guys can see it. I'm gonna go to the annotate, and here is linear. Now, the yellow portion represents the long wall, and that is 13 feet and 6 inches. Okay. Here, the green, that is actually short wall, that is 12 feet. You can see that. Okay. So 13.5 for the long, and for the short, that is only 12, which never changes. Okay. Now, the thickness of the wall, that is just shown, okay, maybe in the drawing. This is a brickwork, okay, maybe 9 inches. It is not just annotated over here. Let me just check if it's 9 inches. Okay, it's 9 inches. Pretty cool. Okay, so that's going to be 0.75. 9 inches means 0.75, okay? Is that clear? Now, the height. Let's just check if the height is over here. As you can see, it is 11 feet. Okay, so I'm gonna have height of the brickwork. This is, as you can see, a brick wall. So the height is 11 feet. Okay, again, let me just put those videos over here. 11 feet and 11 feet. Now we have to just copy that formula and paste it over here. Okay. And you can see this is the same thing as brickwork. I'm gonna drag that down. Okay, and let's just have total brickwork. BW means brickwork. I'm gonna have extra column over there and the summation. So this is in CFT, right? I'm gonna add the other things, maybe like borders to the other cells. So we have calculated almost 5 materials. Okay. Next, we have actually the maybe you can say the roof. Okay, let's just calculate the roof, right? Number 6, and that is actually RCC slab maybe. Okay, and let's say the RCC that is 1 to 4. Is that clear? Now the RCC slab is only 1 because it is just a single room, right? Now the length of the RCC, that should be actually, if you see, that is just extended. You can say 1 feet is just the chajja or maybe extension to one side and another side. Okay, and this is actually the length, which is 12 feet. And as you can see, it is square. Okay, it means the size or maybe the both sides should be the same. You can say breadth and width. Okay, let me just have dimension, and as you can see, if I just check it over here from this point till that point, that is actually 15 feet and 6 inches. And how? Okay, let me just show you how it works. As you can see, we have 12 feet over here. Okay, 12 feet. So for both sides, I'm gonna add 9 inches, okay, for one side and 9 inches for another side, because the wall thickness is 9 inch. Okay, as you can see, 1 feet for one side and 1 feet for another side is chajja or maybe extension. Okay, so 12 feet and 1 feet and 1 feet. Okay, it means 2 feet addition. Okay, for the chajja, that becomes 14 feet. Okay, and 9 inches for one side and 9 inches for another side, it becomes actually 9 and 9, that is actually 18 or maybe 1.5 feet. Okay, so 14 feet plus 1.5 feet, that becomes actually 15 feet and 6 inches. Okay, so this is going to be the length of the RCC slab. Okay, that is 15.5, and the width is going to be 15.5 because this is just square. Now the height is 6 inches. Oops, it is only 5 inches, I think. Okay, it's written over here. Okay, that is just 5 inches. So you have to just divide that 5 by 12 in order to have that in, you can say, feet. And that is actually 0. Maybe 416. We have to copy the formula. That is 99. It's a CFT, sorry. It is CFT because this is maybe you can say RCC work, okay, in terms of volume. Okay, so slab is done. Now the floor is remaining. As you can see, we have floor over here.
सर इसमें अगर आपने हाइट ली है तो डीपीसी में क्यों नहीं ली 1 इंच?
Because DPC, the height of DPC, that is very minimum, okay? While we analyze these things, maybe in the analysis, okay, you will learn that thing over there. In the analysis, we will convert this DPC's area into volume. That time, actually, we will multiply the thickness of the DPC with the area of DPC, so we can have the volume of DPC.
Okay.
So in the analysis, we will actually have consideration for the thickness of the DPC. This time we are just ignoring the thickness of DPC, okay? Very simple thing. Okay, two things are remaining, just the floor and then the plaster work, okay? And I think an hour is just completed, so we will just continue this thing from this point. Are you guys agree?
Yes, sir.
Allah Hafiz. See you tomorrow,
Okay.
inshallah.
See you tomorrow.
Tomorrow is actually just a minute. The class will be morning time, okay? Chalo, you are good to leave the class. See you inshallah tomorrow. Allah Hafiz.
Inshallah.
Okay, so I think we have changed the schedule. That's why we have few participants. Okay, it doesn't matter. They may watch the video later. Okay. Now, if you remember previously, in the same session, we have determined some quantities of different materials, okay? And you can say excavation, PCC work, brickwork, okay, concrete work. However, in brickwork, as you can see, the total brickwork that is 420 CFT, okay? This is actually the total. We have not subtracted or deducted the quantity for door, or you can say the volume of the window, okay? So it's really important to subtract those things. Now I'm going to delete this row, okay? And I'll say deduction, okay, for different elements. You can say deduction for window and doors, okay? Or we can, let's say we have deduction for window first, and then we will have deduction for doors, okay? There can be ventilators and many more things. So you have to deduct the volume of everything, okay? That have just, you can say, covered some space in the wall, okay? So we have deduction for window, and let me just insert another row. So we can have deduction for the deduction or door, okay? Now in the same drawing, as you can see, we do not have, you guys can see the screen, okay?
Yes, sir.
Okay, so we have only two things, okay? You can see, you can confirm that from the 2D plan, from the section, and even from the front elevation, okay? We have only door and window. So we will have deduction for those two things. And here I'm going to insert another tab. Oops, sorry, just here maybe another tab, and I'll say total deduction. And then after total deduction, we will have to determine the net quantity of the brickwork, okay? You can say net brickwork. So it's going to be very simple, okay? All right. Now, as you can see, the deduction for a door, we have only one door. So in the number column, we will have only one. Now the length of the door, okay, it can be, you can type BI in the command bar. It must be shown in the drawing. However, we do not have detailed drawing, so we can just confirm that from here. It is 3 feet and 6 inches, okay? So for a door, we can type 3.5, okay? And then the width, the width of the door can be, you can say, equal to the width of the wall, okay? Because it is just the same thing. So we can just drag that video below. Now the height of the door, now if you remember, there must be some legends for the doors, windows, okay? So you can confirm the dimensions from there, okay? Legends means some tables, okay? Like you can say door 1, door 2, there can be different size, okay? So you can confirm that from the legends. This time you do not have legends, so I'm just using this AutoCAD, okay? Let's see what's the height of the door. I can just see I can confirm that by using DI and specify the height. You can see this is 7 feet, okay? So I would say that the height is just 7. Now I can drag the formula so we can see the quantity. Okay, this is deduction. It means 18 CFT will be deducted from the total brickwork. Okay, now deduction per window. Window is only one. If you have multiple windows, you can put the video for that. Okay, now the size of the window, as you can see that from the plan and even from the ledgers. Okay, it is just 6 feet. Okay, this is the length, so 6 feet. Width must be the same as the width of the wall and the height. Okay, let's just see. We do not have height or legends, so AutoCAD can help us. DI, and let's click this point and that one. You can see in the bottom that is just 4 feet and 6 inches. Okay, so I can just type 4.5, and we will just use the same formula for the same thing. Okay, it is just actually the multiplication of these 4 columns. Okay, now we can determine the total deduction. Okay, this is actually the total deduction. Okay, we can use the sum functionality. This one, as you can see, we have 38 point something. Okay, now the net brickwork can be actually, if we type equal and the total brickwork, I mean, just you can say these 2 columns. Oops, wait a minute. Equal, and we will have a bracket maybe, and you can see these 2 things are actually just the quantity of the brickwork, okay, including the deduction. Okay, so we have to just subtract from those things. Okay, now I can say this, and I'm going to type plus sign and this one. Okay, it's better to add them before the deduction, so it can be very easy. Okay, and I'm gonna close the bracket and let's subtract the deduction. Okay, where is the deduction? This is the total deduction. Okay, press enter. As you can see, we have now this is the quantity. Okay, you can just change the color of it so you can understand about the things. Let's say this is the total quantity here. This is the total quantity. Okay, so it's better to share them so you can see the things very clear, like total PCC. Then you can of course calculate the quantity of different materials used in PCC. What's wrong over here? We have total PCC. Okay, these are actually 2 different things. Okay, that's why, that's the reason. Now again we have, okay, this is where is it? Total PCC stonework. This is actually total stonework. Okay, total stonework. If you remember, we have done this previously. Okay, on the same in the same video, you can see. Now this is the total excavation. We are doing it right. So RCC slab, that's been done. Okay, now next let's focus on the floor. Okay, in the same drawing, as you can see, we have floor, and there we have 10 inches soil. Okay, so let's say number 7, and that is actually about the floor. Okay, and in the floor we have, as you can see, 10 inches soil filling. We will calculate that, and then above that we have actually where is it? That is 2 inches sand filling. Okay, so let's type 2 inches sand filling, and then above sand filling we have 1 inches concrete, which is 124. Okay, so let's see that we have 1 inch concrete, and that is of course 124. Is that clear? And number, these things must be 1 because we have only 1 floor. Okay, so these are just, you can say 1. Now what should be the length? You can confirm that from the section and maybe from the foundation plan as well. Okay, so this is going to be very easy. Now as you can see, this is 12 feet. You can see that. Okay, so as you can see, now look at the foundation. We have to just subtract this portion, which is actually maybe 2 inches, because this is 2 inches offset. You can confirm that from the foundation. Look at that. Okay, the offset is just 2 inches. Okay, so from 12 we have to subtract 2 inches for the soil filling. Okay, this 2 inches, and for the other side 2 inches as well. Okay, so it means 4 inches can be subtracted. What do you say? The total length, that is 12, and we will subtract 4 inches. It means we should have 11.667 feet. Okay, now this is square. Okay, you can see the plan. This is just square, 12 by 12. It means the width should be the same. Okay, is the length. Now the height, which is 10 inches. Okay, 10 inches means if you just divide that by 12, we can get that in feet, and that should be 0.833. That's very easy. Now we have to copy this formula and paste it over here so we can have the quantity. You can see that. Okay, which is 113 CFT soil filling. That means 1 sekada, little bit more than 1 sekada. Okay. Now 2 inches sand filling. Okay, let's focus on the same section. Okay, the width for the soil filling and for the sand filling, it is just the same. You can see that. Okay, so it means the length and width, these things are the same. However, the thickness is just different. Okay, that is different, and that is only 2 inches because it's given in the drawing. Okay, that the sand filling, that is 2 inches, or you can say 0.166. Okay, that is in feet. Just drag the formula below so we can have 22 CFT maybe. Okay, you can just put the you can say unit for that over here. Now the concrete work, you can see that the concrete work, that is just okay, little bit we cannot subtract, you can say that extension. Okay, it is the same thing as the width of the, because this is just above the you can say DPC. Okay, so we have the same thing as 12 feet. Okay, that is clear. 12 by 12, and the thickness, that is actually 1 inch only. Okay, what do you mean by 1 inch in feet? That should be 0.0833. Okay, just drag the formula below so we can have that in CFT. What do you say? It's very clear now. So this is for the floor. Now next we will be just determining the quantity of the plaster. Okay, so let's do it. We have the quantity of plaster. Okay, and that is number 8. Okay, plaster work. Now plaster work, let's say that is just 1:3. I'm writing these ratios because after the completion of this small project, we will be just determining different materials used in these things. I mean, we will have some analysis, okay, for different materials such as sand, cement, whitewash, maybe, etc. Okay, so let's do it. Now the plaster work. Look at the drawing. Okay, we can have plaster, okay, on different places. Maybe the internal plaster and the external plaster. Okay, we will have plaster over here as well. Okay, just we can say between the ground level and the plinth level. You can see. Okay, we can have plaster just over here. Okay, on this face. Okay. And below ground level, there is no plaster because that's just, you can see it is just inside the earth. So how can we plaster that? All right. So let's say if we have internal plaster. Okay. Now in number, there can be different methods. You can do long wall, short wall. You can actually determine the parameter and then multiply that with height. I think that is simple. Okay, we have to determine the parameter. Like as you can see, this is the internal. Okay, this is just you can say a square. So the parameter of square is very easy. Okay, we have to add all these sides. You can say 12, 12, 12, and 12. Okay, it means 4 times 12. Okay, this can be the parameter of the internal walls. Okay, so 12 times 4, that can be actually the length for the plaster, that is internal one. Okay, and that should be 48. Okay, now in number, I'm gonna put 1 because we have only one room. Now remember, the width of the plaster, that is just not taken. You can say the thickness, it is the same thing as DPC. Okay, we will include that in analysis. Okay, so we have to take the height only. And how the height? Just focus on the section. As you can see, in the section, we have the height that is actually the height of the wall, 11 feet. But for the plaster, that is not 11 feet. As you can see, 1 inch has already been taken over there. Okay, by, you can say, the concrete work. Okay, so now if you can confirm it, okay, let me just see if we can see it by linear. So this can be little bit, you can say, less than the 12. Okay, up to this point maybe, and that is actually 10 feet and 11 inches. Okay, because 1 inch is already been covered by the you can say concrete work. Okay, so 11 inches and 10 feet, it can be actually 11 by 12, okay, which is 0.9 and plus 10, so we can have 10.916. okay, is the height. That is 10.916. Okay, now we have to only just multiply these two things. Okay, we do not have to multiply the, you can say, the thickness. Okay, because the thickness can be 1 inch or maybe ½ inch, so we will add that in analysis. Okay, now the quantity must be in SFT or in square feet, because this is just the area. Okay, so let me have a formula. You can say equal, and we will multiply the number, okay, with the length, and then the height, which is actually F32, okay, center. Okay, this is in square feet. Now the slab, which is internal, let me just write internal slab, and let me include another word, that is plaster. Okay, now in number, slab is only one. Okay, let's see in drawing. This represents actually the slab, and the internal size, that is actually 12 feet. You can see that. Okay, so 12 feet is the length, and this is actually square. It means we will have only 12 by 12 slab, okay, inside, and we will drag the formula below. Okay, it's very simple. Now internal plaster, that is just done. We will have external plaster now. Okay, and then we will add all these plasters, so we can have the quantity, maybe you can say. Okay, all right, so external plaster. Okay, now in external plaster, let me just include something over here, maybe walls. Okay, now in external plaster, we have, let's say, walls. Okay, and above the plinth level, maybe, and for plinth level, I'm gonna say PL1. Okay, let me just have red text. Okay, now in number, we will have to determine the perimeter again. Okay, as you can see, this is external wall, so we can have the plaster on this surface. You can see that. Okay, on this surface, only on this surface. Okay, and the height, that is actually known, it is 11 feet. You can see that. Okay, now the perimeter, we will have to take the perimeter, which is the external perimeter. Let me just draw a rectangle so you can see this perimeter. Okay, we have to take this perimeter only. Okay, you can see that. So this perimeter can be determined very easily. It is the same thing as we have determined the length of the wall B. Okay, as you can see, we have 12 feet, just the same thing. Just a minute. It is actually 12 feet from this point to this point. Okay, what we have to do is just to add 9 inches to one side and 9 inches to another side, just for the walls addition. Okay, so this is going to be the one side of the square. So it means we have now 12 feet and 9 inches, and 9 inches are 18 inches maybe, which is 1.5 feet. Okay, so it means we have one side 13.5. And let me just confirm if we can see it, okay, by linear. So this and this, you can see that. Okay, it is just 13 feet and 6 inches, or maybe you can say 13.5. Okay, so now there are 4 sides. Okay, because it is a square, that's why I'm going to multiply that 13.5 with 4. Okay, and that's going to give me the length, which is actually 54. Okay, in number, I'm going to put only 1. Now the weight is never taken. The height is known, which is of course just 11 feet from the section, and we will just apply the same formula. What do you say? That's very easy, okay? So these are external walls. Next, we will determine this portion. You can say, let me just draw a rectangle, this portion, and then that portion on the other side, okay? And it is the same thing because you can see these places are just plaster, which are actually the distance between plinth level and ground level, okay? So I'm gonna say external plaster between plinth level and ground level, okay? Okay, a number that's going to be 1. Now we have to determine the length, and you can say the height. The height is just known, I think. You can see the distance between plinth level and ground level. It should be given over here. And that is, I think, if I'm not wrong, 12 inches. Okay, so 12 inches is the height. So I can put 1 over there because 1 feet and 12 inches, that is just the same thing. Now let's just determine the perimeter, okay? Up to this point, you can see, let me just have dimensions and then linear. Now from this point till this point, that is actually the side of the square, okay? And that is 13 feet and 10 inches, okay? Pretty cool. So we have to multiply the one side with 4 because we have a square. It is simple. If it's rectangle, you have to determine them separately, okay? So 10 by 12, that is actually 0.8, and we will add 13. So we have the one side now times the 4, okay? So we can have 55, maybe, like you can say that, okay? 55.34. Okay, cool. We have to derive the formula just below. And this is very little because the height is so small, okay? One thing I think is just remaining. 2, I guess 2, okay? This 1 feet portion and then this vertical portion of the chajja, okay? So we have to determine that, okay? Plaster, you can say chajja, okay? And I'll say the horizontal portion, okay? And then we have to determine the plaster on chajja, and that is going to be, let's say, the vertical portion. And number, we have to just put 1 because it is just the same thing, okay? Now, if you see, it must look like the same thing as this one. Just a minute, okay? I can show you. It should be, if you look to the diagram, it should be the same thing as like this one. Okay, so we have to plaster this shaded area, maybe you can say. Okay, let me just show you if you guys can see it. Okay, this shaded area, I mean. Okay, so how do you determine the area of the same shaded area? It's very easy, okay? We have to subtract the internal rectangle, you can say square, from the external square. Or we have to determine the center line length and then multiply that with the width, which is actually 1 feet only. Okay, so this is what we have to do. And another thing, which is actually the vertical one, so that's very easy because we have to check the one side. Let's say this is the one side from this point to this point, which is actually 15 feet and 6 inches. Okay, let me just cover this thing first, okay? 15 feet and 6 inches. One side is, you can see we have square, so we have to multiply that with 4, okay? It means the perimeter of the plaster, that is actually 62 feet, okay? And the height, that is actually the thickness of the slab, okay? So we have height, which is 0.5, that is 6 inches, okay? Now, however, chajja on, you can say, the horizontal portion of the slab, which is this portion, you have to determine the center line, okay? And how you gonna do that, okay? For that, let me just draw extra line from this point to this point, okay? And then from this point to this one, okay? So we can determine the center line length, okay? I'm not gonna do that on whiteboard because we have discussed this thing before, how to determine the center line length. So the center line length is 14 feet and 6 inches, okay? 14 feet and 6 inches, which means 14.5 times 4 for the square, okay? So that's gonna be 58, right? And the width can be 12 inches or 1 feet. Okay, so this is actually the total plaster work. Okay, now we have to add all these plasters. So this is actually the total plaster work, which is SFT. Okay, and I'm gonna share this is yellow. Is there anything which is remaining?
इसमें डिडक्शन नहीं करेंगे प्लास्टर में विंडोज और डोर की.
Oh, very good. That's what I want. Okay, that's amazing. Thank you so much. Okay, let me just subtract this thing. Very good. What's your name?
मोहम्मद इस्माइल.
Muhammad Ismail. Thank you so much. So we have detection and detection for door and then detection for window. And remember, door is 1, window is 1. But this time I'm not gonna put 1 and 1 because there are two sides of the door and window. Okay, two sides plaster has just been covered. Okay, let me show you that. Let's say this is the door. Okay, so the door has covered plaster area which is internal, and the external one is also been covered by the door. So we have to take two sides. It means 2 and number. Now it is the same thing. Let's say door, the width that is 3 feet and 6 inches, that is 3.5, and we cannot take the height, sorry, the width. However, the height that is 7 feet. Okay, if you remember that. Now for the window, that is 6 feet. Okay, and the height that was, if I'm not wrong, which was I think 4.5. Okay, let me just confirm it by DI. Okay, click this point and this. So it is 4 feet and 6 inches. I was right. So 4.5. Okay, now we will just drag this formula and we will delete this cell, because those are empty. Okay, now the total detection, this can be actually the summation of the two. Okay, we do not have ventilators or any other stuff, so we cannot detect them. Okay, so detection in SFT, and let me just have maybe one cell over here. Okay, let's say total plaster. So we can have something easy in detection, you can say. Okay, I'm gonna total them. Okay, this is SFT. Now let's determine the net plaster. Okay, we will just subtract the detection. Okay, so net plaster, and that's going to be actually equal, and we will have the total plaster and we will subtract the detection, which is 103. Okay, so press enter, and that is actually in SFT, that is total plaster. Pretty cool. Okay, that's good you remember that. Okay, so we have total detection over here. Okay, you have to recommemorate everything to me, because I'm also a human. I can forget things. Okay, so these are actually the total. Okay, we have what number? Let me just see it. We have different things which are actually number 8. That was just plaster. We have 8 types of materials in the same room. Okay, if there is any other type material, you can just check for that, no problem. Okay, now we have different things, so we have to look for the material statement, and in order to prepare the material statement, it is required to determine or you can say it is required to have analysis of the quantities which are being calculated, okay, in the Excel. Okay, so we have to check okay, we have to actually make everything separate, like maybe the let's say, okay, let me just, what actually we need is the PCC work, which means total PCC work. Then we need actually total plaster work, and then the brickwork, and then everything like maybe excavation and etc. Okay, so once we have these total things, then of course we can determine different materials. Okay, let's say if we have PCC work, maybe something like 10,000 CFT. Okay, what we have to determine is actually the cement, the sand, the crushed stone, okay, in the same material. Now in plaster work, let's say if we have plaster work is 5,000 SFT. Okay, what we have to determine is actually the quantity of cement and then the quantity of sand in the same plaster work. Okay, so we have to look for the materials. You can say we will also focus on the ratios. Okay, like let's say we have 148 over here is the PCC work. Okay, do we have another element that is just 148? No, of course there is no. Okay, however, there can be 1 to 4 maybe. Okay, we do not have 148. Okay, twice. There can be, just focus on this. Okay, stone work in cement mortar, it is 1-3, and the plaster work, that is also 1-3. Okay, 1 to 4. Okay, RCC slab, that is 1 to 4, and we're here 1-inch concrete, that is also 1 to 4. It means we have to add 382 and that 11.9. Okay, after addition, then we will have analysis. Is that clear? So tomorrow, inshallah, we will have analysis, and for today, this is enough because we have a complete project. Okay, so see you tomorrow, inshallah, and if there is any question, you may ask. Is there any question?
No, sir, clear, sir.
It's clear because it's just basic. Okay, and I think many of you may understand how to calculate or how to do analysis. Okay, how many of you do understand that?
Question क्या था?
The question is, let's say we have PCC work. Okay, can you do its analysis, like maybe calculating the cost of materials, calculating the cost of labors? Can you do that?
No, sir.
Material,
Okay,
material
so
no, sir.
you must attend the tomorrow's class. Okay, see you guys tomorrow, inshallah, and wassalam. All right, so if you remember previously, we have done all these things. Okay, we have calculated these materials. You can say the quantities of different materials, such as brickwork, PCC work, okay, and the plaster work, and let's add whitewash too. And let me have that maybe like 3 quarts, okay, on the fresh surface. So the whitewash is going to be the same thing as the plaster work, because we're gonna whitewash the surface that is just plastered, you can say. Okay, so we have the whitewash is the same as the plaster work. Now, I want to determine the cost of construction, okay, of the same project. Like it is just a small project of a room which is 12 by 12. If you remember, let me just open that. Where is it? Yes, this project, okay. We have done it. And if you can see, it was the same thing like this. Okay, this thing, okay. So it was just a small room, you can say. However, a room and you can say some small project is the same thing, because we have foundation, we have floor, we have roof, everything, okay. Doors, windows, everything available in the same small project. So it means it is like a project, okay, you can say, for a quantity beginners. So as we have just calculated all these things in Excel, you guys can see the Excel, okay. Okay, so we have all these materials. Now, I want to determine their cost. You can say the cost of construction. So how can we do that? For this approach, you have to use MRS. If you remember, we have already talked about these things before, okay? MRS. I have 2020, which is a little bit old, but does not matter. It's just learning, okay? You can download maybe 2023, maybe available on the internet. And this can be actually different according to the location you are living, okay? So MRS is actually just the material rate system, or you can say just the material rate schedule, okay? Because it is just a schedule, okay? Having different costs. You can say the cost of labor, then the cost of material, or maybe composite, you can say, okay? So we'll just take the composite rate for different materials, and I'm not gonna use all these small videos, okay. Let's say we have serial number over here, okay. I'm just making like a table, and then we have description, And then let's say we have maybe quantities, then maybe unit, and then maybe unit rate, and then you can say the total amount. Okay, so it is just like a small table, you can say, right? Let's have some border, like maybe tick, so it's clear. And I'm gonna enter some videos. All right, so let's say we have maybe brickwork in the same project. We may have PCC work, we may have RCC work. There can be like excavation, which should be at start. And there can be like maybe whitewash in your project. And lastly, I would say there can be maybe stonework or maybe stone masonry. Okay, just the same thing as brickwork. So you can say brick masonry. I'm not just entering all these things because that's gonna take much time, and our lecture maybe a little bit then lengthy. Okay, so let's say if we have the brick masonry, I'm not gonna take the brick. Where is it? Okay, here's, let's say this one. Okay, I'm not taking the net brickwork is 382. It is just a small video. Okay, so let's say if we have brickwork is maybe 6,000. It is, let's say it is a huge project, and then we have PCC work is maybe 3,000. Okay, and these guys are in CFT, you can say, right? And then let's say RCC, so maybe 1,000. Excavation, let's say this is 7,000. Okay, in CFT. And then we have whitewash, let's say maybe 3,000 SFT, because this is just, you can say, area. And then stonework, this is, let's say 2,000. Okay, CFT. CFT means cubic feet. Okay, you may have cubic meter, does not matter. Now the unit rate, it means the composite rate. Okay, what rate we have in market. Okay, so it depends upon those things. Now we have to just look into the MRS. Let me just have MRS over here. And the first thing, as you can see, we have the brick masonry. Okay, so you can just search for brick masonry in your MRS, which is just a PDF, and let's just search this thing over there. Okay, for this you can even check the maybe the table of content. Okay, if you cannot find your required work. Now, as you can see, this is chapter 7, and we have the brick masonry. So as you can see, in the same MRS, we have the brick masonry. Now, let's say we have the brickwork in maybe in ground floor or maybe in second floor. So you have to confirm those things if it's first class brick or maybe second class brick. Okay, so these are the description, you can see it. Okay, let me just highlight if I can do it. These things. Okay, these are just the description. Okay, so let's just see if we have maybe let's say first class brickwork in ground floor, cement and sand mortar. We can even use this, but if you remember in our description it was 1:3. Okay, so we can use this composite rate, which is of course 28,748 point something. Okay, if you need to determine only labor, you can use this thing. But remember, this rate is not just for a 1 CFT, it's for 100 CFT, which is huge work. Okay, so what you have to do is just to convert it into 1 CFT and then multiply the rate with your same video, you can say, with this one. Okay, so we have the unit rate, which is actually let me just copy that. Where is it? It's maybe like 28, this one. Okay, let me just copy it and I can just paste it over here. This is the unit rate. Okay, and this unit rate is actually per 100 CFT. Okay, now what should be the amount? That's pretty clear. Okay, you have to just determine the unit rate, which means per CFT. You can do it by using Excel functionalities. Okay, what we have to do is just to divide this thing, okay, by maybe 100. So we can have per unit rate. Okay, you can even just close those things with bracket and then multiply this with the same quantity which you have and press enter. Okay, it is a huge video, very huge video. Okay, because we have, and let's just confirm if we have done that correct or not in Excel. Okay, so calculator is, I think, best option we have. And this is 0.83. Okay, and let's divide it by 100. So this is the rate per CFT, which is 287. Now we have a huge work. Okay, that's 6,000. It means it's like a huge building, heavy project. Okay, so let's multiply that with 6,000. Yeah, this is good. Okay, so we have amount, and this amount is actually in RS, not in dollars, because this MRS is used over here in Pakistan. Okay, that's not US MRS. So I think you guys have understood how we can use MRS. Okay, I'll have just another example. Okay, I'm not going to spend much time with it because it's just simple thing. So let's look for the whitewash. What do you guys say? Okay, whitewash, and I'm gonna have whitewash in the same MRS. Let's just search for it. Okay, let's say whitewash. Okay, you should know about this search box. Okay, and there, as you can see, we have different type of whitewash. You can say in chapter 11. Okay, we have surface rendering, and this is whitewash old surface 1 coat. Okay, our surface is, let's say, new surface. Okay, and we want 3 coats. So as you can see, we have this thing. Okay, whitewashing new surface and 3 coats. Okay, that's good. And we have the rate, which is 426. Let's just copy that rate into our Excel, maybe like we're here. And this rate is actually per 100 SFT. Okay, let me just confirm it. Yeah, it is per 100 SFT. So again, we have to just convert it. Okay, the same way is like this one. We can even drag this formula below so we can save time, and let's just remove these zeros. Okay, so this is the same thing. Okay, it means we have just divided 426 by 100, and then we have just multiplied that value with 3,000. So we have the rate for the whitewash, and this is actually in RS. Okay, 12,797.1. So this is how you can use whitewash. There can be earthwork. Okay, let's just look into the table of content. If you guys can, yeah, we're here. We have broad bridges, lining up canals, sheet piling, okay, and so on, protection and diversion works. We have outlets and so on. Okay, so you can just have these things over here. Look at carriage, which means the carriage of material. Let's say we have maybe stones and we want to carry them. Okay, let's say we have 1,000 or maybe 2,000 CFT stonework. So what should be the rate of carriage? You have to look in the MRS. Okay, for that concrete work, we have mortar, the stonework, and so on. Okay, so this is how you can use, of course, MRS. Now, I'm going to just close this thing because we don't want to waste much time on this approach, maybe on this topic. Okay, the next thing which I'm going to do is actually the same thing, which is the material analysis. Okay, are you guys there?
Yes, sir.
So we have material analysis, and I'm going to use the whiteboard for this approach because whiteboard can be better option. Okay. I can even do that in Excel. However, we will give it a touch, no problem. Okay. I don't like this whiteboard. Let me just open something like maybe PowerPoint. Okay, PPT. I really like PPT. We will be just determining the brickwork. Okay, and we will have some analysis, maybe just determining different materials used in it. Let's say if we have the brickwork, maybe the quantity of brickwork. Let's say if we have the quantity QTY, let's say it is 373, okay, CFT. It is the same video. It was just determined yesterday, okay, for the same room, if you remember. We have done this. We have 373 CFT. And let's say we have the ratio for the brickwork, and it is 1:3. Okay, so this is the ratio. Now, if we need to determine the quantity of cement, the quantity of sand, but let's say we have the number of bricks. So how many number of bricks should we just demand for this work, for the same work? Okay, so the number of bricks should be calculated first. Now, in order to determine the number of bricks, you have to just multiply 373 with 13.5. What do you mean by 13.5? Because we have 13.5 bricks per CFT. Okay, if you have 1 CFT brickwork, it means you should be using 13.5 bricks. Okay, so this is actually the volume of the brickwork, and we have to just multiply that with the unit factor. Okay, so after multiplying these things, there can be actually the number of bricks, and these should be actually 5040, which is huge video. Even you guys can confirm these videos, okay, with your phone or maybe with any other calculator. So
Okay, sir.
so you guys have to just confirm these things, because I'm just writing these things from, okay, maybe you can say approximate videos. So we have 5,000 bricks, you can say. Now for the same project, let's just determine the quantity of cement. Okay, let's just determine cement. Now in order to determine cement, of course, we need how much mortar we have in the same brickwork. This is actually the good question, okay? So first we have to determine the quantity of mortar. Now remember, the quantity of mortar should be 30%, okay? And this is actually dry mortar. 30% of the brickwork. So 30% of the brickwork is actually 30 by 100. And we will just multiply this with the brickwork, which if you remember, it was just 373, okay? So this should be now approximately 111 CFT mortar. Now from the same mortar, okay, this mortar actually contains two things. One is cement and another one is actually sand. Okay, so we have to multiply these two things, and these can be determined from the ratio. Okay, we have 1:3. Now the sum of ratio, we have to determine it. Okay, the sum of ratio, which is actually 1 + 3, and that should be 4. Okay, so this is what we need to determine these two materials. I just gonna need to determine the cement first, and for this approach, and even let me just erase these things. Okay, these things, I should just write a specific formula for this approach. Okay, in order to determine the quantity of anything, quantity of material, you can say, you have to take the ratio of the material, the ratio of the same material, okay, and you have to divide it by the sum of ratio. So it is like a formula, okay, and then multiply this thing, you can say this ratio, with dry mortar. So now let's just determine the quantity of cement. Now the ratio of material, okay, just look at over here, the ratio of material, that is actually 1, okay, in the same ratio, because 1:3 means, what do you mean by 1:3? Anyone just know about this?
1 cement,
Yeah.
1 and 3 sand,
Okay, so
1 brick cement.
okay, so it's like the ratio of material, you can say the ratio of mortar. One represent it represents actually cement's quantity, and 3 represents the quantity of sand. Okay, so we have to take the ratio of material, which is actually 1 this time, and we will divide this by the sum of ratio. Now the sum of ratio, that is actually 4, and then we will multiply this with the dry mortar, okay? Or you can say the dry volume. And if you remember, it is just 111. So 111, okay? So if you just multiply 111 with 1, it is the same thing, and then divide it by 4. So you will have 27 maybe CFT cement. But remember, cement is always just, you can say, bought in terms of bags, okay? We cannot demand it in terms of CFT because bags are available in market. So we have to convert this into bags. Now, in order to convert the CFT into bags, okay, you should know the volume of one cement bag, okay? And this can be different, okay, according to your country's bag volume. Like maybe in Pakistan, it is 1.25 CFT, okay? So you have to multiply this, divide this by 1.25 in order to get the quantity of cement in bags, and these should be approximately 22 bags. Next, we need to determine the quantity of sand. So you have to use the same formula, like maybe the ratio of sand, which is actually 3, divided by the sum of ratio, which is 4, and multiply it with the same thing, okay, which is the dry mortar. So this should be the quantity of sand, okay? And this is so simple, which should be 83 maybe, like 84 CFT sand. Okay, you can even convert this into sacras, which is actually like local unit, okay? So you have to divide that by 100, okay? Which is almost like 0.84 sacra. It is local thing, maybe like 100 CFT is actually 1 sacra, okay? Now, it's really complicated to use this formula again and again, so it's better to use it like in short form, maybe, okay? Like if you see, we have 1:3, okay? Now the quantity of cement, it was just 27, okay? So you have to take that 27 and then multiply this with the ratio of sand, because sand is just 3 times of cement, okay? So we have cement is 27, multiply this with the ratio of sand, which is 3, and this is going to be the same thing is 84, okay? If I'm not wrong, 27 times 3, this should be 81, okay? So it means this should not be 84 then, okay? Let's just confirm it. So we have actually taken this thing approximate, okay? Because I'm not using calculator, okay? This thing is actually approximate. This one is approximate, okay? So we have taken approximation over here. You have to use the exact video in order to calculate these things, okay? Right? Like if you remember, we have just labeled 111. But if you multiply this thing, which is 373, okay, with 30, this is actually 11,190, and then just divide it by 100, which should become actually 111.9, okay, 111.9. So 0.9 is just been skipped. That's why we have some differences in the answers, okay, which is not, you can say, issue. Okay, so it means we have now materials like maybe cement and then sand.
सर
Yes.
सर ये 111 जो वॉल्यूम है मोटर का, इसके साथ 1.3 मल्टीप्लाई नहीं करेंगे ड्राई के लिए?
Basically what happens is actually 30% is actually dry already. Okay.
नो सर ये बात नहीं करा.
What's your question?
सर ये 111 क्यूबिक फीट जो वॉल्यूम है
Yes.
मोटर का, ये वेट वॉल्यूम है ना सर? ड्राई में कन्वर्ट नहीं करेंगे मल्टीप्लाई बाय 1.3?
This is what I'm saying, that 30% is actually dry. So 111, this is actually in form of dry volume. So we don't have to convert that. It's never wet. However, let's say if you have plaster work, okay? Let's say if you have plaster work, and that is, let's say maybe 200 CFT, okay? So this can be wet. Then you have to multiply this with 1.27 in order to convert this into dry volume. What do you say? Is it clear?
Yes, sir.
Now next, okay, so this is how we can do material analysis for the brickwork. Okay, let's do it for the PCC work. We will take the same video from the same room which we have calculated. Okay, and let's say that is 13.8.2 CFT. It was just calculated. Okay, the PCC work. If you remember, we have done it. Now the ratio for this, if you remember, it was just in the foundation. Okay, and I think it was just 3 inches. Okay, so you have to confirm that, no problem. It was, I think, 1:3:6 ratio. Okay, so now if you just calculate, okay, like if what it was just in foundation, maybe like this. Okay, so it's just like a slab. Okay, we have 13.812 CFT. Okay, and this is PCC plain cement concrete. So when we calculate all these things, we actually multiply the breadth with the height or thickness and then with the length. It becomes actually the wet volume. Now, the ratio that is 1:3:6, it means the summation of ratio or the sum of ratio should be 10. Okay. Now, in order to determine the quantity of cement, let's just calculate cement. Okay. Remember the same formula. The ratio of cement, let's say the ratio of cement divided by the sum of ratio. Okay. And we multiply this with dry volume. Okay. So the cement should be now the ratio of cement, which is actually 1 divided by the sum of ratio, that is 10. Okay. And we will multiply this with dry volume. Now, what's dry volume? Dry volume is actually the wet volume, which is 13.81. Okay. And we will multiply this with 1.54. Now, 1.54, this is, okay, it may be varies depending upon your country and depending on the materials used in the same concrete. Okay, I have read many books and this video is different. Okay, it can be 1.50, it can be 1.51. Okay, it can even be 1.49. Okay, so it depends on the properties of the fine aggregate and then coarse aggregate, and even depending on the cement. So why we take 1.54? This is a good question. Okay, but before answering that, let's just calculate this value first. So the quantity of cement should be now, okay, if you multiply 13.81 with 1.54, this should be actually 21. And 21 times 1, this is the same thing. And we will divide that by 10. So we can have the quantity of cement, which should be 2.127 CFT. So 2.127 CFT is actually cement, right? Now divide this by 1.25 to have the quantity of cement in form of bags, okay? So we should have 1.701 bags. Why do we need to convert wet volume into dry? This is a good question. The question is actually, we're here, okay? We just converted the wet volume into dry by multiplying 1.54, okay? So why do we need to convert wet volume into dry? And why, what's 1.54?
ड्राई वॉल्यूम सर ज्यादा होता है जब हम पानी उसमें ऐड करते हैं तो फिर उसका वॉल्यूम कम हो जाता है, वो कंप्रेस हो जाता है सर.
Exactly. That's good. You are clear, okay? So what happens actually, if you see, we have aggregates like maybe cruststone, okay? These are cruststone, and there can be actually maybe sand like this, okay? And here we have cement, very fine, okay? So we have 3 materials, right? This one sand, and this one cruststone, or maybe coarse aggregate, if you use technical words. Sand is known by the fine aggregates. Now what happens actually, if you bring, okay, if you carry the crush, okay, there are spaces, maybe voids, okay, these voids, okay, so these voids are filled with the quantity of sand, okay, and even these voids are maybe the voids in sand are filled with the quantity of cement. So this is actually the basic approach. And this is the idea, okay? So what happens is actually, let's say, if we bring 100 CFT Crusstone, 100 CFT sand, okay? And even 100 CFT maybe cement, okay? Which is actually not the same thing, right? This can be 50 maybe, this can be 25, or even we can say, let's say if we have 1 CFT, and then we have 2 CFT, and then we have maybe 4 CFT, okay? Okay, that's not considered that, okay? So we have 1 CFT, we have 2 CFT, and then maybe 4 CFT as the crust stone, okay? So what happens actually, this is very, you can say this is maximum, okay? The volume is maximum, okay? We bring it in dry form. Okay, now we know it in advance that after adding water or mixing these three materials, we may have the shortage of 54%. Is that clear? That's why we add in advance. Okay, we add 54% volume in advance. This is the basic concept. So for 1 CFT, if you add 54%, it means 1 plus 0.54. This becomes 1.54 for 1 CFT. So this is how we have 1.54. So this is how we can just calculate maybe the cement. Okay, where is it? We have 2.127 cement. So this is cement, and now we will just calculate the quantity of sand ratio. It was just 138. Okay. So what you have to do is to take the quantity of cement first, that is 2.127, multiply this with the ratio of sand, that is 3. So we should have 6.381 CFT as sand. Now, let's calculate the crust stone. We have cement, which is actually 2.127. Now, the ratio of crust stone, which is 8. Okay, so we will multiply that with 8. I'm not going to repeat those formulas like the ratio of the material divided by the sum of ratio times the dry quantity of the material. Okay, this is just for kids. So we will use these simple things, okay, times 8. So we must have maybe 17. Yes.
No, sir, 136 ratio था.
Okay, we have 136. That's good. We have 136, so we will put 3 over here. You are good. Thank you. We have 6 here, okay? So it means that 2.127 times 6, this is actually 12.762 CFT. Thank you. That's good. Okay, so this is called, and this is known by the material analysis of PCC work. Is it enough, or I should move ahead? Okay, one another thing. Let's cover DPC, and I'm not gonna calculate these things. Okay. Now, what we have done in DPC, let's say if we have 50 SFT. Okay, remember DPC, it was just calculated in terms of area, if you remember. Okay. And now let's say if the DPC thickness, if we have thickness of the DPC, and that is actually 1 inch. So we have to convert this into volume now in analysis. Okay, you have to multiply this with 1, but 1 that is in inches, let's divide that by 12 to convert it into feet. We must have something in CFT. Okay, now this is actually concrete or PCC. So you have to use the same process. Okay, we just used over here for the PCC. Okay, so for the PCC, it is the same thing. Okay, for the DPC. Okay, and even it is the same thing for the RCC as well. Okay, so we are not going to discuss these things. because we have already done it. Okay. Now, another thing, let's just say, why not we cover about the whitewash?
सर ये प्लास्टर वर्क का जो मोटर होता है सर, उसका वॉल्यूम कैसे फाइंड करेंगे, वो भी एरिया कैलकुलेट
Okay,
करते हैं।
let's consider plaster. So if you remember, we have already calculated plaster, okay? Can be anything, okay? But let's say if we have that like 200 SFT, okay? It was just the same thing in an area, you can say. Now, we have plaster thickness, okay? Let's say the plaster thickness, that is maybe ½ inch or maybe 1 inch, okay? So let's say if we have ½ inch, you have to convert this into feet by converting or dividing that by 12, okay? Like maybe 0.5 divided by 12, this is actually something like 0.041, okay? Feet maybe. Okay, so now you have to actually determine the wet volume of the plaster. Okay, wet plaster, or maybe you can say wet volume of the plaster. So you have to just take the area. Now area times thickness, this is actually the same thing as volume. So we have actually the wet volume, and that should be, if I'm not wrong, this should be 8.34 CFT. Okay, so let's just say if we have the ratio for the same plaster is 1:3. This is the ratio. Okay, so let's just determine cement. Okay, that's clear. Okay, let me just make it clear for the others. So we have to take the ratio of cement, which is 1, and let's divide that by the sum up ratio, which is 4, because 1 plus 3, that is 4. Okay, now let's multiply this with the dry volume. We have wet, that is 8.34. Let's multiply this with 1.27. Okay, for concrete, it was actually 1.54. This time we have 1.27 because we don't have the coarse aggregates. And the voids present in the sand should be filled with the quantity of cement maybe. Okay, we consider it the same thing. In advance, we know that 27% may decrease after adding the water or mixing the aggregates or maybe the cement and sand. So this is now the dry quantity, you can say, if you multiply that with the same factor, okay, and divide it by 4, so we can have the quantity of cement, which should be 2.64 CFT. Okay, 0.64 CFT cement. Now just divide this by 1.25, so we can have it in bags. Okay, 1.25, and it should be 2.11 bags. Now, if you're working in MKS system, this thing can be different. The volume of cement bag can be different in MKS system, maybe in cubic meters, okay? It can be different. And sand should be actually the quantity of cement, which is 2.64 times the ratio of cement, which is 3. And this is 7.92 CFT. So I think it's enough for today. See you in the next video. And if there is any question, you may ask.
Sir, please can slide send in group.
Send in group?
Yes, sir.
Okay, let me just save it so I can even send it, okay? Is it QS class day 5? Is it day 5 or something else? Okay, I'm gonna convert this into PDF so you guys can read it even in your mobile phone.
Okay, sir. Thank you.
You guys may leave the class, okay? Okay, in the same material analysis, if you remember previously, we had just determined different materials in brickwork, okay, and then in PCC, also in RCC, and then we have, if you remember, calculated different materials used for the plaster and something such. Okay. Now, in the same video, we will carry the same topic and we will be just analyzing the materials used in or maybe for whitewash, okay? And for the same whitewash, or you can say the materials to calculate, and those materials can be actually maybe lime, maybe glue, and then color can be added sometime, okay? So we will be just determining the lime, then the glue, and then of course, okay, instead of glue, rice can also be added, okay, for the bonding purposes. So glue that is just normally used, however, rice can also be added. And the color is just a good thing, you can say, okay, just maybe for the beauty. Okay, so let's move ahead and let's see. We may have some points, okay, just to you guys have to remember these points in order to determine the quantities of different materials for the whitewash, okay? And the points are, you can say 2 kgs of lime must be used, okay? You can say 2 kgs of lime for 10 square meter surface, okay? And this is actually unslacked lime, okay? This should be required with 0.06 kg glue, and this you can say 10 or maybe 10 square meter, which is required in 2 kg lime, that is just for the single coat, okay? This video can be different. I mean, the 2 kgs per 10 square meter, that can be different for a 2-coat whitewashing. And that is actually 2.8 kg, okay? So you have to just buy, or maybe it is required to have 2.8 kg per 10 square meter, okay, of white fat lime. Okay, so the glue is actually the same for the 2 coats, okay, or maybe for the double coat whitewashing. And then for 3 coats, it is just completely different. You can see the lime should be 3.5 kgs, and as you can see, the unit rate, that is just the same. I mean, the unit of work, which is 10 square meter, and then the glue, look at that, it is actually twice, which is maybe 0.12 kg, okay, and this is for the 3 coats. And the color, however, the color can be depends on the choice, okay, of the client, which means the color can be lump sum, okay? So we can add it lump sum. And by lump sum, I mean that it can be any value, maybe anything, like can be even maybe 100 grams, can be 200 grams, can be anything, okay? So it depends on the choice, okay? And I think to understand these things better, we should have an example, okay? Because example can be a better way to understand the problem. So let's have an example, and let's say if we have a wall, we will just consider a wall, and the wall, let's say it is just 15 times 5 meters, okay? 15 is actually the length, and 5 is actually the height. Now, you don't actually need to calculate, okay, just maybe a single wall, then another wall, then another wall, okay, adding them, it will take much time, okay? If you remember previously, okay, in maybe in the last video, or maybe in the last lecture, we have already calculated these things, okay, using Excel sheet. So you have to do all those things in the same Excel sheet, and then the analysis, for the analysis, the quantity of the work should be taken, okay? This time I'm assuming a wall only, okay? So we are just required to determine different materials for the whitewash. And as you can see, we are informed to have 3 coats. We're here, you can see it. So the coats are 3. And this is actually just a fresh plaster surface, okay, or fresh plastered wall. All right, in the solution, I should have the whitewash area, which should be actually 15 times 5. It is just simple, okay? It is just a rectangle. That's why we have just learned about areas, okay, in the very first lecture. And 15 times 5, that is actually 75 square meter, okay? It is just clear. Now, we will just calculate the quantity of the lime, which means unslacked lime, okay? Unslacked lime is just, you can say, required. So the lime, for the lime calculation, you should remember those points. Here, as you can see, we have 3 coats. It means we'll be just using the point number 3, okay? It means 3.5 kg per 10 square meter. Okay, we will take the 3.5 kg, and that is actually we will divide that by 10 because the unit work is just 10. Okay, and our quantity, or you can say the surface, that is just more than 10. Okay, so it means 3.5 divided by 10, and we will multiply the total whitewashing area. Okay, that is 75. Just it is just simple math. Okay, you have to just multiply 75 times 3.5 and then divide it by 10. So you must have 26 kgs lime. It's a pretty good. Okay, very simple. So for the same wall, 26 kg or maybe more, like, okay, because we have 0.25, it means if you take it like maybe approximate, so you have to just buy 27 kg of the lime, okay? Next, we will be just determining the glue for the same work, okay? And now for the glue, we have to remember the same point, okay? Which is actually 0.12 kg. Again, 0.12 kg divided by 10, because 0.12 kg that is just for the 10 square meter work, okay? And however, we will multiply that with 75 because that is the total whitewashing area. And this should be actually 0.9, which is approximately taken is 1 kg. So for the same work, as you can see, we have 27 kg is the lime and 1 kg is the glue. Pretty cool, okay? It is very easy. Is there any question?
No, sir.
Okay, because it's very easy and you guys, I think, are already familiar with these things. Next, I'm gonna have some work with the floors, okay? You can say farsh in Urdu. Now, floors can be different types. There can be floors of tiles, okay? There can be stone chips in the floor. Okay, the floor can be of PCC one. The floor can even be RCC. Okay, just you can say for the maybe for the factories. Okay, because there we may have heavy load, so RCC floors are constructed. Okay, and so on. You can say ETC. Okay, so floor can be of different types, and because of that, the analysis can be different. Okay, however, we will have just an example to clear the idea. We will not spend much time on each floor type. Okay, so let's move ahead, and let's say if we have the same very simple. Okay, let's say this is the section of a floor whose area is just 30 square meter. Okay, this is the total area. You can consider a room maybe, which is actually like AB. Okay, now A times B, that is actually the same thing as 30 square meter. So the section is given, and we are asked to calculate materials for the given floor section. Now, subbase, you can see subbase is actually brick ballast, and then we have base is concrete, which is actually 136, and the topping, that is actually cement and then stone chips. Okay, and that is 1:3. Okay, we have already covered the concrete, which is 136. However, we have not yet covered about the stone chips. Okay, so topping, that is very important, and the brick pillars. Let's just move ahead toward the solution. And in the solution, as you can see, the brick ballast can be which is in the subbase, and that can be actually in terms of volume. Okay, and if you remember, we have already covered volumes in the second lecture. Okay, this is the reason I have covered those things, area and volume. Now, what should be the volume? The cross-sectional area, or maybe the top area times the thickness. Area is given, okay? The total area, or you can say the total floor area, that is just 30 square meter. Okay, and then we will multiply the same area with the thickness, which is known, and it is 12 centimeters. Okay, so this is the quantity of brick ballast. As you can see, we have the total floor area. Okay, that is just 30 square meter, you can say, and we will multiply that with the thickness, which is 12 centimeter, or you can say 0.12 meters. Because if you see 1 meter, that is just the same thing as 100 centimeters. Okay, so in order to convert centimeters into meters, you have to divide that by, you can say, 100. centimeters. Okay, so we have 12 centimeters. It means 12 by 100, which is the same thing as 0.12. Okay, that's why we have 30 times 0.12. Okay, multiply these two, we should have the break ballast in the subbase maybe, and that is actually 3.6 cubic meter. Okay, which is a huge video, cubic meter, because the floor is very wide. It is 30 square meter, maybe like a hall. Okay, it is a huge hall, you can say. Now, you may have question about the compaction factor. Like maybe if we have thickness, like let's say if this is floor and if we have 10 centimeter thickness, now after compaction, the thickness may decrease to 8 centimeters, maybe 5 centimeters. So why I'm not taking that? Because we don't compact brick ballast, okay? This is the reason I'm not including the compaction factor. Because if you compact brick ballast, they may become very small, okay, and weak. So this is the reason. As you can see, we have the subbase, and in the subbase, we have actually the concrete work, which is 136. Okay. Now 136, or maybe the concrete work should be actually 30, which is the total area of the floor, and again times 12 centimeter. Okay. This is concrete, very simple, or you can say 0.12 meters. Okay, multiply these two, we should have 3.6 cubic meter. Now, it is the same thing as the wet concrete. We have to multiply the wet concrete with 1.54 to convert this into dry, okay? And then from the dry volume, we can calculate cement, sand, and crushed stone, right? It is the same thing as PCC work. So moving ahead, the material, it is the same formula, okay, just discussed many times in the previous video, so we will not waste our time over here. Now the cement can be calculated. For the cement, the ratio of material can be taken, okay, which is actually 1, because we have ratio is 136, okay. In the same ratio, 1 represents the cement ratio, okay. So 1, and we will divide this by the sum up ratio. The sum up ratio means 1 plus 3 plus 6, and that should be actually 10. Okay, so 1 divided by 10 times the dry volume. Now the dry volume can be very interesting, but we have already just covered it. Okay, that's why I'm not gonna spend much time again. Okay, the dry volume is actually, you can say, the wet volume times a factor, and that factor is actually 1.54. So we may have the dry volume is 5.544, okay, cubic meters. Now, what's 1.54? We have already just covered that, okay? I'm not gonna repeat that again because you guys are not asking me that. It means you are clear about this, okay? So the quantity of cement can be 1/10 times the dry volume. It means the quantity of cement should be now 0.5544 cubic meters, okay? Now, this is in cubic meters. You have to convert this into the bags, okay? For that, you should know the volume of one cement bag, which is actually, we're here in Pakistan, that is just 0.035 cubic meters. Very simple, okay? So divide that by 8, and it should be 15.8 bags. You can say 16 bags, okay, for the same floor. Now, the sand can be calculated from the quantity of cement. Now, the quantity of cement that is just 0.5544. Multiply that with the ratio of sand, which is actually 3, and that should be the same thing as 1.66. Now, the crust stone can be calculated. Okay, crust stone, that is just known by the budgery. Okay, in many countries, maybe like Pakistan, Afghanistan, India, okay. So budgery is just used for the crust stone, or maybe for the coarse aggregates. Now the quantity of budgery can be actually the quantity of cement, which is 0.5544, and we will multiply this with the ratio of the crust stone or budgery, which is 6 in the ratio, okay. So it is actually the same thing as 3.326 cubic meter. This is it. Very easy. Okay. All right. Next, we have another problem. which is actually the topping. And this is very important in the same topic because we have already covered the subbase base, okay? Subbase and base. That's why I just did it very fast. And however, I'll take some time with the topping, okay? Topping, that is just known by the top surface of the floor, you can say, okay? And that is just constructed of the stone chips and cement mixture, okay? Like in cement mortar, what we have is actually the cement plus sand. And stone chips, or you can say it is just like a mosaic floor, okay? Where we have cement and then stone chips, which are just 5 mm in size. Okay, so again, the topping stone chips, that is 1:3. It means 1 is just the cement and 3 times of stone chips is taken. Very simple, okay? Now the total area that is just given. So the total wet volume can be calculated the same thing as the area times the thickness. Okay, area is known 30 and the thickness that is just 4 centimeters. Or you can say 0.04 meters. Now the volume is actually 1.2 cubic meters and we can calculate actually the materials. The same formula can be used. Ratio of material divided by sum of ratio times the dry volume. Now, in order to calculate the quantity of cement, it is the same thing like 1/4, because 1 is the ratio of material, 4 is the sum of ratio, are the same topping, okay? And this is actually 1 plus 3. So we have actually the sum of ratio, and that is just 4. So 1/4 times the dry volume. And dry volume, it is just the same thing. Is we did it maybe in previous videos or in lectures. The topping actually is the same thing as cement mortar, okay? Because we have only two materials, the cement and the stone chips, okay? If you have the budgery or cast stone, then you have to use 1.54 because that becomes then maybe concrete, okay? This time it's like a mortar because we have only two ingredients, okay? So the wet volume times 1.27. Now what's 1.27? We have already covered this, okay? So the wet volume that is known 1.2 times the factor. So we have the dry volume equals 1.524 cubic meter. We will just bring this video over, okay? So we have the quantity of cement, which is actually 0.381 cubic meters, okay? Now divide this by the volume of one cement bag, so we can have the quantity of cement in cement, you can say in number of bags maybe, okay? All right, so now we have the cement bags, which is 10.88 bags for the same topping only. And next we have actually stone chips, which are, you can say, just small stones, okay? You may have seen these things on site, maybe in your home while constructing floors, okay? So the stone chips should be the quantity of the material divided by the sum of, the ratio of the material divided by the sum of ratio times the dry volume. However, we can also calculate this by the shortcut, which is the cement quantity that is just known. We have calculated that few seconds ago, times the ratio of stone chips, which is actually just 3, you can see that, okay? And this becomes actually now 1.143 cubic meters. It means for the same floor, which is 30 square meter, we have different materials. The brick ballast, we have actually the cement, which is 15.8 bags. We have actually the sand, and then we have the budgery. Very easy, okay? And then actually in the topping, we have cement and then, of course, stone chips. Is it clear? Is there any question? You guys can hear me, right?
ये स्टोन चिप्स जो होते हैं सर,
Yes.
इसमें सिर्फ सीमेंट सकते हैं एज अ बाइंडर.
Yes, exactly. We have cement and stone chips. Because in the ratio, we have only two ingredients. Okay, this is 1:3. There can be another ratio as well, no problem. And you have to then calculate materials based on the same ratio. Like if there is maybe ratio of 1:2, okay, where there can be cement, okay, and there can be actually sand, and there can be stone chips. So these three things. Then you have to just put the ratios for the same material calculation. It's the same process can be used, okay? Let's move ahead. And next we have actually the pointing. Okay, are you guys familiar with pointing? It is the same thing as plaster, but we do not cover maybe the brick faces, maybe the headers, maybe the stretchers of the brick, okay? So we don't cover them. We just fill the joints, and then that is just known by the pointing. And these things are very famous in the construction of the, you can say, walls of the government buildings, maybe you can say, okay? And let me just show you the diagram. You can see it. We have the, let's say this is brick, and here the joint is just filled with the mortar. You can see that. There are a bunch of types, okay? However, these two are very common, so I have just picked them, okay, up in the same presentation, okay? One is just actually the deep stroke pointing, and then we have the flash or flush pointing. So these two are commonly used, okay, for buildings. That's why we will just cover them only. The process or maybe the analysis for the same pointing is actually the same thing as the analysis for plaster work. Now, what we do in plaster work is actually we determine the wet volume, then we determine the dry volume, because plaster is actually just the same thing as mortar, okay? And then we, of course, we determine the cement and then the sand. We actually repeat the same process for the pointing. However, in plaster, the thickness of the plaster and the thickness of the pointing can be different. Okay, what should be the thickness for the deep stroke pointing? It should be 13 mm. And for the flush pointing, it should be 6 mm. Is that clear? Okay, so we have some message in the chat. No sound, sir. I'm just in hurry, and I will just do one more topic, and then we will end the session, okay? So in the pointing, we have these two types, okay? Deep stroked, okay? Here I have just mentioned stroke. It is just actually deep stroked, okay? And then the flash pointing. So you have to use 6 mm thickness for the flash and 13 mm thickness for the deep stroked, okay? Okay, let's just have an example. You guys can see the screen, right?
Yes, sir.
Okay, here we have a flash pointing, and it is, you can say, 800 square feet. Okay, the area that is just 800 square feet. Now the cement mortar, that is actually 1:3. I think this data is just enough to determine different materials for the same pointing, okay? Now, you have to use 800 SFT, I mean the same area for deep stroke pointing. And then you have to send me the quantity of cement and then the quantity of sand, okay? Let me just calculate these two things for the same pointing. Okay, what we have is actually we need the volume of the pointing. For that, we will just multiply the area of the pointing with the thickness, okay? The area that is just known, which is 800 SFT. And the thickness that is also just known, okay? If you remember, we have noted it, right? And that is actually 1/4 inches, or maybe if you remember, it was just, you can see it, okay? 6 mm. So 6 mm is just the same thing as 1/4 inches, okay? For the deep stroke, you have to use 1/2 inches, no problem, or you can say 1/2 inch. Okay, so now the volume must be area times the thickness. area is known at 100. The thickness is 1/4 inches. But if you see the area, that is in square feet. However, the thickness, it is just 1/4 inches. It means we have to convert inches into feet first, okay? That's why we have to divide this by 12, okay? Because 1 feet means 12 inches. Now, area times thickness, that should be 16.67 CFT. Very easy. Now, once we have the volume, it means we can easily calculate the materials. It is just the same formula, okay? Like the cement equals the quantity of the material, the ratio of the material divided by the sum of ratio times the dry volume. It means we need the dry volume, okay? Now, it is the same thing as the mortar. So in order to determine the quantity of dry volume, we have to multiply the wet volume with the factor, which is 1.27, okay? Now, never ask me where 1.27 comes from, okay? Because we have already covered it. So it means the dry volume is now 21.167 CFT. Very easy, okay? And now we will be just determining the cement for the same pointing, which is 800 SFT. So the cement must be the ratio of the cement, which is 1, divided by the sum of ratio, which is actually 4, and times the dry volume, which is 21. Okay, just do some maths. We have actually 5.29 CFT, and you can even divide this by the volume of 1 cement bag to have 4.23 bags. Okay, and the volume of 1 cement bag over here in Pakistan, it is actually 1.25 CFT. So by dividing that volume by 1.25, we can have 4.23 bags. And next, sand is very easy and straightforward. So sand must be the quantity of the cement, which has just been calculated. You can see that, times the ratio of the sand, which is 3. Okay, you can see it is just 3. And just multiply these two, we have actually 16 CFT approximately, okay? Which may be 15.8 or 9 something. That's why I have written 16 CFT approximately. So this is how we can calculate different materials for the pointing. If there is any question, I'm ending the session.
ये 1/12 you can ये क्या है 800 multiply you can 1/4 multiply 1/12.
Okay.
1/12 confused.
That's a good question. Okay. As you can see, we have 800. Okay. That is in square feet. But 1/4, that is in inches. It means we have to convert inches into feet first. Okay. That's why we divided it by by 12. Okay, if there is inches, you can say, let's say we have 6 inches, and you need to convert this into feet, you have to divide it by 12. Okay, it becomes 0.5 feet. So similarly, we're here, you can have the same process. Okay, is it clear?
No, sir.
Okay.
Again.
Okay. Let me have another slide, okay, so I can make you understand.
Okay, sir.
Just a simple one, okay. Let's have another new slide, and then you can see the screen, right? It is just simple conversion. It means, if you remember, 1 feet is just 12 inches, okay? It's simple. Now, in order to convert inches into feet, you have to divide the video by 12. Let's say we have 3 inches. So in feet, what should be the video? That's the reason we have to divide 3 inches by 12. And that then becomes 0.25 feet. Okay. So similarly, if we have 1/4 inches, you have to divide the same thing by 12. But we cannot write it in the same way, in the same form mathematically. So that is the reason I have put this video over there, in terms of 1/12. What do you guys see now? Is it okay?
Yes, sir. Okay, sir.
Oh, okay.
Right.
Never be confused with it. Okay, I'm gonna change this thing to in simple form. Okay, let's say we have 1/4 inches. What do you mean by 1/4 inches? It means 0.25 inches, right?
Yes, sir.
1/4 inches means 0.25 inches.
Yes,
Now,
sir. Right.
now you have to divide 0.25 by 12. Simple. Okay, so it is the same thing. Is it clear now?
Yes, sir.
All right. Is there any question now?
यस सर
And what is it?
सर जिस तरह 1 सैकड़ा बराबर होता है 100 क्यूबिक फीट का
Yes.
तो 1 सैकड़ा कितने क्यूबिक मीटर का बराबर होता है
Very good, very good. I'm not gonna tell you the exact video, but I'm gonna just convert it to you so you guys can even work it for. I know the video, however, but let me just convert it for you, okay? And how do you convert actually it? Okay, without just it is actually like approximately 2 point. Wait a minute, it is 2.83 cubic meter approximately. But let's just work out it. Okay, we have 100 CFT. Okay, you have to divide this by 3.281 cube because 1 meter means 3.281 feet. That's just clear, okay?
Yes, sir.
So 100 divided by 3.281 cube actually becomes 2.83 cubic meter. So 1 sacra is now the same thing is 2.83 cubic meter or just 100 CFT. Okay, guys. See you tomorrow, inshallah. Allah Hafiz.
Okay, sir. Thank you.
All right. Let's get started. And what we have done actually in the previous video, it was about the material analysis, okay? And we have already discussed the MRS2, if you remember. Market rate system or then market rate schedule. Okay, now we will be just switching to the material estimation for roads, okay? You guys can hear me? Please confirm it.
Yeah, here.
And actually, here can be almost, you can say, 3 types of roads, okay? Earthen road, everybody is just familiar with these things, but let me just recommemorate these to you. So we have earthen road, and actually we have 2 types, okay? And then another one, this is known by the Pakka road, maybe, okay? This is Pakka road. However, in Pakka road, we have actually rigid pavement, and then we have the flexible pavement. So in the same video, we will be just covering all these 3 types of roads. And I will just start by determining the quantity of different materials in you can say earthen road. And we will have just a simple example over here. You can see I have just this water-bound macadam road, okay? So let's say we have an example and the road length that is just known, okay, which is 1 kilometer. This is simple. Now, the water-bound macadam road and some components, everybody should be familiar with the components such as subgrade, subbase, base, and then maybe surfacing or topping. If you don't know about these things and what they are made of, you can watch a, you can say a separate video on my channel, okay, related to road structure. This time we are just learning quantity surveying, okay? So I'm not gonna discuss all the terminologies related to road. All right, so we have the base, which is actually 3.5 and that is meter, okay? So this is just the breadth or maybe the weight of the base layer. And the base layer that is 10 centimeter thick. And we have, of course, the sub base, which is 20 centimeter thick. And actually those extensions, those are 50 centimeters or maybe you can say 6 inches, okay? And to the other side, I mean, to both sides of the base layer. So we can have actually the weight of the sub base. That's very simple. All right. just move ahead to the solution, and in the solution, as you can see, we can have this solution in a table, in a nice table. You can even calculate these things in Excel format. Okay, next example will be in Excel. So we can learn how to use Excel in order to determine the quantities of different materials in road. Okay. All right, let's say we have the same table and you guys are just familiar with this because we have done this thing before, even before, okay, for the building estimation. The first thing which we have is actually the description, then we have the number of the member, length, breadth, height, and then the quantities and remarks just for detailings. And the first thing, as you can see, we have subgrade. It means that subgrade preparation is important. Okay, you can say the dressing up subgrade, and if there are any trees, maybe rocks, okay, those are just removed. Even at this stage, you can say in preparation of subgrade, gradient and camber is just considered, okay, this layer. So subgrade can be actually the natural ground level as well. But when you prepare that, then that is just known by the subgrade. Is that clear? Hello, is it clear?
Yes, sir.
Okay, so by subgrade preparation and dressing, I mean everything related to subgrade, right? And in number, this should be 1 because we have only one road that is just earthen, or you can say water-bound macadam road. And that should be 1. Now, the length of the road that is known, which is 1 kilometer, it means just 1,000 meters, because the other information, we will be just converting them into the meters. That's why the length should be in meters as well, okay? Now, the breadth of subgrade, that is just known if you see in the diagram, that is 3.5 plus 15 centimeters and 15 centimeter to another side, okay? That means the breadth of the subgrade should be 3.8. And that's because if you see, we have 3.5, that one, we will add 15 centimeters to both sides. And this is the same thing, okay? As you can see, we have 3.8, I mean. And the height of subgrade. So subgrade is a surface, you can say prepared surface or dressed surface. So surface does not have actually thickness or maybe the height, okay? So it means there is no thickness or height. It means the subgrade is calculated in terms of area, okay? That's why area is very important, okay? So we will just multiply these 3 columns in order to have the quantity of the subgrade. And this should be actually 3,800 square meters. This is very simple and straightforward. Next, as you can see, we have the subbase, which is, you can say the first component, or maybe the second component, just laid above the subgrade, okay? So for the subgrade, subbase material, it means just providing materials for subbase. And by providing, I mean, okay, having materials according to the specifications. Okay, you have to look or read the specification for the same layer, okay, which is subbase. Okay, so subbase material means just to carry or just to buy, okay, just to bring materials on the roadside, okay, according to the specifications. Again, in number, it should be 1. The length is just 1 kilometers, okay. The subbase width or breadth, that is just the same as subgrade, okay. However, there is a height which is actually 20 centimeters, okay. Now here is a point. I'm not going to take 20 centimeters. Why? The height should be actually something different, okay, which should be 0.30. Now why? It is very important. As you can see, the 20 centimeter or maybe 10 centimeters, okay, these values are according to the drawings, which means they are already, you can say, considered as constructed road, okay? So it means there can be consolidation or maybe compaction of the material. And after compaction, as you can see, we lose the depth of the layer, okay? And this shortage or maybe this decrease can be actually 50%, okay, after compaction. I mean, if we just lay materials, let's say if the materials are laid for 20 centimeters. Okay. After compaction, they will become actually 10 centimeters because there are voids, okay, in the materials. So when you compact it with rulers, maybe then 20 centimeter become actually 10 centimeters. That's why in advance, it's necessary to add 10 centimeters. Okay. Now, as you can see, we have 20 centimeters. So in advance, we will add actually 10 centimeters more. It means half of the depth. Okay. So half of the depth must be added. That's why I have just added 10 centimeters. Okay. With 20 centimeters. So we have actually, as you can see, 30 centimeters or maybe 0.3 meters. Okay. And this is the same process. So just multiply these 4 columns. You can say the numbers, length, breadth, and height, and we will have actually the quantity, and that's in cubic meter because this is like maybe we have thickness, so there is volume, right? And next we have actually labor for spreading and consolidation of the. Now, if you bring in when you have materials on site, okay, maybe we carry materials. The carriage is just done using dumpers, okay, and then locally you can say dynas, okay, loaders maybe. So they are just you can say unloaded on the roadside. Now, labor is required to spread those materials according to the specifications, you can say, okay? Or you can say according to the given dimensions. And this is so simple, okay? So this thing, now, it is very important to know that the materials which are just, you can say, brought should be spread, okay? So the same material just spread, it means the quantity should be the same as the sub-base material. It's very simple. Next, we have actually, and this is the same thing, okay? And next, we have actually the base layer, which is, you can say the top layer for the water-bound macadam road. And the process is just the same. We can have 1 in number. The length is just 1000 meters, because it is just 1 kilometer, okay? 1 kilometer means just 1000 meters. And as you can see, we are just doing everything in meters. That's why we do this conversion, okay? Now, as you can see, the width that is known, 3.5. However, the depth, that is just 10 centimeters. I'm not gonna take 10 centimeters this time, okay? I'll just take 15 centimeters. Why? Because half of the depth must be added to the original depth due to compaction factor, okay? We have compaction. So it should be 0.15 meters or maybe 15 centimeters. Now multiply these 4 columns, we can have 525 cubic meter is the quantity of base material, you can say, okay? And the material for base should be based on the specification, okay? You have to look for the size and many more specification, okay? Before just bringing or maybe buying the material for base layer, okay? Now even labor is just required to spread the base materials, okay? And this is going to be the same quantity as the base layer materials. So same quantity. And why same? Because when you buy something, or maybe if you have the same material, those material is just spread, okay? No extra material or no shortage of the material. So that's why we have the same material or maybe the same quantity. And this is 525, okay? Now, once you have these quantities, you can see these quantities, then abstract of cost is just prepared for the road construction or maybe for the road estimation, okay? So let's just move ahead for the abstract of cost. And remember, for this, you have to use MRS. And if you remember, MRS is just been covered in previous video. So I'm not gonna discuss MRS again and again because there's gonna be just wastage of time. You have to look for the same materials in MRS, and then you have to look for the composite rate or maybe for the labor rate, okay, in the same MRS. This time, I'm gonna just assume some rates, you can say, okay, for the same work. So we can carry the abstract of cost, okay? Let's see, as you can see, we are going to just prepare the abstract of cost. And the same thing, we have quantities, you can see it, okay? So we will just add description, then quantities, then again the unit of quantity, of course the rate, and then we have actually the total amount in RS, okay? Now the first thing, as you can see, we have the preparation, you can say the dressing or subgrade. Now the quantity, it was just actually 3,800, and the unit, it is the same thing, okay? However, let's say we have the rate, which is 20 rupees per square meter, okay? It means R is 20 per square meter. Now, it means you have to just multiply this with this, so you can have the total amount. Okay? Very simple. It's nothing complicated. And I think I should just move ahead very quickly, because this is going to be just the wastage of time discussing these things. This is just basic. Okay? Now, supplying material based on the specifications of the sub-base material, and the unit is again cubic meter, and the rate, let's say this is 210 per cubic meter. It means we will just multiply the quantity with the rate, so we can have the total amount, just the same thing, okay? And the labor for spreading and consolidation of sub-base material, we have the same quantity in cubic meter. The rate is just different little bit, and just multiply the quantity with rate, so we can have actually the total amount, and so on. Okay, you can do it just by yourself. It is just very straightforward. So this is how we can actually prepare the abstract of cost, and then actually prepare the material estimation for a waterbound macadam road. Okay, now I'll be just jumping any actually in AutoCAD, and we will have a nice drawing of a road, okay, over there, and then we will prepare the abstract of materials in Excel. Okay, but before starting date, let me ask you if you have any question related to this problem.
So the labor for spreading and consolidation of sub-base material. ये अगर उर्दू में बता दे तो समझ आ
अच्छा
जाएगा।
ठीक है, मैं उर्दू में समझा दूँ आपको। अच्छा, क्या होता है ना कि सब ग्रेड जब तैयार हो जाए ना, तो हम क्या करते हैं, सब बेस लेयर के लिए या फिर बेस के लिए हम
سره د اردو نه په خیر ده چې په پښتو کې شنو خبرې مهرباني وکړئ افغان کسان به هم صحیح پوه شي خپه کېږئ نه
असल में मसला ये है ना कि ये जो इंटरनेशनल स्टूडेंट है, इनको फिर समझ नहीं आएगी ना, तो
अच्छा
यही
अच्छा अच्छा उसमें है ऑलरेडी स्लाइस ठीक है सर नो सर
यही मसला
कोई
है ना,
बात नहीं
इन लोगों को फिर समझ
ओके
नहीं
सर
आती। तो
ओके सर कोई बात नहीं सर ना
अच्छा, तो असल में
ओके
जो हम कहते हैं ना, रोड़ा कहते हैं शायद हम ना, जो आपके लिए कोर्स एग्रीगेट होता है, तो कोर्स एग्रीगेट को हम फिर डंपर या लोडर के जरिए ले आते हैं, जो कि रोड साइड है उस पे, ठीक है। तो वो अक्सर मैं जरा इसको ड्रा करूं तो शायद आप लोगों को ज्यादा बेहतर समझ आ जाए। एक सेकंड, मैं जरा ड्रा करूं इस चीज को, तो ग्राफिकली मेरे ख्याल से समझ आ जाएगा आप लोगों को। फिर यू मेरे ख्याल से वो समझ मुश्किल है। अच्छा, ये देखिए जरा, ये मेरे पास है, लेट्स से यहाँ पे हमने रोड बनाना है, ठीक है, यू। अब हम क्या करते हैं कि मटेरियल्स को ले आते हैं और यहाँ पे यू डाल देते हैं, इस तरह इस फॉर्म में कुछ यू डाल देते हैं, ठीक है। ये सवाल किसने पूछा था?
जी मैंने
जी, किसने पूछा था सवाल भाई? वो बंदा सुन भी
जी
रहा
सर
है या
मैंने
नहीं?
पूछा।
तो हम क्या करते हैं, इस लोडर के जरिए ये मटेरियल ले आते हैं ना, और यहाँ पे फिर अनलोड कर देते हैं यू। अब इन
जी सर
मटेरियल्स को भाई स्प्रेड भी कर देना है। उर्दू में इसको क्या कहते हैं, स्प्रेडिंग को, मतलब हमवार कर देना है इस जगह में, ये सारे बेट में यू हमवार भी कर देना है ना इन मटेरियल को।
जी सर
तो इन मटेरियल को कौन हमवार करेगा? लेबर ये है इस काम के लिए भाई, ठीक है।
जी सर
या डिफरेंट इक्विपमेंट्स हैं हमारे हमारे पास रोड के लिए, तो वो इक्विपमेंट कौन चलाएगा, ऑपरेट कौन करेगा? लेबर ही करेगा। इसी वजह से
जी सर
हम लेबर कास्ट को कैलकुलेट करते हैं, क्योंकि इन मटेरियल को स्प्रेड किया जाता है। अगर आप सेक्शन में देख ले तो किसी महसूस डेप्थ में इनको हम क्या करते हैं, स्प्रेड कर देते हैं। इसको कहते हैं लेबर फॉर स्प्रेडिंग, ठीक है।
ठीक है सर समझ आ गया।
चलो, गुड हो गया। ओके, मैं इसको ख़त्म कर दूं। अब मेरे पास ऑटोकैड में आप लोग इस सेक्शन को देख ले ज़रा। ये एक सिंपल सा सेक्शन है जिसमें सबग्रेड, then we have sub base, and then you can say topping or surfacing, okay, which is just TST, okay, triple surface treatment, that is just known by that. And you can see we have NSL, which is this level, you can see that, okay, and we have side slope, which is 3:1, and there is actually footpath, and then curbstone, and as you can see the carriageway, that is 25, and we have actually some electricity pole, okay, and this road is actually 3 miles long, and we are asked, let's say, to prepare the abstract of material for the same road section. So let's just do it, and I'm gonna do this in Excel over here, okay. Now, in order to determine different materials for the same road in Excel, let me just have that same table over here. Let's say serial number, then we should have description. My typing is a little bit slow, ignore it. And then we have the number, then we have the length, and then width or breadth maybe, then height, and let's say quantity, and then we should have remarks. I'm gonna just have a little bit the same thing, okay, just like this. And let's just apply wrapping to all. Let's say have some settings so we can do it a little bit quickly. Okay, serial number first, it should be 1, and in the description I'm gonna have some nice description for the subgrade, because the first thing is just to prepare the subgrade, okay, just the same way as we did few minutes ago for the waterbound macadam road. So let's just say if I'm gonna type that the preparation or maybe preparing a subgrade, and this actually include, let me just write, including camber and gradient. Now you should be familiar with camber and gradient, okay? And let's say etc. Okay, this is pretty good. So we'll be just preparing the subgrade for the same road, and now the preparation must include preparing the camber and gradient, okay? Because in high quality roads, normally in low quality roads, we provide camber and topping only. However, in high quality roads, the camber and the gradient, that is just considered even in subgrade preparation, okay? So in number, it should be only 1. Now, length of the road. What should be length of the road? Remember, it should be, you can see it is just known, okay? We're here in the drawing. Let's say that is just 3 miles, okay? But the other dimensions, those are actually in feet. That's why let's just convert miles into feet, okay? Now, how do you convert miles into feet? For this, you should know that 1 mile means 5,280 feet, okay? So 3 times 5,280 feet. That means it is just 15,840. That is actually the length, okay? So which is 15,840 feet. And this is what we want, okay? So this is actually the total length of the road, you can say. Now, breadth of the same thing, it should be given, okay, over here, as you can see. And this is also known by the lane width, okay? If you're a little bit familiar with terminologies related to road, okay? There can be different terminologies such as carriageway, land width, formation width, and so on. Curb, okay? Footpath, side slope, side drain, and many more, okay? So we have, as you can see, the width of, you can say, land width, that is 41 feet and 6 inches. And this is actually, you can see it is the total thing, okay, up to the 2 point, okay, of this slope, or you can say side slope. So we have this thing is the land width, which is for 41 feet and 6 inches. It means 41.5. Now the height, what should be the height of subgrade? It should be 0, okay? There is no height, you can say, because subgrade is just a natural ground surface which is just prepared, okay? So we do not consider the height for a date. This is very easy and straightforward. So the quantity should be actually, if you see, we have to multiply these 3 columns or maybe the 4 columns, but this time we do not have anything in the 4th column. So that means the breadth times the length times the number, okay? This should be actually the quantity. Now the quantity must be, let me just have another column over here for a unit, okay? Because it is also necessary to have unit over there. And let's say this column is just for unit. Now this should be in square feet, okay? Because this is just a surface and we have only 2 dimensions in the same calculation. So we have done the preparation of subgrade. Now next, number 2, we have actually the subbase material. You can see, okay? It is just known over here. This is subgrade, okay? And above subgrade, we have actually subbase. And that is, if you see, it is 9 inches and 2.5 inches down size, okay? It means this is just the size of aggregate. So let's just say maybe providing subbase material, and this should be according to the given specifications. And maybe you can say, even when you provide these materials, it is very necessary to stake them, okay, on site. And staking the, you can say on the road side, maybe on the road side, okay? So you have to stake or maybe store these materials, okay? Or maybe you can say unload these materials on the roadside, and then that is just spread by the labor, you can say, okay? And number, it should be 1. Length should be the same because it is just a road, okay, of 3 miles. Now, what should be the breadth? This is very important. You have to look for the dimensions. As you can see, this is actually the subbase, and over here we have 2 dimensions, okay? Up to this point, it is actually 41 feet and 6 inches. You can see it, okay, up to this point, this dimension actually. But over here we have slope at both ends, and these are the side slopes, okay? It's just, you can say, forming a trapezium, if you remember the area of trapezium, okay? So it means we have 2 types of, you can say, width or maybe depth, breadths, which is 41 feet and 6 inches, and another one that is actually 37 feet, okay? So which one should be taken? None of these. We have to take the mean one, okay? Just add these both and divide it by 2, so we can have the mean breadth. And that should be actually, if I'm not wrong, 39.25. You can even just use Excel for this approach, but I think calculator is better so you guys can understand the problem, okay? We have, as you can see, 41.5 plus 37, and we will just divide this by 2 because we need the mean one, and that is 39.25, okay? You guys can hear me? Anybody confirm it, please?
Yes, sir.
Okay, that's good. Once we have the breadth, there is thickness for the subbase because we are calculating materials for the subbase this time, okay? And what should be the thickness? It is already known over here, as you can see, 9 inches subbase. But should we take 9 inches or not? Of course not, because this depth should be increased, okay? Like the same way as we did for the waterbound macadam road. Now 9 inches means 0.75, okay? And it means we will just add half of the depth, okay, is extra, because after compaction, we lose some depth, okay? So we should have compaction factor over here. And we will just add half of this, which should be maybe
0.375.
Yeah, 0.375. Okay, that's good. Thank you so much. And plus 0.75. It should be 1.125. Is that clear?
Yes, sir.
All right, 1.125. Okay, so this is actually the depth. Now, what should be the quantity? We will be just dragging the same formula over here. But if you remember, this formula does not include the height. So let's just include height as well. Okay, so we will multiply this thing over here with this and press enter. Now, this is the quantity. And as you can see, we have 3 dimensions. It means this is in CFT. And then we have actually number 3, and we should calculate labor to spread these materials, which are already, you can say, broad, okay, to spread the subbase materials. And this should also be according to the specifications, or maybe according to the dimensions given, okay? In number, it should be 1. And as you can see, the quantity should be the same, okay? Because what you buy is eaten by you. So what you bring, or maybe what you unload on the site, that is just used by you or spread by the labor. It's just clear, okay? And then we have actually number 4. And number 4 should be actually the base material, okay? Because above sub-base, we have the base layer, and that is 4 inches. You can see that, okay? 1.5 inches down size. So let's just say that number 4, that is just providing the base material. So I'm going to copy that, and let me just rename this into base layer. And this is according to the specification and stacking date on the roadside, okay? So that's simple. In number, it should be 1. The length should be the same, 3 miles, you can say. And what should be the width, or maybe the breadth, you can say. This should be actually, as you can see, different. Now, this layer, which is just selected, this is now actually the base layer. And over there, we have actually side slope on both sides. And because of that, we have actually 2 dimensions. One is just 37 feet, and another one that is 35 feet. You can see that, okay? So we have to take average of these 2 again. It means 35 plus 37 and divided by 2, so we can have 36 is the average, or maybe the mean width, okay? So I'm gonna put 36 over here. That's very simple. Now we have 4 inches is the depth, or maybe the height. So it should be increased, or maybe half of the depth should be added. Okay, it means 2 inches should be added again, because we have 4 inches the depth, and after adding 2 inches, it becomes 6 inches. That means 0.5 feet. And we will just drag the formula. And actually, this is in CFT because this is volume, okay? Now, we have to spread the same material. That's why I'm just gonna copy that thing and paste it over here so we can have some time, okay? So we will be just spreading the base materials and according to the specifications, you can say. Now it should be the same. I'm not gonna repeat it again and again because I don't want to be a little bit tired or maybe more tired, okay? So it is just the same because what you have brought should be spread out, okay? So this is number 5. So, and these things are actually, if you remember, it is the same thing we have just done maybe some time ago for the water-bound macadam road, okay? However, in water-bound macadam road, there was no topping, or maybe you can say surfacing. This time, as you can see, we have surfacing. And there is even timber over there, okay, which is 3%. Now, this, as you can see, which is just selected, and there is arrow, okay, which is drawn over there, okay, leading to this information, which is TST, or triple surface treatment, okay? Now, this is actually 3 coats treatment, which may include bitumen, and then maybe you can say bajri or crushed stone, okay? It means it is just flexible pavement. Okay, so we have to say, let's say number, where is it? Number 6, I guess. Okay, number 6, and number 6 we have actually triple and surface treatment. You can just type TST per there, and even right here surfacing. Okay, so you can understand this is just topping. Now, in the same triple surface treatment, there can be two types of material. Like, let me just say, number one, there can be maybe cruststone. Okay. Now, the quantity of cruststone, it can be different. And this actually depends on the mix design. Okay. So it can be different. However, let's say, according to specifications, we have 9.75 CFT, and we will have that per 100 SFT work. Okay. So let's say this is just the quantity of cruststone. Okay, which means almost 10 CFT cruststone should be used for 100 SFT road surface, or maybe topping. Okay, and we must have actually bitumen. Okay, now how much bitumen is required? It depends on the design. However, let's say we are given that the quantity of bitumen, that is 79, which is almost 80 pounds. Okay, LBS are pounds, and this is actually, let's say, per 100 SFT. Is that clear?
Yes, sir.
Okay, now the length is the same. Okay, so I'm gonna apply that length to I mean each cell, or maybe to each row. Next, we have actually the breadth, and as you can see, we have 25 feet is the width of this layer. You can see that. Okay, it is just represented with yellow line, and as you can see, we have 25 feet is the width. So let me just put 25 over here and 25 over here. There is no thickness for the same thing. That's why we have to just calculate the quantity, and let me just drag that formula. But over here, as you can see, we have result is 0 because the formula is just empty. Okay, I'm gonna just remove the F8. Okay, and then press enter. So you can see we have now the quantity, because multiplying these three things can have the quantity. Okay, or maybe resulting in the quantity. Now the result is the same. Okay, because this is just area. Now further in analysis, or maybe calculating the cost, we will be just considering these things. Okay, 9.75 CFT is the cruststone, and then the bitumen is 79 pounds. Okay, so this is actually the area. That means the quantity is in SFT. Okay, now you have to look actually in MRS for the same specification, and then you have to look for the rate, and then that rate is just enough to work out the cost of the said, you can say surface. It's very easy. Okay, okay, next, number 7. Number 7, we have actually Curbstone. And Curbstone, let me just show you if you can see it. As you can see, we have these Curbstone. One is this one and one is this one. Okay, it means on both sides of the footpath. Okay, or you can say there are 4 Curbstone. Okay, on both sides of the same road. So let's say we have Curbstone, and a number that should be 4. Okay, length is the same because it is just the road, which is 3 miles in length. Okay, now Curbstone, they are actually laid. Okay, along the length. It means the quantity should be in running feet, or maybe in running meter. Okay, so we have to just multiply the length with the number, and that's actually the same thing, 63,360. And next we have actually another thing. Let me just visit it. As you can see, Curbstone are done. We're here on this, we have actually some footpath, and this is a concrete pavement. Let me just color it so you can see it. Okay, this green color. Okay, this is just actually concrete work. Okay, again, let me just color this. So what should be the quantity of the same thing? Okay, we call this maybe, let's say, number 8, and this is actually pavement, or maybe let's say footpath. And in footpath, we have actually, let's say, concrete pavement. In number, it should be 2, because on both sides, that thing is just, you can say, paved. Okay, so in number, it is just 2, and the length should be the same because it's along the road. Okay, now what should be the width? It should be actually 3. If you can see it, we're here in the dimensions, it is actually 3. Okay, so let's just put it over there. Now if there is any thickness, you can just include that, and let's just see if we have thickness or not. Okay, for the same work. Now, as you can see, this arrow is, or you can say leader, is just leading to the same concrete pavement, and that is 4 inches. Okay, what do you mean by 4 inches? It is actually the same thing is 0.334 feet. Okay, so you have to multiply these 4 columns in order to get the quantity, and this is actually the same thing. Okay, a very huge video, because the road is enough lengthy, 3 miles. That is actually a huge thing. Okay, now another thing which we have actually is the brick ballast, and that is just below of this pavement. You can see it. This is just brick ballast. Let me just color it red so you guys can see it. This is just the brick ballast. Okay, on both sides. So in number, it should be 2. In number, it should be 2. Length should be the same, right? Width should be the same because it is just below that thing. Okay, I mean below that concrete pavement. Okay, you can see it is, and you can even annotate this. Okay, if it's not just disturbed, you can see it. Okay, it is only 3 feet.
इसमें
Okay.
सर कर्वस्टोन कौन सा है?
Okay, let me just show you. This one, this guy. You see it?
सर ये
Which,
ड्राइंग में सर दिखा है. अच्छा सर, ठीक है, ठीक है, ठीक है.
actually, curbstone, let me just have some definition to this thing. Okay, curbstone is actually the structure or maybe member of the road which separates the surfacing from the footpath.
जी सर.
And this can be actually rectangular as well, no problem. All right.
ठीक है.
And even over here, we may also have stone channel like over here. Okay, over here. That's why I recommend you to be familiar with the terminologies of road in order to determine detailed quantities. Okay. All right. Next, what we have is actually the brick ballast. And now, what should be the thickness? Okay, let's just see in the same drawing. Okay, as you can see, this arrow represents the dimension to that, and that is actually 8 inches. Okay, so 8 inches means just 0.66, 0.667 feet. And let's just drag the formula so we can have actually the quantity. Now this is in volume, so it means the unit should be in CFT. All right, I think we have only one thing remaining, and that is if you see, we have these electric poles. Okay, according to the specifications we have, or maybe according to the drawing, we have no information about these poles. That's why I'm gonna assume for myself. Okay, let's say we have number 9, because I just want you to understand these things if you have specifications. Okay, now let's say according to specifications, if we have different poles, and let's say if they are maybe after some distance. Okay, so electric poles, remember they are just, you can say, they are just constructed, maybe they are drilled inside the earth. Okay, or inside the concrete. but having some interval, okay? There can be some interval. Let's say if we have, I'm going to say at the rate, let's say 50 poles, okay, per maybe mile. What do you say? Let's say we have some specification. So 50 poles are used per mile. It means we have 3 miles. The number should be 150 now. What do you say? It's very easy. So the quantity is actually 150 and the unit is numbers. So quantity survey is very easy, I think. If you are a little bit familiar with those 3 things, okay, as I have just discussed before, or maybe at start of the session, okay, or maybe a course. Okay, so we have discussed those 3 things: the drawing, the specifications, okay, and then actually the rates. These 3 things are very important. Okay, so when you are familiar with these things, then quantity survey is very easy. And if you remember, before I have already told you that area and volume is very important. Now, as you can see, everything over here that we have just calculated is all about area and volume. You can see that. Okay, this is the reason I have already explained everything related to area and volume at the very start of the course. So these are the quantities of materials for a road. You can see it, okay? There is nothing left over here, and this is the road, okay? Now calculating the cost based on the MRS, it's your work. You have to do that the same way as I did for the waterbound macadam road. And I think we have 1 hour completed. So if there is any question related to quantity surveying or maybe any other subject, you may ask. So we may leave the class then.
सर ये क्रस्टोन और डॉक्यूमेंट पढ़ा है कि इसका समझ नहीं आया, इस पर थोड़ा बताएं।
आवाज नहीं है आपका क्लियर।
सर ये क्रस्टोन और बिचुमेन का कांसेप्ट क्लियर नहीं हुआ है, इस पर ये क्लियर करें सर।
अच्छा, वेरी, ये देखे यहाँ पे, ये तो बहुत सिंपल है, ठीक है। अब क्या होता है, अस्पार्ट में हमारे पास क्रस्टोन होता है और बेचुमेन होता है, ठीक है। जो हम फ्लेक्सिबल पेवमेंट या आप कह ले कि तारकोल वाले जो रोड हम कंस्ट्रक्ट करते हैं, तो उसमें क्रस्टोन और फिर बेचुमेन मिक्स किया जाता है, ठीक है। तो अब कितना क्रस्टोन होनी चाहिए और कितना बेचुमेन होनी चाहिए, ये तो खैर डिपेंड करता है किस चीज़ पे, डिज़ाइन पे। जो हमारा मैक्स डिज़ाइन होता है ना, उस पर डिपेंड करता है बेशक। हावेवर डिज़ाइन के बाद आप लोगों को ये चीज़ मालूम होनी चाहिए, कहाँ से, स्पेसिफिकेशंस में। क्वांटिटी सर्वे ने स्पेसिफिकेशंस को स्टडी करना है, उन स्पेसिफिकेशन के हिसाब से आपने क्वांटिटी के कैलकुलेशन करने हैं, ठीक है। तो चलो मैंने इज्यूम कर दिया कि स्पेसिफिकेशन में हमारे पास एट द रेट 9.75 CFT इतना क्रस्टोन, CFT मींस वॉल्यूम है ना। हमने पहले जो इन चीज़ों को कैलकुलेट किया हुआ है एनालिसिस में, कल वाली क्लास में मेरे ख्याल से। तो इतने CFT का क्रस्टोन चाहिए कितने काम के लिए, 100 स्क्वायर फीट काम के लिए। कितना आसान बात है यार, इजी बात है। सिमिलरली हमें चाहिए 79 पाउंड्स बेचुमेन, ठीक है, कितने काम के लिए, 100 SFT काम के लिए। आप कह ले कि भाई हमारे पास यहाँ पे 10 बाई 10 का रोड है, समझ आ गई आप लोगों को। 10 बाई 10 का रोड है, तो इसके लिए हमें क्रस्टोन चाहिए भाई 9 पॉइंट कितना चाहिए, 9.75 CFT, ठीक है। और बिचुमेन कितना चाहिए, 79 पाउंड्स, ठीक है। आप LBS से इसको लेबल कर सकते हैं यू। कोई और क्वेश्चन?
सर लेक्चर अपलोड कर देना, इंशाल्लाह हम रिवीजन करेंगे लेक्चर देख इंशाल्लाह।
आज तो एक अपलोड किया है मैंने, डे 3 का।
ओके, इंशाल्लाह ये भी इंशाल्लाह अपलोड हो गई तो अच्छी बात है।
डे 3 मैंने अपलोड किया हुआ है, ठीक है। और इसमें थोड़ा टाइम लगेगा क्योंकि मैंने AutoCAD वाले भी अपलोड कर देना है कल ना, तो उसको एडिट करूंगा, फिर इसके लिए टाइम नहीं है।
ओके।
In today's lecture, we will be just determining the quantities of earthwork, okay? can be in different forms, such as cutting and maybe then filling. So we will be just determining the earthwork calculation. Before starting the earthwork calculation, let's just have some basic concept and the method, okay, or you can say some formulas stuff, okay, and then we will just move ahead for the example so we can understand the problem better. As you can see, there can be different methods to determine earthwork calculation, but in these lectures, we'll be just using few methods such as the mean area method and then the mean depth method. So you can say the mean area method, and then we will discuss about the mean depth method, because these two methods are used normally, okay? And I believe you guys are just familiar with these two methods. So we will just move very quickly and we will, you can say, give less time to these formulas. Now, what do you mean by the mean area method and what do you mean by the mean depth method, okay? Let's just have some, you can say, filling maybe. Let's say we have this natural surface level, okay? This is, let's say, NSL. And let's say we have some fillings over here, the same way like this, okay? So we have this filling, and let's say if this is maybe embankment, maybe for some filling formation, okay? And maybe just, you can say, a bank for a railway track, okay? So let's say we have this thing, and it means the section can be the same, okay, to that side as well, such as this one, okay? The section can be like this one as well, okay? Now, as you can see, the section is just trapezium, and this is just normal practice, okay? So we have, let's just focus on the mean area method first. Now, as you can see, let's say if we have the depth at this section, and I'm gonna call this is D1, and at that section, let me just call this is D2. It means the depths are different, so the areas for both sections can be different. If area of this section, let's say this is just the red shaded area, it means this area is just different than this area, which is just, you can say, the blue area, okay, at both sections. Now, once we have the area different, and if these areas are just the same, it means this is then very straightforward, okay? Then you have to just multiply this area with the length to have the quantity of the earthwork, okay? And we have done this before many times. Now, we are discussing these two things, the mean area and mean depth, because we have different dimensions, okay, at both ends of the same embankment, okay? Now, if we talk about the mean area method, then the mean area method means, let's say, I'm gonna say area, and over here M means the mean area, okay? Now, area at this section, I'm gonna call this is area 1, and for that section, let's call this is area 2. Now, what do you mean by the mean area method, okay? We have to just multiply the mean area, okay? And by mean area, I mean just to add both areas, okay? Like A1 plus A2, and then we will divide that by 2. So we have the mean area, okay? Now, once you have the mean area, then of course we can calculate the earthwork. Maybe let's say if this is filling, because this is just an embankment, okay? So it can be filling. It means the area, which is this time mean area, times the length, and this can be actually the earthwork or maybe filling. That's straightforward. So this is actually the basic concept for the mean area method, okay? Now let's just discuss something about the mean depth method, okay? And again, I'm gonna say, let's say if we have the same embankment, just the same way like this one. Let me just draw it if I can do it better, okay? Let's say we have the same thing. Now, I'm just gonna have some dotted lines over there. Now, the mean, and one another thing, wait a minute, okay? We're here, as you can see, we have the mean area. And this means that the area of the same embankment at the middle portion, like this one, you can say, just this one. This is actually the mean area. And this means AM, okay? Now, we're here, as you can see, let's say if I have different depths, okay? You guys can hear me, please confirm it.
Yes, sir.
Okay, so let's say if we have two different depths at each end, you can say, and we are talking about the mean depth method. It means the mean can be taken as the middle one like this. Okay, something like this. This depth can be just measured, and let's say this is dm. So the mean depth method, let's say mean and then depth method. So this is actually all about dm, and this should be d1 plus d2 and divided by 2. So this is actually the mean or depth, okay, for the same embankment. Now, let's say if we have length of the same embankment as L. Now, as you can see, we have the mean depth. Okay, and once we have the mean depth, then of course we can determine the earthwork for the same embankment. Okay, now the earthwork, and let's say this is just filling again because this is an embankment. So the earthwork can be the mean depth, like dm, okay, times the length of the embankment. And this is straightforward and very simple. Okay, so this is the main concept related to mean depth and mean area method. Now we will have an example so we can calculate all these things very easily. Okay, and one another thing that should be given in order to determine the earthwork. Let's say, let me just say if I have the same thing in embankment like this one. So one another thing which should be known is actually the dimensions related to the section. Okay, so we should have the depth for both ends and actually the formation width, which should be this portion. Okay, so the formation width should be known again like this portion, and this is actually B. Now side slopes should be known, like maybe you can say side slope, and this is S1, and for the other another side, let's say this is S2. Okay, and these can be the same as well, no problem. These can be different as well. Okay, like maybe these can be S1 for both sides. Okay, now as you can see, we have one another thing which I'm gonna just make it clear for you so we can move ahead then. Okay, if you remember, the areas, if they are different for both sides, and let's say if we have to determine area of the first section, then what should we do then? Okay, let's say this is slope for one side, and here we have slope for another side. You can say S2, and let's say this is just the width or breadth. Okay, and here we have the depth. Very simple. Now, if the depth is not known, there can be actually, let's say this is formation level, and here, as you can see, this is NSL. Okay, so one of I mean these two must be then known. Okay, NSL. Then if these two are known, we can just subtract the NSL from the formation level, like you can say formation level minus NSL, and this is actually the depth then. Okay, so this is how you can calculate the depth. Okay, it is just, you can say, the difference of levels. Now, once we have the depth and then the side slopes, then actually what we do, we just split the same section into, you can say, different geometries such as this one. Okay, and we call the central one is the area of the center, which is actually what, and that is just BD. Okay, because this is just rectangle, so we have the breadth and then the depth. Now, area of the sides, these are actually triangles. So area of this side should be SD square divided by 2. Okay, and this is actually S1. And for this side, area should be S2 D square divided by 2. Okay, it means the total area of the same section should be actually area, and it is BD. Okay, and that is just BD plus S1D square divided by 2 plus S2D square divided by 2. That's very simple. Now, there is another thing. If S1 is equal to S2, then we can just simplify this thing a little bit more. Okay, and this can be then, of course, area. If these two, if S1 is just S2, then area can be actually BD plus SD square only. So these are the formulas which may required, okay, and which may be needed, okay, in the calculation of cutting fill. Okay, we will just move ahead to the example. And in the example, let's say if we have this embankment, okay, which is actually just 10 meters, and we are asked to determine the quantity or maybe cut fill for the same embankment. As you can see, the side slope are both sides. This is just the same, okay? This is just 2:1. And let's say we are asked to work out the earthwork for the same embankment, but this time by mean area method, okay? And these are actually the terms. As you can see, we have an embankment, and the length is 150 meters. It is just wide is 10 meters at the top, and the side slopes are 2:1, and the depth at each interval. It means, let's say this is an embankment for maybe road, maybe for a railway track, okay? And after each 30 meters, these are actually the depths, okay? You can see them, 0.6, 1.2, these are in meters, okay? And at the other end, it means, as you can see, at start, we have 60 centimeters, and at the end, we have the depth is 1.6 meter. So you can say the embankment is just trapezium. Why it's trapezium? Because we have side slopes, okay? And you can label the information just the same way as I'm doing, okay? Now, we have to determine the cross-sectional area is the shaded area, you can say, and then we will multiply this with the length so we can have the quantity. But the cross-section area can be different, okay, after each 30 meters. Because depths are different after each 30 meter. So it's not like that. It's not that simple just to multiply area with the length, okay? We're gonna do this thing in a nice table, okay? For this approach, let's say we have the same table, and this table is just known by the mean area method. So the first column should represent the station, and then we should have the depth, then the central area, which if you remember, I have already said that we will just convert the section into different geometries, maybe triangles and then the rectangle, okay? So the central area is actually BD, and if you remember, it is just the central area, this one, okay? So this should be BD, or maybe the breadth and then the depth, okay? And then we should have actually the sides areas, and these are SD square only. Okay, why SD square? Because the side slope for both sides is just, you can say, same. If they are different, then of course we will use SD square divided by 2 for one side, okay? And for another side, it should be S2D square divided by 2, okay? But this time, the side slope is just the same thing for both sides, so we can only use SD square, okay? Very simple. And then the total area should be determined, which is actually column 3 and column 4 summation. And then we will have the mean area. Okay, that's why this method is known by the mean area method. And then we will have the interval, and then of course the quantity of earthwork, which can be in form of cut, maybe in form of fill. This time this is just an embankment, which is already known over here, okay, in example terms. So it means there will be filling only without cutting. Till this point, is there any question?
Yes, sir.
Okay, you may ask.
सर ये SD स्क्वायर ये ट्राइंगल का एरिया है ये फार्मूला.
Wait a minute. Let me just make it a little bit clear, okay? As you can see, let me just draw the same, maybe one side of the triangle like this, okay? Over here, we have the slope, which is maybe you can say S, and on this side, we have D, okay? Now, basically what happens is this is a right angle triangle, and you should know the area of a right angle triangle. Okay, remember, as you can see, we have the hypotenuse, that is S, the perpendicular is just D, and let's say the base should be actually SD for the same triangle. So now area of the triangle should be the base times the perpendicular. If you remember, it is just you can say the old thing, and we have done this. Okay, so SD times D, SD is just the base times D, that is just the perpendicular, divided by 2. Now SD, where there we have D times D. It means SD square, okay? And we will just divide it by 2. So this is the same formula. Is it clear now?
Yes, sir.
So as you can see, we have 30 meters interval, okay? It means the station can
ठीक है
be,
सर
okay, and that is also 150 meters long. This is the total length, okay? So it means we can start the station from 0 and tell 150, but the station's interval that is just 30. So it means 0, 30, 60, 90, 120, and 150. So these are actually stations, and after each station, the depth is different. It is the same thing. If you remember, while making the profile, we make some chin edges, we mark them on the natural ground surface, okay? And then by level machine or maybe total station, we determine the depth at each interval, maybe you can say. So these depths are actually provided by the land surveyor, you can say, okay? So we will just put all those depths, like maybe 0.6, 1.2, and 1.4, 1.6, 1.4 again, and 1.6 again. And those can be just, you can say, written over here in the same table. Now the central area, we will multiply the depth with the breadth. You can say, let's just consider the first station. Over here, we have 0.6 is the depth, okay? That is actually 0.6, and we will just multiply that with the breadth, which is actually 10 meters, okay? The result will be actually the area of the central portion, okay? But this will be just actually for the station 0, this red shaded area. Now, as you can see, we have 10 times 0.6. This should be actually 6, okay, square meter. And for the another station, as you can see, the depth is different, which is 1.2. So 1.2 times 10, then that should be, let me just remove the other things, these things, so you can see it. So the area can be actually 12. And again, 1.4 times 10, that should be 14. And 1.6 times 10, that should be 16. And again, 14 and 16 again. Now, area of sides, okay, for both sides, area is actually SD square, okay? SD square. Now, you have to put values over here, like maybe for S, we have 2, and D can be actually different for each station. Let's take 0.6, okay, and that is just square. So this is how you put values in the same formula. Now, what should be the value for that station? And this is actually the sides area, and as you can see, SD square. So it should be 2 for S, and for D, that is actually 0.6, okay? But over there we have square. Now this should be 0.72 square meter, okay? We can put that value over there. For another station, the depth is different, which is 1.2. So the answer should be 2.88. Okay, we can put that value over there. Now the depth is just different for each station. Okay, so you can put all these values and just try them by yourself. Okay, and put all these values in the fourth column for area of sides. And these sides are actually triangular. Now total area means just to add column 3, okay, with column 4. Very simple. It means 6 plus the sides area, which is 0.72, okay? Very simple. That's going to be the total area. And 12 plus 2.88 should be 14.88, and so on. Just do it. Now mean area, this is what we want actually, and that's why the calculation method is just known by the mean area method, because we just calculate mean area in the same method, okay? Now again, let me just repeat it. By mean area, I mean just to add one area with another. You can say area of 2 stations and divide that by 2, okay? Very simple. Like, as you can see, the station 0 and station 30's areas can be added together, and we will divide that by 2. So we can have the mean area for station 30. Okay, very simple. So add all these, you can say the two areas, okay, which are at start or maybe for both stations, and then we will divide that by 2. Okay, and that's just calculated is that one. So that should be 10.8 square meter. We will just put that value, okay, in the same row for station 30. Now, 14.88 plus 17.92 divided by 2, that should be actually 16.4, and so on. Now, we have actually interval that is just 30 meters. Okay, it means the distance between two stations, that is just 30. Now, area times the distance, that should be actually the quantity. That is area, and we will multiply that with the distance. So we can have the quantity. Okay, 10.8 times 30, that should be the fill, 324, and follow the same process. So we can have filling. Now, why filling? Because this is just an embankment. Now we will just add all these fillings. You can say these things, so we can have the quantity, okay? And that should be actually the total filling of the embankment, 2572.8 cubic meter. Very simple. So that much material is just required for filling, okay, for the same embankment, which is 150 meters long. Now here, as you can see, we have only filling, okay? We don't have cutting over here because the formation level is just above the NSL. In the next example, however, we will include cutting as well, so you guys can understand when you face cutting and filling, okay, together. Okay, so let's move ahead for the another method. And let's say we will just do it using mean depth method. This is going to be the concept. We will be using the same table, such as stations, NSL, formation level, okay? And the previous, you can say table, the depths were just known. Here, as you can see, depths are not known. However, the NSL and let's say the formation level is known. If the depths are known at each station, you don't actually need to add these things in the table, okay? Just add the depth. Very simple. Okay, and over here, as you can see, the depth can be actually, if you subtract any cell from the formation level, that's your depth actually. Okay, very simple. Now, and if the formation level is just a bound, let's say this is the NSL, okay, here, and this is the formation level. That means it is just filling, you can see it. Okay. However, if the NSL, let's say this is NSL, and let's say over here we have the formation level, this one, then of course it is just cutting. This should be cutting. And over here, this should be filling. So it's very straightforward, right? Okay, and then we should have depths, and of course, just NSL minus formation level, or maybe formation level minus NSL, okay? You can just switch their location, does not matter. So these should be the depths, and remember this method is known by the mean depth method. So we will add two depths and then divide that by 2, so we can have the mean depth. Then of course, areas, maybe the central area like BD and SD square for both sides, okay? If the slope for both sides, okay, I mean, you can say side slope are different, then of course, you can add another column over here, and we will have SD squared divided by 2 for one side and SD squared divided by 2 for another side, okay? And then as you can see, we should have the total area, and then of course, area times the interval can be actually the quantity, which should be the cutting or maybe the filling. Is that clear? Okay, let's just have an example so you guys can understand better. In the same example, we are asked to work out the quantity of earthwork for a portion of road. We have a road whose formation weight is just 10 meters, the same thing. But here, the things are very different. The side slopes are 1 and 1 in cutting, okay? When there is cutting, we will use 1:1 side slope. However, when there is filling, we'll use 1:2 as the side slope. The natural surface level and formation levels at different stations are given below, okay? Let me just see what we have were there. Again, my pin is not working. Okay, it's working now. Okay, so we have stations such as 0, 30, 60, 90, 120, and 150. And then NSLs, okay, these NSL must be provided by the surveyor. Okay, at each station, you can say, let's say this is maybe road portion, and the road has just started from 0, then we have 30, okay, then we have 60, 90, 120, and let's say there is, let's say, curvature, no problem, and then we have 150. Okay, so NSL at this station, at 0 station, that is just determined at 30, at 60, at each station, and they are just noted over here. Then we have the formation level, which is just the work of designer. Like maybe if you just draw the profile of the same road, the formation level is just drawn, okay, and then the maybe the road surfacing or maybe the road topping is just leveled with that formation level, okay, and then we decide the cut and fill based on the formation level. Now, as you can see, the formation level is just above, okay, the value of the formation level is just more than the NSL. It means here we should have filling, okay, again the formation level, it is just more than the NSL, it means filling again. The formation level for station 60, it is more than the NSL, it means filling again. Okay, here the formation level for station 90 is also more than the NSL, it means filling again. Okay, however, look at the station 120, the formation level is just, you can say, less than the NSL. That means there should be cutting, right? And again, at 150 station, the formation level is just less than the NSL. It means cutting again, okay? So, the cutting will start actually somewhere from the middle of station 90, okay, and station 120. So here, okay, on this side, we have actually cutting, maybe. And on this side, we have actually filling. So in the same example, we are facing cutting and filling at the same time, okay? And this point where we actually, let me just draw the map, let's say, okay? If we have this thing, such as this one, okay? Let's say, just a minute. If I can just remove this line, and let's say if we have the formation level, okay, well, here we have the formation level above the NSL, but at the, okay, at the end, as you can see, the formation level is just down, or you can say below the NSL, okay? The green one that represents NSL, okay, this one. And this guy represents the FRL or maybe formation level. Very simple, okay? It means we're here, we should have filling. This portion is just filling, okay? And this portion that is just, you can say, cutting. Very simple and straightforward. But here is a point, this point, where we don't have cutting and filling as well, okay? Their cutting and filling both are just 0. This point is just actually known by the intermediate point, okay? IP, intermediate point. Intermediate point is actually a point where we don't see any cutting and filling, you can say, okay? Or you can say the FRL is just crossing NSL, or maybe NSL is just crossing FRL. So here, the things are actually a little bit different. So let's just move ahead to the calculation. And in the calculation, let me just have the same table. And here the section for cutting portion, okay, where the side slope is different. And the section for filling portion where side slope is just different, which is 2:1, okay? Very simple. Okay, so we have RDs, which is 0, 30, 60, 90, 120, 150. Okay, I have left this cell, okay, blank because I already know that there is intermediate point. Then we have NSLs. Remember, these things were known, okay, NSLs. In the formation levels, these were also known. previously if you just saw that, okay? Now we have to determine the depths at each interval. And for that, we will subtract any cell from FRL, okay? Very simple. Like maybe you can say 252, which is the FRL of station 0. We will just take that and we will just subtract the NSL, okay, which is 251. And that's going to be the depth, which is actually 1 meter. And again, 251.8 minus 250.9, that's going to be 0.9. Okay, and so on. Just do that. So this is the same process. We're here, as you can see, when we subtract 250.8, or you can say when we subtract 251.2 from 250.8, that's going to be minus 0.40. And that indicates that there is actually cutting, okay? That minus sign represents the same thing. And again, minus sign for 150 station, it means cutting again. Now we will just determine the mean depth, and if you remember, mean depth means just to add 2 stations at the, you can say the depths of 2 stations, and then we will divide that by 2 so we can have mean depth, okay? So just add those 2 stations depth and divide that by 2 so we can have the mean depth for station 30. And again, 0.9 plus 0.7 divided by 2, that's going to be 0.8. And then again, 0.7 plus 0.6, that's going to be 0.62. Now, one thing which is very tricky and you can say technical word here is actually the intermediate point. How do we locate the intermediate point and what should be the station? I mean, intermediate point is somewhere between 90 and 120 station. But where is it? Is it at station, you can say 95, or is it at station 110? Okay, we exactly don't know the location for that. That's why it's very important to calculate the location of intermediate point first, and then we can move ahead, okay? So as you can see, let's just represent that graphically so you can understand it better more. Let's say this green line is actually the formation level, and you can see the NSL, okay? Now here, these points which are circled, they are just known by the intermediate point, because there we have actually no cutting, there we have actually no filling, okay? Let's say, as you can see, we're here, this is actually just filling. You have to fill here, okay? And these places, you can say these red shaded should be just cut out, okay? These are actually cutting, okay? And for the black one, these are actually filling, okay? So this is actually the formation level. Now next, as you can see, we have the intermediate point and that should be determined. And how do we determine that, okay? For that, the distance of IMF, which is intermediate point, should be actually the depth at lost station, which is station 90. And we will actually divide that by the same depth, okay, which is the depth at station 90, okay? And we will just add the next depth, which is actually 0.4, and then we will multiply that with the interval, and actually we will just add the last station, okay? And this is gonna give me the intermediate point, which is 108. That means the station, which is 108, the cut and fill over there are just 0. Okay, this is very simple and straightforward. We don't have NSL over there, we don't have FRL over there because we are not calculating that. They are not needed. Okay, and the depth over there is 0. And 0 depth means that no cutting, no filling over there. Okay. Okay. So once we have actually the intermediate point, then of course we can calculate the mean depth for station 180 and station 90, okay? And that's gonna be 0.3. Again, the mean depth for station 108 and 120, that should be actually minus 0.2 and so on, okay? Once we have the mean depth, then of course we can calculate the sides areas or maybe the central one as well, okay? And that is
Sir, repeat the distance of intermediate point.
Okay, just let me just go a little bit back so you guys can understand it, okay? The intermediate point distance, that should be actually the depth of last station, which is actually the depth of station at 90, and that is 0.6. We will just divide that by the same depth, okay? And then we will add the next depth, which is actually the depth of station 120. And that is actually 0.40. We are not just actually including that minus sign because we are looking at the depth only. And this is the same thing as similarity of triangle, okay? The same way as we determine actually the point of counterflexure. If you're a little bit familiar with these, maybe structure analysis, okay? And then we will actually multiply this with the interval, or maybe the distance between two stations. And that is actually the distance between station 90 and 120. So it's just 30, okay? And then we will add the last station. Why we are adding last station? Because if we don't add last station, then of course that's gonna give me the distance. This formula is gonna give me the distance from 90 onward, okay? We are adding the distance up to 90 because we are calculating the intermediate point from point 0. Do some math so you can have actually the intermediate point. Is it clear now? All right, so BD, that's actually the central area, and that's very straightforward, okay? P is already known, which is 10, and that should be actually the depth, which is 0.9. So 10 times 0.9, that's gonna be 9.5. And again, for station 60, 10 times 0.8, that's gonna be 8. 10 times 0.65, that's gonna be 6.5. Now, 30, 0.3 times 10, that's gonna be 3 only. And minus 0.2 times 10, that's gonna be actually minus 2 and minus 6 again. Now, SD square, okay? SD square. For S, we're gonna put 1 or maybe 2. Because we have cutting and filling both, okay? And over here, as you can see, we have cutting. So for these portions, we will just include the side slope for cutting, which is actually 1. Okay. And for the above portion, we will just include the side slope for filling, which is actually 2. In the previous example, actually, it was just the same thing. Okay, one side slope for both. Because over there we had actually only filling. Okay, this time we have both things, cut and fill. Clear? Okay, so for station 30, SD square. By S, we will just put the side slope of the section which is in filling, okay? And we will just multiply that with the mean depth, and we will have actually square. So simple, and that's gonna be 1.8. How 1.8? Again, let me just repeat it. We have actually SD square. So put 2 for S, and then D, that is actually 0.95, and take it square, and that's gonna be actually 1.8 square meter. Is it clear? It's just straightforward and very simple mathematics, okay? You can also do this thing in Excel. In Excel, that takes very less time, and I actually share those Excel file, which I have already made, and videos are already uploaded, okay, on the same channel, Engineer Boy Official. Okay, for next station, we have actually the mean depth, and then the side slope again the same, and the area should be 1.28, and so on, okay? However, after the intermediate point, we have actually cutting. Then, of course, we will just use the side slope from the section which is in cutting, okay? And that's actually 1. So the area should be 0.04, and for the last station, the area should be actually 0.36. Now, summation of area means just to add those two areas, we can have actually summation of area, okay? And I'm gonna do that very quickly. Interval is just known, which is 30 meters. Now, area times the interval, that actually means the quantity, okay? And that's going to be actually in cubic meter per cut and fill both. So that's 339 cubic meter, okay, up to station 30. And then we have actually for the other station, which is 278. Again, we have 220, and then we have actually 57. But after this, as you can see, up to 108, which is station this guy, and the quantity is 57. Over here, we have actually all these things, these are in filling, okay? After this, we have actually cutting, which should be just the area times the length, which is 12 meters. And here is one trick, okay? Because 90 and 8, actually, this is 108. We will subtract 90, so it becomes 18, okay? And that's actually the interval. And after 8, up to, you can say, 120, that should be then 12 meters. So 12 meters times 2.04, that should be 24. And next, again, we have 30 meters again, and the area is 6.36. So if we multiply that, we're going to have 190.8 cubic meter is the cutting. Very simple and straightforward. If there is any question, you guys can ask them.
सर ये 108 आरडी पर ये 57.24 कैसे आया है? ये तो इसमें न कटिंग है न फिलिंग है, तो किस तरह
एक सेकंड, मैं जरा इसको शो करूँ तो फिर मैं आपको आंसर दूंगा। अच्छा, सवाल दोबारा पूछा, क्या पूछा आपने? 108 पे क्या?
108 आरडी पर ये 57.24 क्वांटिटी किस तरह आई?
वेरी गुड,
इसमें
वेरी
न
गुड।
कटिंग है न फिलिंग है।
एग्जैक्टली यही तो पॉइंट है। देखिए 108 पे हमारे पास ये 57.24, ये जो फिलिंग है ये एग्जैक्टली उस पॉइंट पे नहीं है। ये तो असल में स्टेशन 90 और स्टेशन 180 के दरमियान जो डिस्टेंस आ रहा है ना, 18 मीटर का डिस्टेंस है भाई। तो 18 मीटर में इतने क्यूबिक मीटर का फिलिंग होगा ना।
जी जी सर,
तो सॉल्व हो गया आपका क्वेश्चन।
जी जी साल हो गया। और ये फिर 108 से 120 तक ही पे फिर कटिंग होगी 24।
एग्जैक्टली क्योंकि इंटरमीडिएट पॉइंट के बाद कटिंग आ रहा है।
जी जी सर।
चलो गुड हो गया। अच्छा 50 मिनट हमने इस चीज़ को डिस्कस किया, तो मेरे ख्याल से इतना ही काफ़ी है। नेक्स्ट वीडियो में फिर इंशाल्लाह हम देखेंगे चीज़ों को, ठीक है। अल्लाह हाफिज़। We will start and we will actually continue the previous topic because something that is important is remaining, okay, in the same topic. So we will just move ahead and let's say we'll just calculate the earthwork calculation, okay, in a hilly area. In the previous session, if you remember, we had just done the earthwork calculation for plain areas, okay? So this time we will be just doing it for the hilly area. The process will be the same, okay? Nothing complicated. However, the terrain or maybe the shape of the earthwork can be different, okay? Because the hilly area can be even more complex area, okay? So let's just do it. And let's say there can be actually different types of conditions, you can say, okay? And the conditions may include, like you can say, the earthwork can be in cutting, and in the shape can be just in this form. As you can see, we have the shape where we have the cross slope, and this is actually, you can say, the natural ground level, or maybe just the slope just formed by the hill or maybe mountain, okay? So this is actually the same slope. And there we have actually the side slope, which is S ratio 1. And for the cross slope, we actually annotate that with R ratio 1. Now this area, which is actually the cutting, okay, and which I'm just shading over here is the red shade. As you can see, this area can be actually the same is which is shown over here, okay? This is actually area in cutting, and this formula can be used to determine this area. Now, once we have this area, okay, then we actually multiply this area with the length, or maybe the tonnage, or maybe the RD, and we can have actually the earthwork, or maybe the volume. Okay, so this is the basic concept for pulley and cutting. Okay, we may have another condition such as fully and filling. Okay, that time, if you remember, it was just cutting because the formation level. Okay, let me just make it a little bit clear. As you can see, this is the formation level, okay, which I'm just representing is the blue. Let's say this is formation level. And as you can see, this is just below the natural ground, okay, or you can say below the cross slope. So that means we have to dig this red shaded portion. All right, moving ahead, fully in filling. Okay, there can be filling as well, because as you can see the formation level this time, okay, this is just the formation level. You can see, okay, that I'm just highlighting, okay, with blue marker. So this is actually the formation level, and as you can see, this is above the natural surface level, or maybe above the cross slope, okay, or the slope of the mountain. So it means we have some filling over here, okay. This is actually going to be the filling as I'm shading, and this filling, the formula is going to be actually the same formula. And then there can be actually the condition where we may have both conditions, okay, at the same time, like maybe cutting and then filling as well, okay, like you can see that. Okay, here as you can see, we have cutting. This portion can be in cutting, that is just shaded in red color, okay, because it is the same condition as just we have discussed that is the type 1, okay. And here, as you can see, the formation level, that is just actually below the ground, or maybe the cross slope. However, if you look to the filling condition over here, this is actually filling, okay, the green one, the green shaded area. Over here, the formation level, that is just actually above the slope, which is just, you can say, the cross slope, okay. So this is called partial in cutting and then in filling. Now we will have actually some example to understand these three conditions, and we will have examples just to learn how do we calculate these cutting and then filling, okay. So let's move ahead, and I'll just give solution to an example related to fully in cutting, okay. If we have cutting such as this, okay, what we have to do is just determine the area of the section, and then we will just multiply this area with the length. Now, if this area is at both ends, okay, or you can say if this depth is just different for both ends, then we may use mean depth over here, okay. And if you're doing this calculation for is a mean area, then we have to determine the mean area. Maybe let's say this is section at one end, okay, and there is, let's say, another section at another end. Then let's say this is A1 and over here this is A2. Then we of course have to determine the mean area is A1 plus A2, and then we will divide that by 2. And then we will actually multiply this with the length, so we can have the volume, or maybe the total volume in cutting, or maybe the earthwork in cutting. And these are actually the terminologies which we have already discussed, like maybe the cross slope, okay, of the ground, which is the slope of the natural ground, you can say. And then we have the side slopes, which is S/1. And then actually D means the depth of cutting at the center, okay, which is, as you can see, this is D in the same section. So we will have actually an example, and just to have the complete solution to the earthwork in cutting, okay, maybe in fully in cutting. So we have this example, very simple example, okay. And as you can see, we are asked to work out the quantity of earthwork for 50 meters long road. Okay, the road length, that is actually 50 meters, but this is actually in hilly area. Now the formation width of the road is 10 meters, that is known. The average depth for cutting, it means this is just the mean depth, okay. So this is given is average video. Okay, so in average depth for cutting its center, that is actually 2 meters. That's good. Now the cross slope of hillside is 10:1 and side slope is 1:1 in cutting, and then actually there is 1.5:1 in filling. Okay, if we have filling, right? And actually the section or maybe the diagram may look like this guy, as you can see. So this data, okay, I'm going to replace this with another diagram, but before, as you can see, we have some given data, and over here we have the breadth of the road, which is 10 meters. Now this breadth is actually the capital B, okay, in the same diagram, and what we need actually is the small breadth, okay, maybe up to the middle portion, or maybe up to the depth which is taken at mid section. Okay, so this is going to be just b by 2. It's very simple. And then we have actually half it, so it can be 5, because 10 divided by 2, that's going to be 5. And then the mean depth, which is 2, and this is actually the same thing is this depth. Okay, this is 2 meters. And then we have actually the cross slope 10:1, and that is actually the R:1. And then we have the side slope, which is 1:1, and then the length of the road, and that's of course 50 meters. Okay, now in the solution, let's just give it some clear solution. Okay, in the solution, as you can see, the earthwork, or maybe the volume of earthwork, can be area in cutting, which is actually this area, the red shaded area, you can see that. So we have to determine this area, and then we will multiply this area with length. Okay, so we can have the earthwork. That's going to be very simple. Okay, and if you remember, for the same section, or maybe if the section is just in cutting, we can use that previous formula. Very simple. Okay, SB square plus 2R square BD plus SR square B square divided by R square minus S square. Very simple. So what we have to do is just to have some plug-in check-in in the same formula, okay, and then we will have some mathematics, so we can have area and cutting. All right, so area and cutting, as you can see, we have SB square, okay, and you can even just look for this formula in the same reference, okay, which is actually not needed in the same section, however, no problem. Okay, so putting some values like S, which is going to be 1, that's known, which is side slope. Okay, you can see that, times B square. B is also known, as you can see, that is 5, which is just half of the formation weight, you can say. So 5 square plus 2 times R square. R is also known, which is 10, you can see that. So 10 square, and B again, that is known 5, and D, which is also known, and that's of course 2 units, plus again R square. Okay, S times R square, sorry, that's S, which is of course 1. R is again 10 square, and D, that is known, which is 2, so 2 square, and divided by R, which is actually 10 square minus S, and that's going to be 1 square. Pretty cool, very simple. Do some maths, okay, using maybe your calculator, and you must have area, which is 24.50 square meters. Now we will multiply this area with the length to have the earthwork. Okay, so area 24.5 times the length, and that is 50. If you see that, okay, it's just given in the example terms, that is just 50. Okay, so multiplying these two, we can have actually the quantity, and that's 1222 cubic meter, you can say. Very simple. And it means that the final result we have is 1225 cubic meter is the earthwork, which is actually this shaded area. This is actually going to be the earthwork for the same cutting. Just moving ahead, and we will have another example for the filling. Okay, if we have a section having some filling, and then how we can actually calculate that earthwork for the same condition. So let's say we have an example, and we are asked to determine the earthwork maybe for a road which is in hilly area, and we are asked that the length of the road, that is just 100 feet. Okay, very simple, that's known. As you can see, the section is just the same. Okay, this is in filling, you can see that red shaded. Okay, so what we have to do is just to determine this red area, this red shaded area, and then we will just multiply this with the length of the road. Okay, the same way like this. So if we have length, very simple. Okay, and let me just draw the same diagram from the given data. Okay, let's say we have the formation weight and then the side slope, and there is actually 32 feet is the formation level, weight, and its half can be actually 16 feet. And as you can see, the depth at middle portion, which is actually, you can say the mean depth, that's 1.85. Okay, the side slope that is known 2:1, and actually the cross slope or maybe the slope of the mountain or hill, that is 10:1. Okay, so we will give some solution to the same thing. As you can see, the volume of earthwork, let me just remove the extra work so we can see that. Just removing these previous work. So the quantity of earthwork can be area and filling, and we will just multiply that area with the length then, or you can say with 100 feet. Okay, so as you can see, we have area and filling, and for that, to make sure if this is completely infilling or if there is any cutting. Okay, so we have to make sure this thing first. And how we can make sure it? For this approach, we will be just determining this, you can say element or maybe this portion. Okay, and this is just a distance which is known by RD. So what you have to put over there is actually R, which is 10, and D, that is known 1.85, and that's actually 18.5. Now, as you can see, this video, which is 18.5, this is actually more than the half width. Okay, it means that this section is going to be only in filling. There is no cutting in the same section, because RD is just more than half of the weight or maybe half of the formation weight. Okay, very simple. So it means we will be just determining the what? RDA is as you can see, it is just the distance from half weight. As you can see, this is the middle portion. Okay, it is just the distance from half weight till the mountain or maybe till the cross slope.
Okay, sir. Okay.
So we will be just determining the same area, and for the same area, which is in filling, we will use this formula. Okay, which is, you can say, another form of the previous. So putting some values over here, maybe for B, which is 16, and then RD, R is 10, D is 1.85, and there is actually whole square. And we will divide this by 2 times R, which is 10, minus S, which is 2. And let's subtract RD, which is just calculated, okay? And that is actually 10 times 1.85, or maybe you can put 18.5 over there, no problem. Minus B, which is 16 whole square, and 2 into R plus S this time. Just calculate the area, which is 74.13 square feet. Okay, now we have to multiply this video with the length, and the length is known, which is 100. Okay, you can see that. So you have to put that video over here. That's gonna give me the earthwork, which is a huge video, 7,413 CFT or cubic feet. Okay, by CFT I mean just cubic feet. Very simple. So this is how we can calculate the earthwork if we have conditions such as fully infilling. Okay, next, let's just look into the same thing. Okay, we will follow the same process just for an irrigation channel. Okay, and if you remember, in the previous session, we have learned about something which is known by the mean depth and then the mean area method. Okay, now as you can see, the irrigation channel can also be fully encutting, and it can even be fully infilling. Okay, so you have to look to the condition, and according to that condition, the earthwork can be in 2 types. Can be only in cutting, can be only in filling, and there can be even partial. Okay, maybe you can say some portion can be in cutting, some portion can be in filling. If you guys have attended the yesterday's class, okay, we had the same condition over there. Okay, and we had also discussed about the intermediate point, which is actually just the point where the earthworks is just changing its type, you can say, maybe from cutting to filling, maybe from filling to cutting, okay? So let's just look for the same solution of the irrigation channel. And we will just do an example because example is the best way, okay? Let's say, okay, this is just an example which is taken from a book and that's written in Urdu language as well as in English language. So we have a canal this time, which is actually, you can say, an irrigation channel. And the data, and that is just shown, okay, you can see the data, and there is section in cutting, and over here we have section in filling as well, okay? For cutting, side slope is 1 and 1. For filling, that is 2 and 1, okay? And how do you confirm that that is cutting or maybe that is filling? You have to actually look into the NSL or natural surface level, okay? Now look at look into the bed, okay? NSL is just over here, and we have actually constructed this bank, you can say. And this bank is just above the NSL, it means this is just in filling, okay? Very simple. Now, this is in cutting because over here we have NSL, okay? This is just NSL, you can see that, and it may be just the same way like that, okay? So we have just cut this place, you can say this section, okay? This is just, you can say dug or maybe excavated, and because of that, we have actually this section in cutting, okay? So let's just give it solution. And we will have the solution in the same table, and the table is actually based on the mean depth method, okay? You can even use mean area method, no problem. That's not a huge deal, okay? You can use any method. So data is given, like maybe the RDs, these are known in the same picture. If you remember, this is the same picture, RDs at different stations, those are known, okay? Which is the AD, and then 30 meters, that is just the interval, okay? And NSL for each RD, that is also known. You can see that like this thing, okay? All of these. Now, as you can see, the level of RD80, it means it start of the channel, that is 233 meters. That means that is just known, okay? The formation level. And you can see it is just over here. It is known in the example terms. Now, one thing that is very important is actually you cannot construct, or maybe you cannot lay the irrigation channel, okay, at the level surface. There must be some gradient so the water can flow, maybe according to the gravity. So that's the reason we provide the gradient, okay, along the length. And that is actually 600:1. Very simple. So because of this, we can actually calculate many other things, maybe the formation level for other RDs such as 830, 860, 90, 920, and then 950. So how we can do it? For that, we actually need how much the channel is just dropping, okay, per meter or maybe after each interval. So that's what we are going to calculate. So the fall in bed in each 30-meter interval can be actually 30, which is actually the distance or maybe the interval, and we will divide that by 600 because that is actually the gradient which is known. You can see that, okay? Now, we have actually 0.05 meters. And this is actually the fall in bed in each 30 meters interval, okay? Now, this is the thing which we want. Because of this and because of the first FL, which is known, we will calculate the formation level for the remaining RDs, okay? So the formation level for the next RD can be now, if we subtract this video, because the channel is just dropping, okay? It is just like maybe like this way, okay? So the elevation over here is more, and after 30 meters, the elevation can be, you can say, decreasing, okay? So that's the reason. So we will be just subtracting this video from the first formation level. That's, as you can see, we have 232.95. Now we will subtract that value again from the new formation level. So we can have actually another value, which is that, and so on. You can do it. Now depth, that is just the previous thing, and we have already learned that. You can just subtract, or it is, you can say, the difference between the formation level and the NSL, okay? So depth at each interval can be determined. Now the mean depth, this is just to add two depths and then divide that by 2, like maybe 2.5, okay, plus 2.85 divided by 2. That's going to be the mean depth, okay, for these two stations, and that is actually 2.67, okay. Again, 2.85 plus 2.35 divided by 2, that's going to be 2.6, and so on. Just do it. Now the actually the central area, okay, let me just say, if we have some conditions like this, okay, let's say if we have this area, this is actually a rectangle, so this is called the central area, okay, and that can be actually B times D. B is known, D can be known over here, or maybe just over here if you are working in filling, okay. So B times D, now B that is known, which is 5, you can see that, times D, D can be actually the mean depth, that is also known. So 5 times 2.67, that's 13.35. Now again, 5 times 2.6, that can be 13. 5 times 2.87, that can be 14.35, and so on. Now SD square, that's very important. SD square means side slope can be taken, okay, from these two sections. It can be 1:1, and it can even be 2:1, okay. However, this time we will be just taking the side slope of the cutting section, because we already know that there is cutting. And how we can know that? Because if you see, the formation level is just less than the NSL, okay. And over here in the same diagram, as you can see, NSL is just above the formation level. So when formation level is just down, just you can say down, then we have some cutting, you can say. So that's why we will be just using this ratio, or you can say 1:1. So 1 times 2.67, which is the mean depth, and over there we have square, okay. So that's gonna be actually the side area, or you can say the area of this triangular portion, this one, and for the other side as well, okay. All right, so again we have 1, which is the side slope, times the depth, and this time the depth is going to be this one, 2.6, and the square can be taken, so we can have 6.76, okay, and so on. I'm just speeding over here because we have already learned about this thing in the previous video. If you are not that clear, you can watch the previous video, okay. So you can have, a clear amount according to, or maybe just about this problem, okay, or maybe about the mean depth and mean area. Now the summation of area, which means this area plus this area, and that's going to be actually the summation of area. So this area plus this one, that can be actually 20.48, and then 13 plus 6.76, that can be actually 19.76, and so on. Now we have the distance, which is actually the interval, and that is just 30. How 30? Because as you can see, the first RE, that is 80, then we have 80 and 30, and then 860, okay. It means there is increase of only 30 meters. So the distance between two RDs is actually 30 meters, okay. Now area times distance, that is just the earthwork, and that is in cutting, okay. And again, area, which is 19.76 times the distance, which is 30, that's actually the earthwork, and so on. What do you say? It's very simple. So we have the total cutting, and that's actually 3,259.5 cubic meter. Very simple. So this is how we can actually calculate the earthwork in plain areas is according to the previous session, and earthwork in hilly area according to the today's session. Is there any questions?
No, sir.
Okay, it means you guys are clear about this, okay? How much time do we have? Okay, we have just covered this in 30 minutes, okay? So next, is it enough or I should have another topic?
काफी है आज के लिए सर।
अच्छा, आप लोग इस
इस
पे
पर
प्रैक्टिस करें, अगर किसी जगह पे कोई मसला हो तो फिर आप पूछ सकते हैं, ठीक है? So today we will be just discussing about the steel calculation, okay? And we will just do it from the basic to expert level, and we will just actually cover few things so you can apply them in a huge project. The first thing is actually how do we determine the weight of a steel bar? That's important, and many of the quantity surveyors, they have just learned a formula which is just a plug and chug in, okay, and they don't know about the basic concept, how these formulas come and where a formula should be used, okay. So it's important to know these things better. All right. And the first thing, let's just say if we have to determine the steel weight, okay. But before starting about this, before starting about the steel weight, it is important to learn about the weight, because a weight formula can be, like you can say, if we take the volume of anything and then we multiply this with the unit weight of that material or maybe the mass, okay. Now don't be confused with unit weight and then mass. This is just quantity surveying. You can use both, okay, interchangeably, no problem. Okay, it's not physics. So the unit weight, okay, I'm writing weight over there. So the unit weight times the volume, this can be actually the weight of any material, okay? I'm not talking about only steel. Let's say if we have some slab, okay, concrete slab like this one. And we have dimensions, let's say 6 inches is the thickness, the 10 by 10 is the size of the slab. And now, what should be actually, this is, let's say, RCC slab. What should be the weight of this RCC slab? Of course, you have to take its volume and then multiply it with the unit weight. It's very simple. So the volume can be actually 10 by 10 times 0.5. This is the volume. Okay, we have learned about these things before. Now the unit weight, this is very important. What should be the unit weight of RCC work? What should be the unit weight of PCC work? What should be the unit weight of steel? So if you know all about all these things, okay, about the unit weight of each material, each engineering material or maybe construction material, then it's very easy for you. Okay, you have to just determine the volume and then multiply that with the weight. Very simple. Okay, now the weight of RCC can be actually different. Okay, you have to check. There is a note or maybe schedule about the unit weight of different construction material. You can just type the unit weight, okay, of different construction material in Google, and you can actually find that table over there. It will be just simple. Okay, so this time the unit I'm gonna put the unit weight for RCC work is, let's say, 150 pounds. Okay, what do I mean by 150? 150 pound is actually 150 lbs per CFT. Okay, if you take 1 cubic feet of RCC slab, that can be 150 unit pounds. Okay, so 10 times 10 times 0.5, this is the volume, which is 50, times 150, that's actually 7,500 pounds. This is the weight of the slab. You can even convert this into kgs if you want, because if you remember, 1 kg is just 2.204 pounds. Okay, so you can convert this by dividing it by 2.204. Okay, if you divide that, you can have actually the weight in kgs, and that's gonna be actually, if I'm not wrong, 3,402 kg. So this is the weight of the same slab. Very simple. Okay, and this is actually the basic concept. I'm just coming again into the steel work, no problem, okay? If you have any shape, no problem. If you have slender, if you have cone, okay? If you have any shape, what you have to do is just to determine its volume, and then you can just multiply the volume with the unit weight. It's very simple. And that can be actually the weight of that material. So let's just have an example for steel. Let's say if we have a steel bar, Ehsan, आप इधर हो?
Yes, sir.
And let's say this is just the length of the steel bar, and let's take this is 5 meters. Okay, 5 meters is a huge value, no problem. And we will take the diameter is, let's say, 30 centimeters. Now this is actually the diameter. It means the steel weight can be now very easy. We already know that the weight of the steel can be actually its volume times the unit weight. It means we have to determine the volume. Now remember, the volume of the same thing can be pi d squared divided by 4, because this is the cross-sectional area times the length. Okay, you remember that, Ihsan?
Yes, sir.
Now you
I
have
know,
to,
sir.
okay, that's good. Now you have to put values over here, like maybe for D is 30 centimeter or maybe 0.3 meter, okay, and divide by 4 times the length. What should be the length? That is 5, okay? It means the volume can be now, let me just do it very quickly. Now this is the volume, you can say 0.353 cubic meter. This is the volume, okay? Now we can put this volume over here in the same formula. W equals the volume, which is 0.353 times the unit weight. That's important. You know the unit weight, okay? Now it's also important that what type of steel is this? Is it cast iron? Is it wrought iron? Which type of steel is this? So the unit weight may be changed. However, in constructional projects, most of the time we use mild steels. Okay, maybe in slabs, in beams, in columns. Okay, so these are the mild steels normally. Now, the weight of mild steel bar is actually 7,850 kgs, if you remember this, per cubic meter. Okay, so you have to put that value over here. Now, again, you have to Google the unit weight of each material. So the process is just simple for you. Okay, just multiply the volume with 7,850. We have actually 2,774. This is actually in kg. Is it clear? Now we will just move ahead for some formula stuff, because calculating the volume and calculating then the weight, that take actually much time. Okay, we will use some formula stuff, like maybe we have a formula for weight, which is d squared by 162.198 times the length. Let's say if we have the same bar, so we can confirm if the weight is just the same or not. If we have 5 meters, and let's say this is 30 centimeter is the diameter, and let's say we are asked to work out its weight. So the weight can be, now we have to put, okay, important thing is actually the diameter can be in mm and the length should be in meters. This is important. You should know about this, okay? So we have 30 centimeter. It means the diameter is now 300 millimeters. So you have to take its square, okay, and then multiply this with the length, and the length should be in meters. So that's 5. It's okay. And then divide this by 162.198. Very simple. Now the weight can be actually, if you just calculate that using calculator or maybe any Excel maybe, okay, the weight can be 2,774 kg. It is the same weight, okay, as we did just maybe few seconds ago in the previous slide, okay. So it means the formula works. Very simple. Now this formula is actually for the MK system. We have to look for a formula which can also calculate the weight of steel bar, okay, if we have data in the FPS system. Okay, so let's just learn about that formula as well. We have a formula which is actually d square by 52.9, okay, times length. Over here, the diameter should be actually in sooth, and the length should be in feet. Very simple. Okay. Again, I'm just gonna take an example. Let's say if we have a bar whose length is 10 feet, and let's say the diameter that is 1 inch, then what should be its weight? Then the weight of the bar can be actually, we can put that video over here. As you can see, the diameter that is 1 inch. Okay, I told you that it should be in sooths. Okay, 1 inch means 1/8 sooths. Okay, so we're gonna put it means sorry, 1 inch is just equal to 8 sooths. Okay, it's very simple. Okay, just remember it. 1 inch means 8 sooths. 1 inch is further divided into 8 parts. It means sooth is just the 8th part of the inch. Okay, so we have to convert that into that part. Now 1 inch means 8 sooths, so we can put 8 for the inches, and remember there is square for that. Okay, and we will divide this by 52.9 times length. Length is 10 units. Okay, now the weight should be actually at 64 times 10, which should be 640, and we will divide that by 52.9, which can be actually 12. So this is the weight of the same bar. This is actually the basic concept. Now we will just move ahead and we'll have some practical example. Maybe we will calculate the steel bar for beam, the steel calculation for slab, okay, for footing, etc. Okay, so let's just do it. Now, which one element should I take from construction? Should be a slab or a beam or footing? Okay, it's your work. Tell me. I think for basic understanding, the slab is good. What do you say?
Yes, sir.
Okay, so let's just take a slab. Okay, and there can be actually structural drawing for that, but this time we don't have, so we will have just an example. Okay, let's say the slab is just 20 by 10 feet. Very simple. And let's say there are distributions bar. Okay, these bars are known by the distributions bar, which are actually in the longer span. Okay, or through the longer span, maybe you can say. The bars whose length is just more than the other directional, or maybe the bars which are above the main bars. Okay. Now let's say we are given that the main bars are let's say number 4, and they are 6 inches center to center. It means the distance between two bars that is just 6 inches. It's very clear, and you guys must be familiar with that. Now let's say the distributions bar are number 4, and they are also at 6 inches center to center. Can be different, can be 12 inches, can be 9 inches, no problem. But this time, this is just an example. Now let's say we have a section of the same slab, which is just in this form. Okay, and here are some bars, you can say, just like that. I'm not gonna represent that very clearly. Okay, the thing which I'm looking for is actually the thickness. Okay, and let's say the thickness of the slab is just 6 inches. Let me just connect my charger to my laptop because the battery is running out. Okay, just a second, I'm coming. Okay, are you guys there?
Yes, sir.
Okay. So this is actually the data we have. And let's say we have concrete cover. You guys know about the concrete cover, okay? It is just the cover of concrete, maybe from outer edge till the you can say the steel, and this is just the same distance. Okay, let's say we have the concrete cover over here, and over there is 1 inch, no problem. Okay, it can be different. Okay, in long project, we will actually cover these things in detail. This time, we are just covering the basics, okay? So don't be confused about these terminologies. Now, the first thing is actually, if you remember, the weight of steel, if we need, is actually, we have to determine it by the formula, which is d square by 52.9 times L. Because we have FPS system over here in inches and feet, you can see that. So this formula can be used. Just we have discussed this, okay? Maybe a few minutes ago, if you remember this. You can also use d square. Where is it? So you can use d square by 162.198 times L. Okay, these two formulas are commonly used. You can use actually, of course, again, the volume times the unit weight to determine the steel weight. Okay, so let's just have maybe something which I'm gonna keep these for the notes. Okay, and I'm gonna have actually a duplicate for this, so we can just determine the things. Okay, now in order to determine the quantity, we actually need that formula, and for that formula, if you remember, we need the length of the bars. Over here, there are many bars, so the length of the bar can be actually something like complex. Okay, that's why we have to determine the number of bars. And let's say if I need to determine the number of bars, okay, and let's say I'm gonna say the number of main bars. Okay, and the main bars can be actually, we will take the length, we will divide that by the center to center, and one bar can be added over there. Okay, as an extra bar. So this is the formula, you can say. It means the number of bars can be now the length. As you can see, if we need to determine the number of main bars, the main bars is actually just dividing the side, which is 20. Okay, it is just dividing the long space, it means. So the length will be actually taken as 20, and the center to center for the main bars, it is actually 6 inches or maybe 0.5 feet. Okay, and we will add one extra bar maybe for the start or maybe for the end. So the number of bars can be now 41 bars. It means these green bars along the span, which is 20, can be 41 in numbers. That's very clear. We are not subtracting the concrete cover because this is just wastage of time. We should not subtract the concrete cover over here. Because if you subtract the concrete cover, then the number of bars can be like 40 point something, okay? Which we actually directly then round it into 41. Very simple. Now, as we have the number of bars, we can actually calculate the length of the bars. Let's say the length of main bars. And that can be actually, if we say the total length, then the numbers, okay? And we will multiply the numbers with the length of one bar. Length of one bar. So this is the formula. Now, we have the number of bars, those are actually 41. And the length of one bar, we will determine that, okay? Which is actually, if you see, the main bars are just 10, okay, in length. However, we can now subtract the concrete cover for one side and another side. You can say 10 feet, and we will subtract concrete cover for one side and another side, or you can say 2 times concrete cover. And the concrete cover, that is 1 inch, and you can actually divide that by 12 to convert that into feet. What do you say? Very simple, okay? So this is going to be the length of one bar. Now, 1 over 12 times 2, that is the concrete cover, which is 0.16 something, okay? And we will actually subtract that from 10. It means the length of one bar, or you can say the cut length, can be 9.833. So this is the thing you have to actually tell the steel fixer, okay? Steel fixer have to cut the bar, okay, at the same length, which is 9.833. Now the total length can be actually, the total length, I will say T length for the main bars, okay, can be actually 9.833, which is length of one bar. And we will actually multiply this with the number of bar, which is 41, okay? Very simple. So 9.833 times 41, that can be, if I'm not wrong, it can be 403.167 feet. Very simple. Now we have to put this in the same formula, like maybe the weight can be now d square, okay? This time the bar diameter is just, that is number 4 bar, it means 4 suit, okay? And there is square over there, and divide by 52.9 times the length, which is 403.67 feet. It means the quantity can be now 4 fours are, that is 16, and times the length, and then we will divide that by 52.9. So the quantity can be in kgs, and that is 121.94 kgs. Very simple. Okay. This is
सर
how we.
मेरा क्वेश्चन है सर क्वेश्चन है एक
Yes.
सर ये डी में हम नंबर ऑफ बार पुट करते हैं ना
Yes, yes, exactly.
वो नंबर, जी सर यही बात कर रहा हूँ मैं। तो यहाँ पर हम इंचेस में क्यों नहीं पुट करते सर? अगर हम देखें तो सिस्टम सारा फीट में चल रहा है, तो यहाँ पर तो होना चाहिए था सर।
दिस इज वेरी गुड क्वेश्चन, वेरी वेरी गुड क्वेश्चन। मुझे भी ये पसंद नहीं है कि भाई बंदा इसको फिर सूत वगैरह मिले। तो इसके लिए आंसर मैं आप लोगों को यू बताऊँ ना, कि जब आप इस फार्मूले को डिराइव करते हो d²/52.9, यहाँ पे एक और फार्मूला भी है d²/162 point something. Okay, another formula we have is d² if I don't forget that 24, that one is okay. So we have different formulas over here. Now, while deriving these formulas, the deriver, you can say, they have just converted the diameter into that suitors or maybe mm. Okay, I will also teach how to derive that formula, and then you will understand why we take diameter in mm or maybe in suit. Okay. So after derivation, you will understand that. However, it is not necessary, it is not important that you should use the same formula. It is never necessary, okay? You can use your own formula. Just derive another formula, okay? I will show you how to derive by yourself. Don't worry about that. Just derive another formula for yourself where you can put the diameter in inches. What do you say?
ठीक है सर।
So it was just for the main bar. So we have, you can say, we will say 122 kg. Okay. So the main bars, which are actually number four bars can be, we should buy 122 kgs for the same slab. Now let's just talk about the distributions bar, which are known by the temperature bars also. And we will just calculate the number of bars. For that, we will take the length, which is actually 10 feet. Because as you can see, the distributions bar, they are just actually dividing the same length, which is 10 feet. Okay, so 10 by the center to center distance, that is 6 inches. And we will add 1 bar extra. So this is now actually, you have to just divide 6 inches by 12 to convert that into feet. Okay, this is going to be 21 bars. Now, length of 1 bar can be actually, let's say, length of 1 bar. Length of 1 bar should be actually, as you can see, this is 20 in length. Okay, so we have to subtract 2 inches for one side and another side is concrete cover. So we have 20 minus 2 times concrete cover, or 2 times 1 inches. Very simple. Okay, so 1/12, that is actually something like 0.08, and multiply that with 2. Now you have to subtract 20 minus the same answer, and that's actually length of 1 bar, which is 19.833. Now the weight is very simple. The weight can be actually d²/52.9 times L. Now diameter, again, over here we have number 4 bar. Okay, so 4 that is actually 16, or maybe 4 square divided by 52.9 times length. Length is also known. Okay, now important thing, which let me just erase this. Okay, we actually need the total length, not length of 1 bar. So the total length, which means the length for 21 bars, can be actually, let's say, 21 times length of 1 bar. What do you say? This is what we want, and this is necessary. Okay, so we have 21 bars times the length, which is actually going to be 416.5 feet. It means we have number 4 bars, and whose length is actually 416.5 feet. Now we will actually calculate its weight, like you can say W equals d²/52.9 times L. Okay, so D, that is 4, and square 52.9 times L. L is actually 416.5. Okay, now the weight can be actually, for 4 that is 16 times 416.5, that can be 6,664, and divide that by 52.9. We can have actually the weight in kg, 125.9. You can say 126 kg. Very simple. It means that number 4 bar, we actually have to by, you can say, for the same slab is the same thing is 126 plus the main bars quantity. If you remember, what was the main bar quantity? And it was, if I'm not wrong, 121. Okay. Was it 121 or 122? It was 122, yes, plus 122. So we have to buy the main bars, like maybe 126 plus 122, and that should be 248 kgs. So this is the requirement for the same slab. Is there any question?
No, sir.
It is just straightforward, and you guys have already practiced this, I think.
सर आज बंद है बहुत कम है, पता नहीं सो रहे हैं या क्या वजह।
आज हमने स्केड्यूल चेंज कर दिया ना, तो 10 बजे पे अक्सर लोग सोते, रमज़ान है ना, और आज तो संडे है, इसलिए हमने सुबह के टाइम पे रखा हुआ है क्लास।
मैं तो कहता हूँ कि एंड कर दे सर, बंदे भी नहीं है तो इससे फिर काम हो जाएगा।
हाँ ठीक है फिर।
Yes, sir.
ठीक है, ओके, अल्लाह हाफिज़। All right, let me just open in AutoCAD. I have some drawings over here, okay, related to bridge and maybe culvert, okay. And this, as you can see, this is a abutment and then wing walls. So, as a quantity surveyor, you must be familiar with drawings and terminologies related to different engineering structures such as building, bridges, okay, canals, etc. So because those things are then included in description, okay? Let's say if this is abutment and wing wall. So a quantity surveyor should be familiar which one or which part is just abutment and then which part is just called or known with the or by with wing wall, okay? So this is just a single diagram, you can say. And here we have the, of course, the cross section, okay? Everybody just understand this. And on the other hand, as you can see, we have this bridge, which is, you can say, just RCC bridge, having slab, then the wearing court, some grills, okay, or posts, and you can see this is like a T-beam, okay? And percentages are also given in each member, okay? Like you can say mild steel and beam, this is 2.5%, okay? So we will be just looking into these two examples. We are in the first stage, we will actually determine or we will prepare the abstract of quantities for different materials used in the same diagram, you can say, okay? And then we will switch into the bridge, you can say decking, which is the same thing, and we will actually determine quantities of materials, and then of course we will include cost as well. And I'm not going to do this in whiteboard. We will just do it in a Excel sheet because whiteboard can take much time. So let's just say if I have, it is the same thing, okay? I will say serial number because we do this all the time. So then description, okay, and then we have the numbers, then we have the length, and then the width of breadth, height, and then of course the quantity, and then we have some remarks if we need, okay? Now this is actually the table, which I'm gonna call is, let's say, abstract of quantities. It's your choice if you can do you can give it some styles and coloring, maybe shades, etc. I'm not gonna do that because the video can get longer, which I actually do not want. Now, however, you can adjust the columns width and some other stuffs. That's your work. So the first thing which I'm gonna do is actually, let's just look into the same diagram, which is this one. Here, as you can see, we have abutment and then wing wall. So let me just say if I have, let me just change the color. You can see the red one, okay? Now, in the same diagram, these are actually known by the wing walls, okay? These, right? And the middle thing, which is this one, this is actually the abutment. Now, abutment is actually the support of a bridge or maybe culvert, and these are actually the exterior, okay? Or you can say the supports at both ends. Now the middle supports are then known by the pier, maybe, okay? So I guess you guys note those things. All right. Now, in order to calculate quantities of different materials and which quantities are just included in the same section, you can see them, okay? We have excavation because the ground level is just labeled over there. And then we have actually concrete, 136. And then it is a brickwork because this abutment and wing wall, these things are just, you can say, for a small bridge or maybe culvert, okay? So brickwork, which is pretty good thing, or maybe any masonry work. So let's say the first thing which I'm going to do is actually to calculate the earthwork. Okay, you can say excavation, and let me just label as 1. And then I'm going to say the earthwork, or maybe you can say excavation. It's your work. You can just have anything in description. Now, in earthwork, as you can see, we have abutment and then wing wall. So I would say that first I'm going to calculate abutments excavation, and then I will look into the wing walls. Now, in number, abutment is 1, wing walls are 2. How? You can just see it, okay? Wing walls, these are actually 2. One is this one, another one is this one. Now, abutment, which is this one, and that's actually 1 only. The excavation length, if you remember, we have already discussed these things in very first, third, or maybe 3 or maybe 4 lectures. That the excavation length is somehow very different, okay? Now, the abutment length, as you can see, this is 20 feet, which is already just mentioned were there. From this, let me just draw a rectangle so you guys can see it. You can see this one, okay? It's almost like this thing. So this is, if you look to in top, this is actually 2 feet wide, and the length is just 20. However, we will just have excavation till this point, okay? Till you can say, let me just drag this thing so you can see that, okay? Excavation length can be up to this. What do you say? It's very simple, okay? It means we have to add 2 feet, which is actually, if you see, this is 2 feet, okay? And let me just label it so you guys can then confirm it, and can be very easy, okay, for you. So this is actually 2 feet. We're here, okay? Just clicked on the wrong place, and this is, you can see it, it is just 2, okay? So what should be the length of excavation for the same abutment? It can be actually 20 feet, and then 2 feet for one side and 2 feet for another side. You can see these 2 things, okay? And then here we have 2 steps extra, and 2 steps the other side, okay? It means if I can directly say the length of the abutment for the excavation can be 26. Now, how 26? That's the point which should be cleared over here, okay? So 26, I'm gonna write this thing in the remas, but before writing this in remas, let me just make you understand, and I want you guys to confirm it, okay? Now, just look at over here. I'm gonna say, let me just have some maybe dimensions, okay? Now, look at this. This is 20, and from this, as you can see, we're gonna add 2 for one side and 2 for another side, okay? Now, next, I'm gonna add these 2 steps, okay, which are actually, you can see, this is 1 feet. It means 6 inches one step and 6 inches another step. And to the other side, which is actually 1 feet, it means 6 inches to one step and 6 to another step. Now the total is actually 20, and 2 for another side, and 2 for this side. Actually, it means 24, 1 feet this one, 25, and 1 feet this one, which is 26. What do you guys say? Okay, so it is actually, if you are a little bit good with drawings, so you can do that. However, if you're not that good in drawings and you cannot read these things, the plans maybe, okay, sections, elevations, then if you remember, I have already told you a formula, okay, about a formula. It is actually, you have to subtract the weight of the wall, which is 2 feet, from this, okay, from the weight of the foundation. So it means 4 minus 2, okay, this is actually 2. And then you have to actually add this with the length, which is 20 plus 2 plus 2, 24. So 24 plus 2, that's going to be 26. Okay, I'm going to write this thing over here, like maybe what is 26? Okay, so it is actually the same thing like 20, okay, we have just added 2 feet for the wing walls, okay, for one side, 2 feet for another side. And then if you remember, we have added 1 feet, okay, for one side, for you can say for 2 steps, and 1 feet for another 2 steps. What do you guys say? And in the width, actually, this is simple. Width is very simple. You can see the width can be from this point till this one, which is 4 feet. And if you cannot just count this, you can see it in the section as well. The width of foundation, which is 4. So you can put 4 over here. And now another thing, which is actually height. And this is actually the height of excavation, and where we do actually excavate, and from which level we actually excavate. It is actually the ground level. So we have to count all these heights below the ground level, which is actually 1 feet and 2 feet and then 2 feet, which is actually 5 feet, okay, total. So we have 5 over here. Now the quantity can be actually, we have to multiply these things. Okay, you can say the number, the length, the breadth, then the height, which is actually the quantity. Very simple. Okay. So the number, the length. Okay. लगे बंदे क्या कौन है ये बंदा? The width and then actually the height, which is F4. Okay, so I'm gonna multiply that F4 as well. So 520, and I'm gonna just enter another column over here so we can have per unit. Okay, maybe let's say units, and this is going to be in CFT or maybe cubic feet. So we have quantity, which is 520. Now let's talk about the wing wall. Now I'm going to say the length can be 6 feet. How? That's going to be very simple. You can see it, okay? We have 6 feet is the length of the wing wall, okay? Now, the total length of the wing wall, that is actually 6 feet. You can see it in the diagram, okay? But this is actually from this point till this. Why are not we actually adding this portion, which is, you can say 2 feet? Sorry, 1 feet, because one is 6 inches and another step is 6 inches. Why are not we taking 7 feet as the length of the wing wall, you can say? And this is actually because, okay, let me just say, I'm not taking this portion because this portion is already taken over here with the abutment. What do you say? These 2 steps are taken from the wing wall. So if we add these 2, it means we can subtract those 2. Very simple. So actually it is the same thing, okay, from this point, okay, from this point till this point. So it is the same thing as 6 feet, okay? We are not counting this one, okay, actually. So it means 6. Now, of course, the width of foundation, it is the same, which is 4. The height is the same, and we can actually drag the formula just like that, okay? So this is the quantity. Now, total can be actually the summation of the above 2. So we can say the total quantity may be, let me just merge these. So the total earthwork for abutment and wing walls. Very simple. You can even, and actually you should highlight these things, okay? And I'm gonna remove that one so we can have yellow. So this is one thing which is been covered. Now, next, what we're gonna do is actually to determine the concrete work. And why I'm deciding concrete work, because in this section, we have excavation, and then over here we have concrete work actually, which is 136. So let's say concrete work, and which is 136. Now, the concrete work actually can be the same for both, okay? In, you can say, in depth and then in width. The length can be different, of course. So we're going to calculate this for the abutment and then wing wall. Remember, abutment this time is 1, wing walls are 2, okay? And the length of abutment, it can be the same. Why the same? Actually, if you see the foundation width, it was just 4 feet. Now the concrete work, it is also 4 feet wide. That means the length of both quantities, or maybe both elements, is just the same thing. This is the reason I'm gonna say that the length of the abutment for earthwork is the same thing as the length of the abutment for concrete work. Okay, and this is the same thing for the wing walls. Now next, actually the width or maybe the breadth, it is the same thing. Okay, in PCC you can see that, so it's gonna be 4. However, the height for both, it is just something which is different. Okay, we actually take the height or maybe the depth of earthwork from the ground level. This time actually the concrete is only 2 feet if you see that. So the height is just 2 feet and 2 feet for the wing wall as well. Now I'm gonna just copy the formula over here and we have to just paste it, and then let's just drag this formula below. Now we will actually sum the above two, which is CFT, okay, 304 CFT. That means this is the total. Let me just copy this thing and paste it over here. So it is the total, maybe PCC or concrete work, 136, okay, for abutment and wing wall. And let me just share these as well. Okay, it's very simple. Number 3, we have actually number 3, and it can be in this section. If you see, we have this step, which is actually, of course, the brickwork or maybe masonry work. And then we have another step, which is this one. Okay, so 2 steps, you can say brickwork. Okay, so again, jumping into the Excel, it means, let's say we have the brickwork and it is in 1:3. 1:3 is actually the ratio of mortar which is then used in the same brickwork. Now I'm gonna say the brickwork, okay, for the abutment, and then I'm gonna say it for the wing wall. However, in abutment, if I'm gonna talk about the abutment, there are 2 steps. Okay, one is actually this one, another one is this one. Okay, so we have to take 2 steps, and because of that, I'm gonna say step 1 and then actually step 2. You can also just label these things in the same Excel as the brickwork below ground level and then the brickwork above ground level. So as your work as a quantity surveyor, you should consider all these things. And I'm gonna say again, let me just call this guy is A, okay? And over here, I'm gonna copy those things and paste them over here. And I'm gonna say B is the wing wall. So we have actually step 1 and step 2 in wing walls as well. Now, abutment, if you remember this step 1, let's just jump into the AutoCAD. As you can see, this is the step 1 whose width is just 3 feet. Now, what's the formula? You have to just subtract actually the width of the wall, which is 2. So 3 minus 2, that is actually only 1. Now we have to add the length of the abutment, which is actually 20, and 2 for one side and 2 for another side, which is 24. So 24 plus 1, that is 25. Very simple. So the length of abutment is just 25. And I'm going to actually, this is for step 1, right? 25. And let me just actually annotate that for you so you guys can be very clear about this thing. Okay, remove those things which are actually some extra work. Now I'm gonna have the dimensions. Now step 2, if you see, it is from this point. Okay, I'm gonna label this from that point till this point because this is also step 2. Now you can see it is actually the dimension 25. Very simple. Out 25 in remarks, you can just put 25 is actually something which is 3 minus 4, and you can also actually, if you remember, we're here, it was actually something different. Okay, you can also just mention 26 is maybe, let's say 20, okay, plus 2 for one side, 2 for another side, okay, and then actually adding the thing which is maybe you can say 4 minus 2, okay, and this is actually the same thing. Okay, that is not equal, that is actually 20. So 20 plus 4, that is 24, and 4 minus 2, which is 2, 24 plus 2, it is actually 26 again. It is the same thing over here, okay? It is the same thing over here for this thing. Now, 25 that can be just written in remarks is, you can say again 20, which is the maybe the distance, the clear distance between two wing walls. And we're gonna add 2 feet for one side wing wall and 2 feet for another side's wing wall, okay? And then again that formula, okay? It is actually 3 minus 2, okay? 3 is actually the weight of the step 1, and we are subtracting 2, which is the weight of the abutment. So 25 should be. Now, what is the weight of the same wing wall, you can say, in the same step? That is 3 feet. So you can put 3 over here. Now the height. Let's just jump into the AutoCAD so we can see the height. The height is 2 feet, you can see it. So 2 feet over here. All right, and number, actually that is 1, and we have something mistake over here, like you can say. And number, that is 1. For step 2, that is also 1, because this is abutment. However, this is 25, which is the length. The weight is 3 and the height is 2. So this was actually the mistake, but you guys can see it. You guys are sleeping, I think. For step 2, these two things are different, actually, the length and the height and maybe the weight. Let's just confirm them, okay? You can see that these are actually different. It is 2 feet wide, you can say. The height is 11 feet, okay? And then the length can be different as well, because it is from that step, you can see it, okay? It should be 20 and adding only 2 feet to one side and 2 feet to another side. It means this can be 24, if I'm not wrong, okay? From this point, actually, till that one. You can see it is 24. So, a number that is 1, the length is 24, the width is actually 2 wide, and the height is 11, if you see. We have to copy the formula and paste it over here, and I'm gonna drag that one, okay? So this is now actually the quantity of brickwork, okay, for the abutment. Now, for the wing walls, actually, step 1 can be 2 in number, step 2 can be 2 in number, because wing walls are 2. Now the length, what should be the length? 6 minus 1 step, maybe, okay? Let's just see if I'm right or not, okay? So step 1 is actually, if you see, this is 6 feet, okay? And it should be actually, you can see it, maybe let me just say linear. This is step 2 from this point till that one, it is 6, okay? And again, step 2, I'm going to take that in advance. That is 6, and over here it is 6 again. It means these are like short walls. If you remember long wall, short wall method, we have already discussed these things in detail. So what we have covered in that time, actually, the length of the long wall can be actually a little bit more than the actual length for each step. However, the short walls remains the same in length. So this is the basic concept, if you guys remember that. The length is 6 for one and 6 for another step. Now, the weight can be both actually the same, because the section is just the same for both abutment and wing walls. And the height is actually the same for both. What do you guys see? And I'm going to apply the formula. So you can drag that to step 2, and then let's just add all these things. And this is actually the summation. It is 1014 CFT. Very simple. So it is actually the total, maybe let's say I'm gonna copy this, the total brickwork for abutment and wing wall. So let's say total brickwork for abutment and wing walls. Very simple. Is there any question?
Yes, sir.
Okay. And what is it?
सर ये ग्राउंड लेवल से ऊपर ये 1 फीट का एस्टिमेशन हमने नहीं दिखा रहा है.
एक second. Let me see. Oh, so and below, it is actually below the ground level. And for step 2, as you can see, it is 11 feet, okay, for step 2 is height. What do you see it?
Yes, sir. Okay.
Yeah, it is clear. Now, next, actually, what we do is the pointing or maybe the plaster work for the brickwork. So we will only consider the things which are maybe above the ground level. Below the ground level, we will not consider that. If it is required, or maybe according to the drawing and according to the tender, so you have to just count them. This time, I want the video to be shorter, so I'm gonna take only the things which are very easy, I mean, just both sides of the wall and above the ground level. So the height can be actually 10 for this time, okay? Because we will subtract this 1 feet. So the height can be actually only 10 feet. So let's just say the plaster work, and this is number 4. And I'm gonna say plaster work, okay? And slash maybe pointing. So one of these two can be taken. I'm gonna say, okay, let me just add some other informations, like maybe both sides of walls, which is abutment and wing walls, you can say. And then I'm gonna say above the ground level. Very simple. Wrap the text so you guys can see it in the same column. One thing is actually, I'm gonna consider, let's say A is abutment, and then B is wing walls. Now in number, it should be 2 because we are pointing or maybe plastering both sides of the wall. In wing walls, okay, these should be actually, and one another thing, okay, let's just jump into the same thing over here so you guys can be very clear. So if you look to the same diagram, we are actually plastering above the ground level, which means we will look only into the step 2, okay? So for the wing walls, we are actually plastering both sides, and for the abutment, we are plastering the both sides. But something which is really wrong over here is actually, let me just copy these things so you guys can see it, okay? Let's just say, and I'm gonna explode this one, so you can see it graphically, okay? Now in the wing walls, I can only just, you can say, let me have some color, okay? In the wing walls, these green areas can be plastered. For the abutment, these two can be plastered. What do you guys say? It's gonna be very simple. If I say that both sides of the wing walls, okay, or maybe both sides of the abutment, it can be very wrong because we have some extension for the outer side, like you can say date extension, okay? So that is something very, you can say, lengthy. So what best here is you have to take the parameter and then multiply that parameter with the height, which is actually maybe 10, okay? Because we are subtracting that 1 feet, right? Very simple. So I'm gonna remove that 2, and let me just say 1 instead, and let me just remove that one, and I'm gonna say abutment, or maybe I can even include that over here, okay? Abutment and wing walls. Very simple. Okay, so in number it is 1, the height is 10 feet, and I can even just delete this raw now, okay? Because I supposed to make you guys sure about this, what I'm gonna do over here now, okay? So what should be the length and height, or maybe the thickness that is just ignored because we didn't consider that while doing analysis, if you remember from maybe 6th and 7th class, okay? So during analysis, we then include the thickness of plaster. Okay, so let's see what's the parameter now. It is actually 20 plus 2 plus 2, okay, for that side. So that's gonna be actually 24. Now, this is 6 plus 2, okay? You see it, I can even remember them, which is 8. Now, this portion is 2. Look, I remember it. So as a quantity surveyor, you should be that familiar with drawings, so you guys can even consider things, okay, before even looking into the drawing or maybe just counting the digits, okay? So this is gonna be 6, and over here, this can be 20. Look, I'm very sure it can be 20. You see it, okay? Again, this is 6. You see it, and this is gonna be 2. And then we have actually 8, which is remaining. So this is what I want, and this is the parameter. You have to actually add all this, you can say these parameters together, so we can have the total parameter, like maybe 24, and then we have 8, which is actually 32, and then we have 2, then we have 6, which is actually 40, and then 20, so we have 60, and then we have 6 plus 2, which is 8, and then 8 were here, so plus 8, and that's gonna be 76. Are you guys there?
Yes, sir.
Is 76 okay or not? Did anybody calculated it? So the number, then the parameter, and then the height, that's going to be the quantity in SFT, okay, or maybe in square feet, right? So this is called the abstract of quantities. We have all these things in the same drawing. There is nothing, I think, more over here in the same drawing. So what's your question? Let me know if there is any confusion. I will even share this drawing with you so you guys can practice it. Let me now just save this drawing and let me just send it to you, okay? And even I'm gonna save this one. All right, we have almost 20 minutes remaining, so I'm gonna just do this thing quickly, or it was enough. You guys can tell me, okay? What do you guys say? Should I start this bridge work, or it was enough? We're gonna just it's enough, okay? We will cover this thing tomorrow, inshallah.
ठीक है सर.
Okay, Allah Hafiz. Okay, if you guys remember previously, I mean yesterday, we have already done all these things, okay? And it was related to the wing wall and then abutment, okay? Because we are supposed to just determine or prepare the abstract of materials for a bridge. Okay, so these things, you can say the abutment and wing walls, these are just related to bridges or maybe culverts, okay? Now, in the same session, we will be just determining the abstract of quantities, you can say, for the same bridge section. Okay, only the section, and then these dimensions, I mean, drawings are just known over here, okay? And as you can see, we are asked to estimate the cost. Okay, remember, the cost estimation is just required for the same bridge work. And as you can see, it is just 6 meters span, okay? And one span only. And the bearings, those are 45. And if you see, what do you mean by bearings? Bearing is actually something, let's say if I have, say, let's say this is one abutment, okay? And here we have another abutment. You guys must be familiar with this. And let's say if I have girder, the girder can be just like in this form. If you see girder, maybe beam, etc. Okay. So this green color rectangle represents actually the girder. Now, what do you mean by the bearing? Bearing is actually just this overlap. You can see this overlap at the end. So this is known by the bearing, okay? You can say this portion, this is actually bearing, okay? This extension to one side and another side. So this must be, you can say 45 centimeters. I hope you guys understand the real meaning of the bearing now. So this bearing should be taken as 45 centimeters, and then steel for different elements, you can say mild steel. In beam, that is 2.5%, for slab, that is 1%, and for the post or maybe for the handrails, okay, which is actually something like this one, okay, on both ends, that is just only 1%. So we'll be just preparing the abstract of cost for the same bridge work. Is there any question? So we can move forward, and I'll be just using, of course, the previous one table, okay, just the same table. We have already used this for a small project, if you remember, for a one-room project, okay. Again, it is the same thing, the number description, I mean serial number description, number, length, breadth, height, and then quantity. We will be also including the unit, and then of course the remarks for detailing if there is any need, okay. So let's say if I have, let me just remove, or let me just say merge and center. and I'll say the abstract of cost of our bridge, that is 6 meters span. Okay, very simple. Now, again, I'm not gonna put all those things over here, serial number, because I have already frozen the top row. Okay, so it means the first column represents the serial number. Now, in serial number, I'll say only 1. Okay, this is the first item which we gonna calculate. Now, as you can see, let me just jump into the AutoCAD again. This is the same section. Okay. Now, what I'm gonna calculate is actually to determine the. As you can see, this is just the RCC work. Okay. Everywhere you see RCC work in this section. Okay. I have not just included the steel rebars. Okay, in the same section, because this drawing, I just prepared this drawing very quickly in short time, so it was a little bit complicated to include all those things. You can say maybe some rebars were here like that. Okay, so no, never mind it. Now I will say, let me just calculate the RCC work, which is actually 124. Okay, we have already discussed this yesterday, if you guys remember it. Okay, 124, and then I'll say I'm not including, it means excluding the steel work, maybe steel fixing. Okay, and let's say binding, and however, comma, I'll include centering. Okay, so this is the description. I will just read the text so we can see it in one cell. Okay. Now a number, as you can see in the diagram, we have only 3 T-beams. You can see it. Okay. So it means a number, the T-beam can be like, you can say 3 in numbers. Okay. And over here, I'm going to include another thing, which is I will say that the T-beam, let me just say T-beam, and I will only take the ribs. Okay, for T-beam. And in the next row, I will say T-beam, and then I will say the fillets portion. So a rib, by rib, I mean just this rectangular portion. Okay, if I can draw a rectangle, you can say, so this rectangular portion, this is known just by the rib. Okay, and here, as you can see, we have fillet of 15 by 15 centimeters. So first, I'm going to calculate the ribs, and then we will actually look into this thing. Okay, now in number, these are going to be 3. Okay, so in Excel, I'm going to put 3. Okay, now the length should be 6.9. How 6.9? Okay, let me just jump again. As you can see, the span is just 6 meters. Now there is bearing to both sides, which is 45 centimeters. It means 45 plus 45, okay, which is 90 centimeters. Now 6 meters and 90 centimeters means 6.9 meters. Very simple. Okay, you can confirm this in the same drawing by the dimensions. Let me just say, if you can see, these two lines are maybe these two, and then these two, actually these are, you can say the girders are maybe T-beams. Okay, so you can just confirm their length. Okay, from this point till this point, it should be, you can say 690 centimeters, which is actually 6.9 meters. Very simple. And graphically, if you are not that good, okay, with drawings, let me say if this is one girder, and here we have, let's say, I'm gonna just make it a little bit, let's say D space, and maybe 90. Okay, and then maybe let's say 300. Okay, I'm just gonna draw this for you guys so you can understand it. Now the span is actually 6. Okay, from this point till there, so it means 600. Now let me just take its mirror. Okay, I'm gonna take its mirror, and as you can see now, okay, I'm gonna remove this. Now we have a girder. Okay, let me just draw the girder, and the girder is actually from this point till this point, you can say, like this. Okay, it is of course not at edge, maybe like that. Okay, and even I'm gonna just take its rough copies, maybe like this. Okay, so these three are girders. Now, as you can see, the span that is actually from this point till this point, it is a top view, you can say. Okay, it is 600. Now here we have bearing, which is actually 45 centimeters one side and 45 centimeter for another side. Is it clear now? Okay, so 45 plus 45, that is 90 centimeters, and then 600 centimeters, which becomes actually 690 centimeters, and that's of course 6.9. Okay, I think it's clear now. Now, what should be the width? Of course, we can just confirm that from the drawings. You can see it over here, okay? It is 35 centimeters, okay? So 0.35 meters. Now, the height of the rib, let's just see what's the height of the rib. It is from this point till that point. So 75 can be taken over here, okay? So 0.75. I'm just converting all the videos, okay, into meters, so we can do it very quickly, okay? I'm going to copy the formula and paste it over here, and you can confirm it by double click, and that's okay. Now this is going to be in CFT. Now again, the T-beams fillets. Now fillets must be actually, as you can see, the T-beams are 3, but fillets are going to be 6, because 2 fillets for 1 beam, okay? So 3 twos are, which means 6 fillets, okay? Like 1, 2, and 2 were here, and then 2 were here. It becomes actually 6. Okay, so in number, I'll say 6. Okay, there is a chart. Let me just open. Cubic meters, sir. Oh, yes, very good. Thank you so much. As you can see, the dimensions, the length, breadth, height, these are actually in cubic meters. Very good, thank you. So I'm gonna write the unit is cubic meter, okay? And now again, also 6.9, that in remass, you can just say maybe like 6 meters, and we will add 0.45 and 0.45 for one side and the other side, of course. The length for the T-beams fillet is going to be the same, because this is just, of course, running along the length. Okay, very simple. However, the breadth and height. Okay, now the breadth and height, this is actually the cross-sectional area. So it means we have to put cross-sectional area in the same cell, maybe. You can say we're here. I can even merge this, no problem. Now, as you can see, the fillet, it is just triangular, which means it is 15 times 15. And if you consider this is a square or maybe rectangle like this, okay, like this one. So they have actually mentioned the dimension. 15 by 15 is actually the height and then the width. So 15 times 15 divided by 2, that's going to be the area in cross section. It is just a right angle triangle, okay? So 15 times 15 and divided by 2. Very simple. So I can even say like maybe 15 and then multiply that with 15, okay? And you can actually divide this by 2 if you want. And this is going to be the area. Now multiply these 3 columns like maybe equal, and we will actually multiply this with this and with actually that one, and that is something. Now another thing which is actually 15 centimeters. Okay, so we have to convert that into meters, which is 0.15 now. Now this is our answer, and this is going to be in cubic meters. Very simple. So RCC for the beams or maybe for these girders is just done. Now we will actually just consider the RCC slab maybe, okay, which is 1, 2, 4 again, and 1% steel over there. So let's consider this slab, okay, you can say this one. Now for the same slab, I can write some description, maybe RCC slab 1, 2, 4. You can also mention thickness over here, but does not matter. In number, it should be only 1 because it is just a single bridge. It means this slab is going to be only 1 over here. Length is going to be the same. because it's just running along the same thing, which is, let me just draw a rectangle so you guys can see it in the plan, okay? The slab can be from this point till this point, okay? It means up to the girders or maybe the T-beams end. So the length is going to be the same for the slab as well, okay? Now, the weight of the slab, it can be actually 7.7. How? It's also shown in the diagram. You can see it, okay? Look at this, okay? The top dimension, this is 770, okay? Which means 7.7 meters, okay? And this is because the slab is just up to this point. If you extend this line like that, okay? And on the right-hand side as well. So this is now the slab, which is actually 770 in length. I mean, in width maybe. Okay, no problem. Now, what should be the height of this slab? It should be 20 centimeters. It's just mentioned over here. You can see it. It's 20. So we're gonna put 0.20. We can just copy the formula and paste it over here so we can have the quantity in cubic meters. The railing posts, those are also, if you see, these are concrete. You can see these things. Okay, let me just draw a rectangle so you guys can see it clearly from that point till this point. This green rectangle actually represents the railing posts. These are RCC, so we're going to calculate them. Now, the railing posts should be actually, you can see its width, which is 15 centimeters. It means these are, you can say, square. So 15 times 15 can be the cross-sectional area. And then we will take its height, which is actually, if you see, that is 120. And of course, 20 over here, if you consider this as well. So 120 plus 20, this can be taken. If you just ignore this 20, and these can be actually taken with curve as well. So this is going to be very simple. Now, the railing posts, these can be actually, if you see, these are squares. So it means we can even consider the intervals of maybe 2 meters or maybe 1 meter. So we will just divide the total distance by or maybe the total span, or maybe just the span with even the bearing, okay, by the interval. So we can have actually the number of posts, okay. It means, let me just say, okay, if we have, let's say 1 meter interval, okay, let's say if the post is just after each meter, then we can have actually 6 posts on one side and 6 on the other side, okay. You can just say like maybe if I'm not wrong, let me just say if we have the posts from this point like this, and let me just draw it, okay, if I can draw it, which is 15 by 15 like that. And if we have maybe a post over here, and let me just take its copies so you guys can see it, okay, and the arrays maybe. And in the array, let me just say the number of items, if they are 6. Approximately, I'll take just approximately, okay, over here. So if you see the distance between 2 can be actually 1 meter, it means 6 posts on one side and 6 posts on the other side. What do you say? It means the number of posts can be actually 12. Let me just say railing posts. Now in number, those are 12, and the length and width, those are 15 by 15. So I can say 0.15 for the length, and for the width or maybe breadth, that is 0.15 again. The height can be taken actually, let's say, that is, if you take it with the same curbstone, then it can be 120 plus 20, okay? It becomes actually 140. However, if you skip this area, like maybe if you extend the curbstone up to this point, then it can be only 120, okay? So let's just say, if I can just delete the previous one, like maybe this, okay? Let me just remove this one. So it can even be in this form, okay? So let's just say if we are taking it without the curbstone, so I can say 120 can be the height, okay? So I can put 1.20 and I can just drag the formula to the down one row, okay?
railing post क्या होता है?
What?
Railing post
जी जी
ये क्या होता है सर?
अल्लाह के बंदे ये ब्रिज पे कभी आपने पैदल वॉक किया है?
जी सर।
अच्छा, तो ब्रिज के दोनों किनारों पे सेफ्टी के लिए वो रेलिंग होते हैं ना, जिस तरह हम स्टेयर केस में हैंड रेल रखते हैं,
हाँ सही है सर।
वो कंक्रीट के बने होते हैं अक्सर। वही चीज़ है, ठीक है। मतलब सेफ्टी के लिए अगर कोई गाड़ी खराब हो जाता है, आउट ऑफ कंट्रोल हो जाता है, तो फिर ब्रिज से नहीं गिरते वो गाड़ी फिर।
ठीक है सर।
अच्छा अच्छा, again we have okay, so that's done, can be in cubic meter, which is 0.32 and 4. One another thing which is actually this thing, okay, Curbstone. Let me just hatch it so you guys can see it better. This area, and which is actually concrete. This area, we will just take its cross-sectional area and then we will multiply it with the length, okay? And the length should be actually the same length as the T-beam's length, okay? So I'm gonna say the curve. So curve are 2 in number because we have one this side to this side and another one to the other side. You can see it over here, okay? And if you see, we have already just extended this to the other side. So it means 2 a number can be taken, 2. Now, what should be the length? Of course, 6.9. Because the curbstone may run actually along this the length or maybe along the span, okay? So this can be 6.90 now. Now, what should be its width and then what should be its height? The height is clear. If you see, it is only 20 centimeters. So I can put 20 centimeter over here in the height, which is 0.20. Now, the width can be taken, which is actually maybe 35 centimeters. If I'm not wrong, so we can confirm it, okay? From the dimensions and up to this point, it is just 35, okay? We are actually ignoring this chamber or maybe some fillet conditions, okay? Because they are constructed and then they are pressed with the float maybe, okay? So that's why they can be taken in the cross-sectional area. So the length actually, if you see, this is 15, okay? And this portion is actually 20, and which becomes actually 35, okay? You can see it. It is 20 by 20, but this 20 is actually up to this point, okay? However, we have 15 centimeters is the post that can be added. You can see it, which becomes actually 35 centimeters, okay? So you can say 0.35. We can drag the formula, and of course, this should be in cubic meter. The RCC work is been actually calculated. If you see, there is nothing remaining in the RCC work. So I can add them, okay, all, you can say, okay, all these things with the auto sum maybe, which is 17.8, blah, 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 okay, maybe in cubic meters. So this is 17 cubic meters RCC work. I can just remove those above because there's just a lot of text were there. So now you have to actually mention these things, okay, like maybe total RCC work, which is 124. Is there any question now?
सर ये फ्लैट का एरिया हमने स्क्वायर लिया है या ट्रायंगल?
इस चीज का फिलेट का
यस
फिलेट का हमने ट्रायंगुलर दिया है ना, ये वाला, ये पोर्शन, क्योंकि ये टी बीम है।
यस सर।
यहाँ पे डायमेंशन बेशक इन्होंने 15 बाई 15 जो कि स्क्वायर बनता है, लेकिन हमने तो ट्राइंगल कैलकुलेट कर देना है, 15 बाई 15 डिवाइड बाई 2 कर देना होगा ना। Another thing which is actually I think we have something remaining over there. That is maybe in the wearing coat. You see, we have wearing coat over here. Like maybe let me just color this so you guys can see it. Maybe this wearing coat, which is actually hedged, maybe the red one. This wearing coat is also remaining, but I'm not adding this with these things because in wearing coat we may have the concrete like maybe bituminous concrete. All these things, okay, you can say these five things, these are cement concrete, okay, made of cement concrete, and the wearing course can be actually bituminous concrete. So I'm gonna say number 2, and that is RCC work, not RCC, of course. I will just say like maybe wearing cord. The ratio can be different, okay. Let's say this is 1 to 4 again. In number, it should be 1 only. The length should be again 6.9. What do you say? Because it is the same thing, okay? If you consider the diagram, if you see. However, the width can be little bit changed. It is also given over there, okay? Little bit above. It is 700. You see it? It's 700. So the width is just 700. I can type only 7 over there. And now the height, it's also shown over there. If you see the wearing course, it's not mentioned in the maybe the dimensions are not given. However, I'm gonna just confirm it over here from the dimensions such as linear, and that is 10 centimeters. Very simple. Okay, so 0.10 only. I can copy the formula and paste it over here, and this is 4.83 cubic meter.
सर asphalt में bitumen भी होता है और क्रश भी होता है, तो इस वजह से ये पूछ रहा हूँ कि कैलकुलेशन इस तरह होगा या कुछ चेंज है इसमें।
नहीं नहीं, असल में क्या होता है, मैं जरा आपको समझाऊं। अस्पार्ट को ना हम जब डिमांड करते हैं किसी रोड के लिए, तो हम इन टर्म्स ऑफ क्यूबिक मीटर डिमांड करते हैं, ठीक है। एक तो ये बात हो गई। फिर ये जो इसका रेशो डिजाइन किया जाता है ना, तो रेशो के बेस पे आप फिर एनालिसिस करते हैं, ठीक है। अच्छा, अस्पार्ट अक्सर ये भी होता है कि हम मन टन वगैरह में इसको डिमांड करते हैं। चलो मैं कह लूँ कि भाई 100 टन का अस्पार्ट चाहिए, ठीक है। तो 100 टन का अस्पार्ट जो है, ये फिर हम उस सीन या फिर उस तरह कैलकुलेट करेंगे जिस तरह हम स्टील वेट कैलकुलेट करते हैं। अब जरा इसको कंसिडर करें, यहाँ पे क्या चीज़ है। मैं जरा कर लूँ कि भाई एक सेकंड, मैं यहाँ पे लिख लूँ अगर अस्पाल्ट वेट मैं लिख लूँ, ठीक है। तो हम वेट के हिसाब से फिर उस चीज़ को देख लेते, और फिर हम कहते हैं कि भाई यहाँ पे अगर मैं फार्मूला लिख लूँ, ठीक है, इक्वल, फिर मैं इस चीज़ को लूँगा और अस्पार्ट का जो अपना यूनिट वेट है उसके साथ मल्टीप्लाई करूँगा। अब यूनिट वेट लेट से 23 एंड 30 kg है पर क्यूबिक मीटर। तो ये 2330 kgs पर क्यूबिक मीटर, ये डिफरेंट हो सकता है, डिज़ाइन पे बेशक डिपेंड करता है। ये आप स्पेसिफिकेशन से देख लेना होगा आपको इन चीज़ों को फिर। Okay, and even if it's mentioned on the drawing, in the drawing that what type of bituminous course is this, okay? It can be even sheet spot, can be premix, okay? So those things then depend, okay? You have to actually study the specifications then. And according to those specifications, you have to calculate the quantity of a spark. Very simple. This is actually now in kg. I can say that we need 11,253.9 kgs as part. Very simple, okay? For the same cord, wearing cord. You can convert this into tons. Just divide this by, let's say, if I can put bracket over there and divide this by 1,000, okay? Let me just close this one over here. And this is actually 11 tons maybe. Is it clear? And I think we have covered this in maybe in the 4th or maybe in the 5th class while doing analysis. Am I right or not? I think we have just covered these things. Okay, now next we will be just let's just determine maybe the steel work, which is just mentioned over here in terms of percentage. If you have percentage, then of course determining the steel quantity is very easy. You have to determine the steel quantity in terms of volume and then multiply that with the unit weight, so you can have that maybe the weight of steel in kgs, maybe in ton, maybe in quantal. That's your work then. This time, let's just say in the same Excel sheet, I'm gonna say number 3, and I'll say steel work. Steel work is actually in different elements, and I'm gonna say steel work, and then including binding and fixing.
सर एक और कंफ्यूजन है वो सर, ये जो वेयरिंग कोट है ना,
जी
इसकी थिकनेस सर 10 सेंटीमीटर है। मैं अगर asphalt मंगवाऊंगा तो मैं 10 सेंटीमीटर के बेस पे मंगवाऊंगा या 15 सेंटीमीटर पे?
This is very good point. If you remember, maybe from some previous sessions, okay, while determining, okay, let me just confirm. Have you just attended the previous class while we were determining maybe the sub-base, subgrade, and then the base, and then the topping of a road? Have you taken those classes?
जी जी सर, उसमें आपने बताया था।
Okay, that time, if you remember, we had included the compaction factor.
जी सर, बिल्कुल।
Okay, that's good. But we're here in the wearing code, something it is very different because the density which I have put it, okay, we're here maybe like the density, and it was 2300 and maybe 30 kg, and this is per cubic meter, okay? Now, it depends on the density actually. This density is actually the density of compacted asphalt. It means compaction is already considered in the unit weight over here. So if compaction is considered in the unit weight, then why should I include the compaction factor in the height for the wearing code? Chalo, steel ke, okay, we will be just determining steel now. And now we have actually steels in different members. Maybe you can say in the beam, and there is steel in the slab. There is steel actually in the railing posts, and maybe we have nothing remaining over here. Okay, let me just confirm it. We have three types of in the beam, as you can see, in the slab, and then in the mild steel. Very simple. So we will be actually looking into the percentage. And this percentage is actually, if I consider the beams, okay, let me just say beam, there is 2.5% steel in the beam. So you have to actually take 2.5% of the beam's quantity, okay? You can see that, okay? Just adding these two. Let me just have one another one over here so we can have the total for the beam. Okay, like that. So we have to take actually 2.5% of 5.8, you can say. It means I can even remove these, I can even merge them because we are taking the percentage. Now, how do you take the percentage? That is actually 2.5%. Okay. Now, percent means actually that can be in 100. So 2.5 divided by 100, it means we can take 0. Maybe 0.25. Okay, because we have already divided it. Now we will multiply this with the quantity of concrete and the beam, and this is actually the summation of these two. Okay, so I can just put the summation sign over there. Is it clear? You can even put brackets over there. Okay, now this is actually the volume of steel now. Now what we do actually is we multiply the volume with the unit weight of steel. Okay, you guys should be familiar with the unit weight, which is 7,850 kg per cubic meter. Is it clear or not?
Yes, sir.
So we have the quantity which is 1157 kg. Now in the slab, now the quantity, I can even put that quantity over here, okay? And I can even just, maybe you can say 58, and I'll say in kgs. Okay, now for the slab, that is only 1%, I think. Okay, let me just confirm that. As you can see, for the slab, the mild steel, that is only 1%. What do you mean by 1%? It is actually 0.01. Okay, that's 1% only. So I can say maybe 0.01 of what? Of actually the quantity of RCC slab, which is this thing. And then, of course, we can multiply this with the density or maybe the unit weight, which is 7,850. Okay, that's gonna give me the kgs, which is 835. Okay, I'm rounding actually the things. Okay, just a
सर एक
second.
सवाल थी परसेंटेज के बारे में। बाज औक़ात हम देखते हैं कि ड्राइंग में वो मतलब शो हुआ है बार बेंडिंग शेड्यूल जो पूरा डिटेल है, ये इधर आप परसेंटेज के हिसाब से बता रहे हैं। आप थोड़ा क्लियर कर दें बस। मतलब जो ड्राइंग्स हमने देखे हुए हैं वो लिखे हुए उधर ही, मतलब सेंटर टू सेंटर पास स्टील के
एग्जैक्टली
ये भी
हमने,
बता सकते हैं ना।
जी जी। तो कल नहीं और परसों उस चीज को हमने देखा था। बीबीएस के बारे में आप बात कर रहे हो, तो वो तब होता है जब हम डिटेल में चीजों को देखते हैं ना, कि चलो एक नंबर 4 बार है, नंबर 5 है, नंबर 6 है, ठीक है, तो उनका कितना केजी या टन क्वांटल आनी चाहिए, तो उन चीजों को हम फिर डिटेल से देखते होते हैं। ये मेरे ख्याल से हमने डिस्कस किया था प्रीवियस, मेरे ख्याल से 8 या 9th क्लास में। वो अब मुझे नहीं पता कि शायद 8th क्लास था या 9th, जिसमें हमने स्लैब की एस्टिमेशन की थी। किसी को याद है?
जी सर, संडे को किया था सर।
हाँ जी। तो स्लैब एस्टिमेशन हमने किया था, जिसमें हमने मेन बार, डिस्ट्रीब्यूशंस बार, उन चीज़ों को डिटेल से देखा था। खैर इन चीज़ों को देख लेंगे बाद में फिर भी। लेकिन ये तो परसेंटेज में अब जो चीज़ गिवन है ना, ये तो अप्रोक्सीमेशन है। मतलब हम अप्रोक्सीमेटली अब्स्ट्रैक्ट ऑफ कॉस्ट क्रिएट करते हैं। अब मजे की बात ये है, मजे की बात क्या है, यहाँ पे बीम का परसेंटेज तो गिवन है कि 2.5 है, लेकिन हमें तो ये नहीं पता कि भाई 2.5 कौन सा स्टील बार है भाई, नंबर 3 है, नंबर 4 है, क्या चीज है ये, इसका तो कोई पता नहीं ना। तो हम मकसद तो हमारा कॉस्ट है यहाँ पे। ये तो नहीं है कि एब्स्ट्रैक्ट का मटेरियल हम देखे यहाँ पे। टॉप पे मैंने क्या लिखा है, एब्स्ट्रैक्ट ऑफ कॉस्ट लिखा है ना, ये मैं जरा रेड कर दूं। तो जब अब्स्ट्रैक्ट ऑफ कास्ट की बात हो रहा है, तो इसका मतलब है हम उन चीज़ों को पे टाइम ज़ाया नहीं करेंगे। मतलब स्टील चीज़ों को कैलकुलेट कर देना, मतलब लेंथ कितना होनी चाहिए ना मेन बार का, फिर स्टेरअप्स क्या होनी चाहिए, टाइस कितने साइज का होनी चाहिए, उन चीज़ों पे टाइम वो फिर हम ज़ाया नहीं करते। समझ आ रही है आप लोगों को?
जी जी बिल्कुल बिल्कुल बिल्कुल।
तो परसेंटेज में बस यही सीन है कि आपने बस कैलकुलेट कर देना कास्ट, हमें कास्ट चाहिए इस टाइम।
ओके सर, ओके ओके, कोई बात नहीं सर, इंशाल्लाह।
तो मैं सिर्फ वो बेसिक कॉन्सेप्ट आप लोगों को समझा रहा हूँ, बाद में अगर किसी का क्वेश्चन हो तो फिर आप बेशक पूछ ले, ठीक है। रेलिंग पोस्ट के लिए फिर वही सीन है। तो हम उस फार्मूले के ड्रैग करेंगे नीचे, जो कि परसेंटेज हमारा गिवन है, ठीक है। अब परसेंटेज के अलावा सिर्फ इस चीज़ को चेंज करेंगे, जो कि रेलिंग पोस्ट का ऑलरेडी वो उन्होंने उठाया हुआ है, ठीक है। तो 25 kg का ये, देखिए 25 kg बहुत कम है, लेकिन वो ये तो एक एग्जांपल है, ठीक है। So, as you can see, we have determined everything, I guess, and now we will actually look into the costs. Okay, abstract of cost, or maybe abstract of estimated cost, and these things are actually can be covered from the MRS. I'm not gonna go to MRS again because we have discussed that thing in detail, okay, in the previous sessions, sorry. So I'll just take dollar cost, maybe unit costs, and that will be actually our work. Maybe let's say, I'm gonna say we have serial number, okay? If we have serial number, and then if we have, let's say, the work, and we will consider the quantity, very simple. And then I'm gonna say the unit, and then we may have the unit, maybe the rate, let's say, okay? And this should be actually the unit rate, okay? Unit rate means per cubic meter, per meter, okay, like that. And then we will have actually the total amount. So we have this a schedule. Now, the first thing, as you can see, we have serial number 1, and we have actually the quantity. Maybe you can say the RCC work, which is actually 17. Maybe let me just confirm that it is, as you can see, 17.8 something, blah blah blah. Okay, so I will just shortly write RCC work. No details. You can put all the details when you become quantity surveyor. Okay, you have to put all those things. Maybe providing the ratios, etc. Okay, just a minute. All right, are you guys there?
Yes, sir.
Okay, the RCC work and the quantity, if you see that is 17.8 something, okay? You can even round that, but let me just say 17.8 does not matter. And the unit, of course, that is just cubic meter. Very simple. Now the rate. The rate can be actually just determined or maybe look, okay, for in MRS, okay? You have to look that. I have already shared MRS with you in the group. And if I have not shared it yet, okay, I'll just share it with you. Okay, now you have already learned about MRS. I'm not gonna go to that in detail. Okay, now let's say if the rate for the RCC work is, maybe it can be anything in the MRS, but let me just put a video. Let's say 800 per cubic meter. Now what should be the amount? Very simple. Just multiply the rate with what? With the quantity, of course. So this is the total amount, which is very less, of course, because we have taken the rate, very low rate. Okay, it can be a huge rate in the MRS maybe. Number two, as you can see, we have the wearing coat. The rate for this can be different. And you can even write the detail description. I'm not gonna go in with detail, you can say, okay? And as you can see, the quantity that is just 4.83. So 4.83. Now the unit that is again cubic meter, okay? The rate can be actually different. Maybe let's say 750, and I'm gonna drag the formula a little bit below. And number three, we have actually steel work. Maybe you can say including fixing and something stretch. Let me just write the text so we can see it. Now, what's the quantity? The quantity is actually the total of these three. Okay, I can just sum them over here, like maybe equal, and we will actually sum all these above, like this one, okay, this one, and this one. So this is the total quantity, 2018. Now the unit that is actually in kg, okay, you can convert this into quintals, into tons. That's your work. Now let's say if the rate for the same thing, you can find it from the MRS, okay? However, but let's say if the rate is only, we're here, okay, I'll provide the local rate, which is maybe 150, okay, RS. The rate you can even just say RS in bracket over there, not in dollars. Now, what should be the quantity? Of course, we can drag the formula. It is just the same thing, multiplying these two. So the total amount, we can actually sum the above three, and this is the total RS. Okay, is there any question now?
कोई सवाल मवाल नहीं है, लेकिन इंशाल्लाह ट्राई करके उसके बाद इंशाल्लाह देखेंगे, हम प्रैक्टिस खत करेंगे उसके बाद इंशाल्लाह।
जी, प्रैक्टिस जरूरी है।
ये भी होता
क्वांटिटी सर्वे में ना प्रैक्टिस इसलिए जरूरी है क्योंकि ये फार्मूले वगैरह फिर बंदा भूल जाता है इन चीजों को। In the last session, we have done something, those were related to some analysis, and we have done a small room project. And I need to have a, you can say, heavy project, or maybe not a small project. Okay, you can say we will have heavy project, so you guys can understand everything from the basics. Okay, for that, I just need detailed drawings, and then I may need detailed specifications, and then of course, number three, we may need MRS. Okay, because these three are just very important for detailed cost estimate. But remember, before having a heavy project, we may need to learn some basic things about BBS, which is known by the bar bending schedule. Okay, so let me ask you, is there anyone who have any idea about BBS or not? You guys know about this thing or not? BBS, anyone? Is there anyone, please?
सर बार बेंडिंग स्केड्यूल में जो बार के डिटेल होते हैं जो स्ट्रीट के, वही होते हैं ना सर? उसके कट लेंथ, उसका जो वेट होता है, फिर उसकी प्राइस,
Yes,
वो सारा
exactly.
कुछ।
Yes. So bar bending schedule is actually what we do, the things, okay, you can say in a whole page, we do those things only in a table. So bar bending schedule is, you can say, just a table. Okay, it's very simple. It is like a table, and we put everything over there, like maybe description, then the length of the member, the diameter, maybe the concrete core, the extra length. Okay, so every these things, and then maybe the weight of the bar, and maybe the shape of the bar, okay, etc. So putting all these things in a table is just the same thing as BBS or bar bending schedule. That's nothing that complicated, okay? So we will cover everything related to bar bending schedule. So while performing the cost estimate of a huge or maybe long project, we may need these things, okay? So therefore, today we will have some short session about this thing. Remember, we have already covered about the slabs estimation for steel, and but before doing the BBS, let me have an example related to the beam, okay, and then maybe for a column we will switch into bar bending schedule. Now it's really important, okay? If you remember, we have done the steel calculation for a slab, okay? But that slab, it was like manual calculation. We did the let me just have a pin word here, okay? For a slab, if you guys remember, we had slab having length and width, and then there was a thickness, okay? Over there, what we did is actually we determined the bar's length, okay? The main bar's length, then we did actually the distributions or temperature bars length, okay? And based on the diameter and then the length of the bar, we actually use the formula for the weight calculation, okay, if you guys remember. So we have used two types of formulas for the length sorry, for the weight calculation, okay? But these things, okay, if you remember, we filled almost many pages, okay? However, if you do these things or calculate the steel quantity in a table, okay, that may take only one page. That's why BBS is very important. Why is BBS important? Okay, after looking into the BBS, you will have an idea about the member's steel details, okay, like maybe the cut length of the steel bar, and then the diameter of the steel bar for the same member, and so on. That's why BBS is very important. Now, I'll just have one example, okay, and then we you can say manually, and then we will have another example with BBS, so you guys can understand how we prepare BBS. But before calculating, or you can say calculating the steel quantity and BBS, it's really important you know the overall calculation. Okay, so I'm gonna take just a beam, you can say. This is a beam which is 10 feet long. This is the length. And we have some information related to the reinforcement, okay? It is 18 inches. You can say the height is just 18 inches. And there's is of course a bent up bar, okay? And we have sections. One is at mid, and there is actually one near the supports. So if you remember from the first lecture, we have talked about that drawing is really important in order to have detailed estimate. So you must be familiar with drawings. I'm not going to teach the details of the drawing, so we will directly calculate the quantities. Right, so the steel quantity and the given beam, what should be the steel quantity and the given beam? Remember, in order to calculate the weight of steel, we just need actually the length of the steel bars, okay? And the length can be actually determined from the number of the bars, okay? I mean the overall length. We have actually different types of steel. You can say the stirrups, okay, which are the rings, and then we have the main bars, which are actually the straight bars, okay? And two actually bent up bars are also included over there. So the straight main bars, those are actually 4 a number because 2 are bent off, okay? It means we have only 4. Now the total cut length for the bars can be actually the length of the beam, which is 10 feet, and at each end there are actually 90 degrees. Okay, you can see, let me just circle that so you guys can see it. As you can see, we have this hook over here, another hook, and at the right hand side you can see, okay, I have circled them with a red pen. Okay, so those are hooks, and as you can see, they are labeled as they can be actually 9D. Okay, so it means 9 times the diameter of the bar. So what we have actually, the total cut length of the bars is 10 feet, and then we will actually add extra length, or maybe the hook's length, okay, and that is actually 9D. But before that, we may subtract the concrete cover, which is not that necessary for a small project. because it does not that increase the weight of the bar. Okay. However, you can even just subtract the concrete cover. So 2 times concrete cover for one side and another side, and that is actually known. Okay, over there. Now 2 hooks just for one side and another side, they can be added. And what we have is really, this is the length of one bar. Okay, that's why we have to multiply the length of one bar with the number of bars, so we have the total calculation. Okay, or maybe you can say the total cut length for all bars. As you can see, we have 10 minus 2 times concrete cover. Concrete cover is 1 inches. That's just known. You can see it in the sections. Okay, we're here. And then we add 2 hooks. You can say 2 times 90. Okay, now 9, that is just a digit. D, that is 6 by 8 inches. Okay, the diameter of the main bars, that's known. Okay, and that is number 6. It means 6 by 8 inches. Okay, you can see it. We're here. All right, and then we will multiply that with the number of bars, which are 4, if you see in this section. Okay, I'm not talking about the total number of bars because there are 2 bent up. Okay, I'm just talking about the straight main bars. Now do some maths. You can get actually 43.83 feet. Okay, is the length for the 4 bars. Okay, it was very simple. Now the steel for the bent up bars. Bent up bars are only 2. And the length calculation can be actually something little bit different because we have bends over there. Okay, 2 bends, and that is actually at 45 degrees. So let's have another page. As you can see, I'm going to draw the same section again, so we can have some details over here. Okay, as you can see, what do you mean by the L by 4? L by 4 means the bend is just starting, okay, at distance L by 4 from the support. That's very simple. Okay, as you can see, we can start the bend. Okay, when we cover L by 4 length of the beam, and then of course the bend can be started. The B, that can be something, the length of the bend length over there, that can be actually something, so we have to calculate that. Now actually L can be determined using some trigonometric ratios. Okay, you can consider that triangle which has 45 degrees is the in angle, you can say. Let me just erase these lines so we can see it clearly. So what should be that length? I mean this length for the bent up bar, that can be actually h by sine 45. Okay, I'm not gonna go into the trigonometric ratios in detail because you guys should be familiar with this, and we have already discussed it before. So h by sine 45, h, that is known, 16 inches. And how 16 inches? Of course, we have subtracted 2 times concrete cover, okay, for the height, and the total height is 18 inches. So subtracting 2 inches is concrete cover for one side and another side, that can be actually then 16 inches is the effective. You can call it effective height, doesn't matter. So h, that is known, which is 16 inches, and we will divide that by sine 45, so we can have actually 22.627 inches. Very simple. Okay, and that's actually the length. It means now we can calculate the L by 4, and then we can add all these together, so we can have actually the bent up bars length. Okay, it's very simple. Now what should be L by 4? As you can see, we have the length is 10 feet and divided by 4, so we can have 2.5. We can put those values over there. Okay, very simple. Now what should be Y? This is actually the distance of the bar. Okay, you can say the distance of the bar between 2 bends, and that Y can be actually, if we just take 10 feet, okay, and then we actually subtract the L by 4 for one side and another side, which is 2 times 2.5. Okay, that's just been calculated. And then actually, of course, we will just subtract 2 times 16 inches because this is the base of the right angle triangle. Okay, very simple. And that's gonna be Y, which is 2.34. Very simple. Now, what should be the cut length for the bar? That's very simple. Okay, we have to just add all these things. You can say L by 4. Okay, and then this Y, and of course these lengths, which is 22, and then of course L by 4 for the right hand side. Very simple. So adding all these things, we can have actually the cut length of a bar, and that should be, of course, 23.347. Very simple. As you can see, we have actually the cut length for the bent up bar and we have the cut length for the straight bar. So we can, of course, just determine their weights. Okay, very simple. And of course, that length was just for the one bar. And of course, we have two bars. So the total cut length can be 43. And that is actually for the main bar. So just straight, you can see. Now, what should be their, weights? What should be their weights? It's going to be very simple. Okay, we're going to put all these things in that formula. If you remember the formula, like maybe d square by 52.9 times L. Are you guys there?
Yes, sir.
Yes, sir.
Now I'm adding the total cut length because the bars diameter for the bent bar and then for the straight bars, that is just the same thing. Okay, so we have 43 and then we have 23. Okay, so we can add them. So 67 feet and just put this video in the same formula for the weight. So we can have, of course, the weight for the same bar, which is 48. And this should be actually 48 kg. It means we should demand 48 kgs of number 6 bar for the same beam. And I'm not discussing this formula again and again because we have already covered this. Okay, just moving ahead. Now, as you can see, we can actually calculate these stirrups. The rings are just known by the stirrups. Okay, and the stirrups calculation is just very simple and straightforward because this is just a rectangle. So it means the stirrup calculation, we can just add the ring or maybe the stirrups parameter, and that's going to be very simple. Now, the parameter of the rectangular portion, and then we can add actually 9D hooks. Okay, these 9D's hook can be actually 2 times. Okay, it can even be 1 time, like maybe 4.5 for the one hook and 4.5 for the another one. It means 9D can be taken for both. So it means the parameter of the rectangle can now be actually, if we subtract 2 times concrete cover for one side and another side from 12, this can be actually the base. Okay, you can see this base. And even I can start from the height, okay, 18 inches. I'm going to subtract 2 times concrete cover from one side and another side. And that's going to be actually this height, okay. If you see the red marker, this can be this height. Because we actually have the height of the stirrup is this, which is shown just in the red arrows. You can see that. Okay, that's why I'm going to subtract 2 times concrete cover for the top, which is this portion, and for the bottom, which is this portion. Now, next, we have actually 2 times because we have 2 sides of the rectangle. Now, we will take 12 inches and again subtracting 2 times concrete cover for one side and the other side. So we can have actually that portion, which is the side of the stirrup, you can say. And I'm going to multiply this with 2 because we have 2 sides, okay, top and bottom. Now, plus 9D. Now, D, that is number 4. As you can see, this is, number 3. It means 3 by 8 inches. And 9D means just 9 times the diameter of the bar. The diameter of the bar is just 3 by 8 inches. Just do some mathematics with this. We can get actually 32 inches plus 20 inches plus 3.375. Okay. And this is 55 inches is the total one. It's really important to remind the number of these stirrups because this is the length of one stirrup bar. Very simple. We need actually the number of stirrups. Okay, the numbers calculation for stirrup can be different. It may depend, and actually there can be different spacings between the bars. Okay, as you can see, we have 6.3 inches. You can see it over here. Is the spacing between those bars which are near the supports, okay, 12 inches which is at mid span, and 6.3 inches, okay, which are actually at another end of the beam. We have actually calculated the stirrups length in feet. That's why we have just divided that by 12, okay, and that can be then 4.6 feet. Very simple. Let's just determine the cut length of one stirrup, and that's just 4.6. Now, the total length for our stirrups, we actually need the number of stirrups, okay? And that's 14. You can count them from the long section. The long section must be given, okay? And you can just study that from the structural drawings, okay? So you can just count the number of stirrups. The total length for the all stirrups can be 64.6 inches because we have multiplied the 2 things. Now the weights calculation, you can use that old formula. So we can have 11 kg. And here is the final result. Number 6 bar, we can demand 48 kgs. And number 3 bar, we can demand actually 11 kgs. Is there any question?
No, sir.
Next, let me have an example. So we can do this calculation in a table, okay? I'm gonna have actually maybe a footing, okay? A footing plus column. And let me just draw the diagram. As you can see, the diagram or maybe the structural drawing may look the same thing as I'm just drawing. You can see, okay? Main bars, there are ties, okay? Now, ties are just the same thing as stirrups, but this terminology is just used for the rings which are being used in column, okay? And stirrup word or maybe the stirrup terminology is used for the rings which are being used only in beams, okay? So never be confused with the tie and then stirrup. So we have this drawing, and as you can see, we are asked to determine the quantity of the steel, okay? It means the BBS may be just formed, and we will calculate the quantity of steel in a BBS, okay? Now, if you remember, bar bending schedule, it is just the same thing as a table. So I'm gonna draw a table first. And in the table, we may have different parameters such as the serial number, then there can be description, okay, there can be actually the length of the member, there can be the concrete core, there can be extra length, okay, and so on. And the BBS is actually never static, it is dynamic. The number of columns may change. If you need extra information, you can increase the number of columns. That's very simple. We may have the number of bars, we may have the total length, and then the weight. There can be another column for the shape, okay, and so on. Now, in the description, let's say if we have to determine the bars, okay, which are actually at the base, okay, and that is 16 mm at the rate 15 inches center to center. Now, the overall length that is known, which is actually 1 meter or maybe 100 centimeters. That's just shown, as you can see in the same drawing. It's over there. Now, the cover, that is known, which is actually 5 centimeters cover, okay? But we will actually subtract 2 times concrete cover from one side and another side. That's why I have put minus 10 centimeters. Now, the extra length, if there is any hook, if there is any overlap, maybe double bars, okay, you can just add them with the length of 1 bar. So extra length, there is no extra length because it is just 1 meter, okay? We cannot provide overlaps over there, and actually, of course, hooks are not given in the same section. You can see the section, there is no hook, okay, for the main bars or maybe distributions bar which are at the base. All right, now the cut length of 1 bar, this is very important. We will take the total length and we will actually subtract the concrete cover from one side and another side. The total length, that is 100 centimeters, and concrete cover is 5 centimeters. It means 100 minus concrete cover for one side, which is 5 centimeter, and for another side, which is 5 centimeters. So we can have actually 90 centimeters. We have the number of bars. If you remember from the previous session, okay, we have done that for a slab maybe. We have taken the length and then divided that by the center to center, and an extra bar can be added. So the number of bars can be 90 and divide that by 15, which is center to center. It is just, if we see, that's given in the same diagram. And of course, we add extra bar, which is 1. Now, never ask me why 1, because we have discussed all these things in the previous sessions. Now, the number of bars can be actually 7. That's very simple. 7 times 2, because we have 2 directional bars. As you can see, we have 16 mm at the rate 15 centimeters center to center, but both ways. That's why we have multiplied that with 2. Now, the total length can be actually the length of 1 bar, okay, times the number of bars. Are you guys hearing me? Because my internet connection is a little bit unstable.
Yes, sir.
So the total length can be now actually the length of 1, which is 90, and we will multiply that with the number of bars, okay? As you can see, cut length of 1 is 90, and the number of bars are 14. So we have the total length, which is 1260, okay? Now the weights calculation is just the same process. You can do that. It's gonna be very simple, okay? But I'm not gonna calculate the weight now. The vertical main bars, which are actually 4 in number, and those are 16 mm diameter. That's just shown over here. As you can see, we have 16 mm dia, and those are 4 in number. Okay, if you draw a section, like maybe just a section, they may look the same way like this. Okay, here are 4 bars. So the overall length that can be 432.5, and you can just calculate that because in a rough page you can say 25, which is also just actually the height of the footing. Let me just circle that so you guys can see it. Okay, that one, 25 centimeters. And then we have actually 30 centimeters, which is this height. Okay, you can say below the ground level. Then we have 60 centimeters, and then of course 3 meters or maybe 300 centimeters. And this 15 is actually the same thing is this 15, which is actually the mat's height. Okay, you can say that concrete. Now 15D hook can be added for one side and another side. And this is actually the extra length. That hook can be added for the top, which is 2.5. And 2.5 is actually just the diameter of the bar, which is, you can say 16 mm and times 15. So 16 times 15 can be something, mm, you can divide that by 10 to have that in centimeters, okay? And we can have actually the total is 432.5 centimeters, okay? Very simple. Now, we can put the cover is -5 because that's just known already, okay? In the diagram, you can see that. And the extra length that is 48. Why 48? Because we have actually 15D plus 15D for one side and another side. Okay, I mean for the top and bottom. And that is just the same thing is 48. So we can just put extra length, okay? And however, for the base, there we had no extra length, okay? This time we have extra length because we are providing hooks, right? And that is 15D. Now the cut length can be actually something which is 472. And how this comes actually, we have just added the, you can say 432.5 with the hook's length. That's very simple. We can just have the total length, and that can be now actually the cut length of 1 bar times the number of bars. That's going to be very simple. The number of bars are 4. You can just count them from the section again and again. As you can see, that's just over there. And the length of 1 bar, that is just known, which is 472.3. And times 4, we can have actually 1889.2. What we have is actually the total because we have the same diameter for the bars in the base and bars in the, you can say the longitudinal bars, okay? So that's 3149.2 centimeters. You have added them. It means you can even calculate their weight just by simple formula, okay? And that is 49.7 kg. How 49.7 kg? It's the same formula. You have to just only have some footings, okay, and that formula, which is actually like d square by 162.198 times the length, okay? What and that's just calculated, okay? I'm just skipping this because it's just time wastage. Now ties, or maybe you can call them with rings, okay? So ties and rings, these are actually the same thing. And if you remember, ties are just only used is term for the vertical members, okay? Now the overall length, what should be the overall length for the ties? The cut length of 1 bar, that is 66. How 66? As you can see, we have the square, you can say the column is square. It means the tie can be square. As you can see, this is 20 times 20 centimeters. And there is actually 10D hooks this time, okay? In the previous example, we had 9D. So it means calculation for the same cut length or maybe the tie's length can be very simple, like maybe the perimeter of the ring plus hooks. Now the perimeter of the ring can be different thing, like maybe we will subtract concrete core for one side and another side, and that is 5. Now I'm just multiplying this with 4 because we have 4 sides of the square. And that's going to be actually very simple, which is the length of the tie, and that is 60 plus 6, which is 66 centimeter. Study this thing in detail, and if there is any question, you can ask me in comment section, okay? I'm skipping multiple things, okay, because we don't have much time. Now, as you can see, the length that is just known, the cut length of 1, which is 66. Now the number of bars, it means the number of ties, that is 23. How 23? It's also very simple, okay? What you have to do is actually divide the height of the column, or maybe the length of the column from the base till the slab, okay, by the center to center distance of the ties. And the center to center distance, that's just known, which is 20 centimeters. You can see that in the diagram. We have actually the height. It is the same thing as the length of the main bar. But however, we may subtract the hooks for the top and bottom, okay? And then divide that by the center to center of the tie. And however, we can add one extra ring for the top, maybe, or maybe for the bottom. The number of ties can be actually the length of the main bar, which is already calculated a few seconds ago, and divided by the center to center, which is 20 centimeters plus 1. And we have actually the number of ties, which is 23. So we can put that value over here. You can see that it's already been over there, right? Now next, what we have to do is actually to calculate the total length, and that is 66, which is actually the length of one bar, times 23, which is the number of ties, okay? So we have 15, 18 centimeters, okay? And the weight can be calculated using that old formula. Very simple. So the weight can be 3.5 kgs. I'm not gonna do this, the weight calculation, because that's very simple. So the final results are 16 mm bars can be demanded is 50 kgs, and 6 mm bars can be demanded is 3.5 kgs for the same column and footing. Now ask me if there is any question. All right, now it's also important if you see, if the project is heavy project, we actually may need to determine the binding wires. However, for a small project, let's say if this is only a column, then the binding wire for this can be very little thing, okay, maybe 1 kg or maybe 2 kg, okay, maybe less than that, okay? So it's never necessary. You can just demand it maybe like lump sum, okay? However, if the project is heavy, then you have to determine the quantity of binding wire as well. And remember, binding wires, these are actually small, you can say, are bars with very small diameter, okay? And they are just used, you can say, to bind reinforcement with each other together, okay? So while placing the concrete, and that may not result in any moment, okay? So the reinforcement just actually stay on the place. Now, the quantity of binding wire may depend actually on the structure type, the type of the bar, okay? I mean the type of, by type of the bar, I mean the diameter of the bar, okay? If the structure is heavy, then the quantity of binding wire can be, you can say, maximum, or maybe you can say the quantity of binding wire may increase if the structure is just actually heavy. And if the bar's diameter is actually more, then the quantity may decrease, because with a huge diameter, the bar may stay on the place and there may not be any requirement of the binding wire. So it actually depends on these two parameters, okay? Now, let's just have an example so we can understand the calculation process for the binding wire. And of course, there is no specific calculation. I mean, there is no formula. There is no some rules, okay, to calculate the binding wire, okay? And that's why we actually may depend on the past experiences. Like maybe if there is any project you have done, okay, you have to look into this project binding wire utilization, okay? Let's say in the previous project, if the cover area for the same project is 100 SFT, and you have used, let's say, 20 kgs of binding wire. It means for the next project, if the project is just 200 SFT, then you may require actually 40 kgs of binding wire. So this is called the basic thing for the binding wire, which is actually a thumb rule maybe, and depends on the past experiences, okay? So even there is some thumb rule, you can say, and let me just show it over here, okay? So according to some thumb rules is actually you may need 9 to 13 kgs of binding wire. For how much work? For 1000 kg work, or maybe 1 ton. Okay, 1000 kg, that is just 1 ton, okay? However, this thing can be actually different if the bar's diameter is little bit different from the maybe just a minute, from 8 mm to 28 mm. Okay, so if your project contains these types of bars, maybe from 8 mm to 28 mm, and if your project is 1000 kgs, okay, then you may require 9 to 13 kgs of binding wire. And this thing, let's say if your project is actually just from 28 mm to 32 mm, then you may need actually 7 to 13 kg of binding wire. Okay, and for how much work? Actually for 1000 kg work. So this is just the basic concept. Now what if the diameter of the bars are just increasing, okay, or maybe more from 32 kg, then you may, 32 mm, okay, the diameter, I mean, is just increasing from 32 mm, then there is no need to bind the reinforcement. Okay, you may need actually what do we call that? Actually, the weld. Okay, then there can be actually the requirement of weld. So let's just have an example so we can understand this problem better. And in the example, I'll take some you can say parameters for the same example. And let's say if we are asked to calculate the binding wire required for 80,000 kg of steel reinforcement. It means, let's say if we have a huge project where we have already determined the main bars, okay, maybe for the beams, for the slab, for everything, okay, and their summation is actually 80 kgs. Now, how much binding wire do we require for the same project? You have to remember actually that thumb rule, okay, in order to calculate the binding wire for the same project. And that thumb rule, okay, you can see it. This screenshot is just available, okay. Now, the average value actually is 11 kg per 1000 kg of the work, because 9 to 13 kgs, if you take average of 9 and 13, okay, that can be maybe 11. It means 11 kgs per 1000 kg. Now, the total requirement of the binding wire can be now, we can say 11 kgs, and we will divide that by 1000. And then let's multiply this with the total work, which is 80,000. So we can have the quantity of binding wire, which is actually kg may cross each other, and there we may have, you can say, 880 kg, okay, is the binding wire. Very simple. So this is how actually we calculate the binding wires quantity. Now next, I'm gonna have another example. If you remember previously, we have done an example about the slabs estimation. You can say the quantity of steel for a rectangular slab, okay? But rectangular slab, that's very easy. What if we face some slabs which are actually different, and they are, let's say, not rectangular, not square, okay? Then actually we may need some complex calculation over there. That's why let's just have an example for a slab, which is, you can say, let's say circular, maybe polygonal, okay? So how do you calculate then the steel quantity for that slab? Okay, let's say if we have a slab, maybe like this one, how do we actually distribute the rebars? It can be the same way as this one, okay? Let's say these are the main bars, okay? And the distributions are maybe the temperature bars can be in this direction. If you see, the bars are actually the length of the bars, they are just decreasing. As you can see, let's say if you take the bars at middle portion, their length is actually more, okay, or maximum. However, this bar's length, this is actually less with respect to the bars which are at the middle portion. So it means when you are just actually leading, or maybe you are looking to the bars which are at edge, okay, their length is just less. However, if you look to the bars which are maybe at middle, or maybe at you can say near to the bars, you can say to the center of the slab, those are actually more, okay, in length. The length of their those bars is actually little bit more. What should be the length of these bars, okay, which are at middle, and what should be the length of the bars which are at edges, you can say. And I'm gonna have just an example so you guys can understand the problem better. Okay, let's just have an example where we have a slab, and I'm gonna say, let's say the slab's diameter. I'm gonna just draw a slab. Let me just have that, okay, little bit. Let's say it is a slab like this. The diameter of the slab, let's say that is just 2 meters. Okay, it is the same thing like maybe a slab for water tank or maybe a slab for the manhole, no problem. And now let's say if the bars, okay, are just running the same way like this. Okay, there are bars like this. And let's say these are the main bars, and the main bars are, let's say they are 13 mm, 10 centimeters center to center. What we have actually, let's say this, I'm going to call the central bar is L1, or maybe the length of the central bar is L1. And let's say this is L2, we have L3, L4, and so on. Okay, it's just going, or you can say the length is just decreasing. And it is also a question, how much and when do we actually recognize the length is the last length? Okay, or maybe the bar's length is the last bar length. So actually, just calculate the length of each bar, maybe L1, L2, L3, L4, and so on, okay? And when you reach to the video is 0, okay, let's say there is Ln, okay, and that length is, let's say, 0, then it means you have just completed that thing, okay? And even, you can even recognize if the length becomes minus, okay, in minus terms, you can say. So, okay, you will understand it after the example. And now, as you can see, I'm just going to calculate the length, okay? And even, as you can see, L1 can be just the diameter of the bar, which is actually 2 meters, because this is at the middle portion. However, L2 that can be little bit less than L1. And then L3 can be little bit less than L2, and so on. Now, there is a basic formula, which is a Pythagoras theorem, if you guys remember it. So we will calculate the length by r square minus h square. Okay, this is Pythagoras theorem, maybe for the half bar's length. Now, as you can see, we have two sides. It means we can multiply this formula with 2 to have the total length. Now, in order to determine L2, okay, we're here. Let me just say, as you can see, the radius can be just the same for each L, okay? However, the H may be different for every bar, because I'm going to say for L2, the H can be H1. For, you can say, L3, I'm going to write the formula in this form, like maybe r square minus H2 square. For L4, the formula may be just like in this form, r square minus H3 square, and so on. Let me just have some puttings over here, okay? So you guys can understand it better. Now, let me just make it a little bit more clear, okay? Now, what do you mean by H1? It is actually the distance between L1 and L2, okay? This is called H1. Now, H2, that is actually the distance between L1 and L3, and so on. Then H3, that is actually the distance between L1 and L4. I'm going to erase these red work. So let me just put values in the same formula. 2 times R is just the same thing as 1, because the diameter is just 2 meters. You can see that. So it means 1 square, because R is actually half of the diameter. R can be actually D by 2. Now D is actually just 2. So 2 by 2 becomes actually 1. So 1 square minus H1. Now H1, remember, that is just the distance between L1 and L2. This is actually H1. And as you can see, the center to center, that is just known, which is 10 centimeters. Or you can say 0.10, okay, meters. So 0.10 square. And if you just calculate this by calculator, you may have the value is 1.99 blah 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 something, okay, meters. So it is just little bit less than L1. Now I'm gonna calculate L3. Very simple, okay? And for that, I'm gonna erase these things. Just a minute, okay? And let's just put values in the same formula again. And this time for L3, okay? So L3 means 2 times R is just 1 square minus this time for L3, we may have H2. And H2, remember, there is just the distance between L1 and L3. This is going to be H2. So it means the center to center, which is 10 centimeter, okay, and 10 centimeters. So that's just 20. So it means 0.20, and there is actually square. Now, just have some mathematics with this formula. You can just calculate the length of the same bar. That can be actually 1.96, okay, L3. That can be 1.96. Look, that is just decreasing, okay, 1.96. Okay, and just apply the same formula, then you may have L4 is actually 1.91 and so on. The distance may actually become 0.87, maybe less than that, okay? So if you have the same, let's say this one, now the central one is just 2 meters, then we have actually, let's say 2 meters, this is 1.99, this one is 1.96, okay, another one that is 1.91, another one that is 1.83, and so on, okay, blah, 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 okay. At the end, you may have 0.87, okay, and this is actually for the top portion, I mean for the top half slab, and for the bottom, it can be the same values, okay? And then if you just determine the same thing for the distributions bar, you can apply the same formula, but in the, as you can see, the direction is only different. This is how we can actually calculate the cut length for each bar. Now you have to add all these cut lengths, okay? You may have the length, I mean the overall length, and then just put that length in the same formula, d square by 162 times L, to have the weight of the bars.
Yes, sir. Sir, I actually said that सर अगर हम देख लें कि L1 की हाइट H1 है, L2 की H2 है, तो एक्चुअली हम ये हाइट कैसे मालूम करेंगे जब हम प्रैक्टिकली कोई काम कर, तो हाइट कैसे मालूम करेंगे उसको?
ओके, ये तो ड्राइंग में तो आपको स्पेसिफिकेशन से मालूम होगा कि ये नंबर लेट से नंबर 13 बार है एट द रेट कोई भी लेट से 6 इंचेस सेंटर टू सेंटर है, इस तरह का कोई इंफॉर्मेशन
अच्छा
तो
अच्छा सर,
गिवन है
ठीक
ना?
है, तो जो सेंटर टू सेंटर डिस्टेंस है उससे हमें हाइट मालूम होगी।
एग्जैक्टली, तो अब देखे ना L1 और L2 के दरमियान क्या है, 6 इंचेस का डिस्टेंस है ना?
ठीक है सर।
अच्छा,
फिर वो 12 इंच का हो जाएगा इसी
तो
तरह।
ये क्या हो गया, H1 हो गया, ठीक है। अब
यस सर, फिर ठीक है, फिर क्लियर है सर।
अच्छा, H2 हमारा 12 इंचेस हो जाएगा,
ठीक है सर, क्लियर है फिर, थैंक
यू। सिमिलरली इतना काफी है या फिर ट्राइंगुलर स्लैब का भी थोड़ा एग्जांपल देख लेते?
सर काफी आज के लिए।
Okay, so we will actually start a project, okay, tomorrow. We may, and that project can take actually few days. After completing that project, that will be actually the end of the course, okay? So attending the project can be very beneficial for everybody, because we will start from the excavation till the top roof, okay? And then we will have the analysis, and of course we will determine the cost of the same project from the MRS. So if there is any
the course is just for the building construction, or it is also belong to the road constructions?
It also actually belongs to the road construction, but we have already done that, the things related to road. Have you taken those classes?
No sir, actually I am busy on those days, that's why.
Maybe the fourth and maybe the fifth class, it was related to the road estimation.
सर वो अपलोड हो गए ना YouTube पर?
I guess not yet. That may take a few days because due to Ramadan, it's really complicated to edit all these
Yes, sir.
videos.
Due to Ramadan, our duty timing is changes. That's why I'm not able to attend those classes.
Okay, okay. Whenever I upload that, I send actually the link in the WhatsApp group.
Okay, sir.
Okay, laugh is. So what we have over here is just a small project, which is 25 by 32 feet. Okay, this is the total area, and having two bedrooms, then the kitchen, bathroom, staircase, lounge, and then some small veranda. You can see that. Okay, we have the columns foundation, the walls foundation, plan of the slab, of course, some legends for the doors, windows, and ventilation, and this is the front elevation. Okay, and let's say we are asked to estimate the abstract of materials and then, of course, the abstract of cost from the MRS. Of course, we will use the latest MRS, maybe the MRS of 2023 or 24 if that is available. And of course, there can be the hike in prices, maybe depreciation, okay, in the prices or in the video maybe. So we will consider that and we will have some percentage for that, does not matter. And we will complete this in the Excel. You guys can see the Excel, okay? Please confirm if you guys can see the screen.
जी सर नजर आ रहा है.
Okay. So we have the length, then the width, and then the height. And then of course we will have the quantity and then unit and then remass. Okay, so this is the same table we always use. And of course, let's just get started. And now the thing which is really important, if you guys remember, we have already done a small project, okay, a one-room project. If you guys remember, we had two types of walls were there, like maybe the long wall and then the short walls, okay? And for the estimation purposes, let me just turn off the furniture and some other stuff so we can see the things, okay? So let me just turn off some layers and maybe the dots and let's say another things such as decks. Okay, I'm just gonna, I think it's good now. And let's just turn off the symmetry as well. Okay, we have symmetry over here. We have text. Okay, that's already turned off. Tiling, I'm gonna remove that. And then maybe some other things such as dimension. That's okay. I'm not gonna remove that. Okay, we have these things. Now, the thing which I'm gonna do is actually to name some long walls and short walls. There can be different types of long walls and short walls over here, okay? I mean in number. Let me just say if we have the green color and let me have a rectangle. Let's say if this is the long wall, okay? Then of course we have few long walls. If I can say if this is the long wall because it is the same length with the top one. And even if I consider this portion plus you can say this portion and this can become a long wall as well because these two becomes one wall which is the same length as this one, okay? So now here as you can see this can be short wall, this can be short wall, okay? And I have already separated these things, so I'm gonna remove that, okay? Now you as a quantity surveyor you may have this drawing in hard copies, okay? You have to label them with different pens so it can be easy for you. As you can see I have made some layers for that, like maybe let's say the short walls, okay? I have turned these things as the short walls. You can see the red, and of course for the long wall we have this green color. So long walls are 4. As you can see, I have called or named the horizontal directions wall is long walls, and the vertical those are is short walls. You can use any strategy. That's your work, does not matter, okay? And even I have labeled some things for the easiness. As you can see, we have long wall 1, okay? And I have written over there 3 in number. It means long walls are 3, okay? In the same length, you can say. And this is 1, where here we have that 2, and this one is 3, okay? And this is actually long wall 2, and it is only 1 in number because its length is different. So I have called this is long wall 2. Now, you may have multiple long walls. You can continue this thing like maybe long wall 3, long wall 4, okay? If the lengths are different. Now, as you can see, if I just delete this thing, over here we do not have a wall, okay? But the thing which is actually, if you see, this is also a wall. So I have included this with this. Over here, this is a wall. So it means combination of this element and over here, that one, that becomes a long wall, okay, which is equal to actually these two. So it means this is also included in the long wall. Let's just jump into the Excel. And the first thing, as you can see, in serial number 1, I'll be just calculating excavation. Now, description can be written from the specifications, but this time I'm gonna have only excavation. You can include multiple details, okay, in this column. Now, a number, I'm not gonna write something over there because we have, let's say, long walls, and then we have short walls. But long walls, as you can see, we have long wall, you can say 1, and then we have long wall 2, because over there we have different types of long walls, okay? That is long wall 1, and over here we have long wall 2. Now, long wall 1, that is 3 in number. Okay, you can count, that does not matter. So long wall 1, that is actually 3. Long wall 2, that is actually 1 in number. Now we have to put their lengths, and that's very important, okay? But for the lengths, we will actually jump into the same AutoCAD. As you can see, this is the wall's foundation. And the length, as you can see, this is 25 feet and 3.5 inches. Okay, this is the total length of the wall. But the excavation length can be different. It can be actually, we will add that length, and we will have actually, we will subtract the thickness of the wall from the foundation width. Okay, and then we will add the same thing at the difference with the length of the wall. And how it can become actually something like, maybe we will have, that is 3 feet, we will subtract the thickness of the wall, which is 9 inches, like, let me say, in the remarks, okay? So I will say the length can be 3 inches, 3 feet. We will subtract the thickness of the wall, which is 0.75. We have already done these things, okay? So never be confused with this, okay? And then, of course, we will add the length of the wall, which is, I think, 25 feet and 3.5 inches. So 3.5 inches, that can be converted into feet, does not matter. If I can say, if you divide that by 12, that is become actually 0.29, okay? Plus 25, that actually becomes 25.29. So we can say 25.29. So it can become the length of the foundation, you can say, for the wall 1 or long wall 1, okay? And that can be nothing actually. Let's say it should be 27.79. That's clear. So I'm gonna write that thing over here, 27.79. Why do we actually increase the length of the foundation? Let's say if this is the straight wall, okay? Now this is 10 feet in length. And let's say if we have the foundation, like maybe we have different steps, and I'm gonna have 6 inches, okay? Let's say we have 2 steps. This represents actually something which is, let me just make different color for that so you guys can see it. This is red, okay? Now this external is actually the length of the foundation. However, the wall is just this green. Now we have to actually increase the length. Wait a minute. If you guys can see, this is actually the wall length, that is 10 feet only. But we will actually increase that, okay, for that step, which is 6 inches. And we have another step, which is 6 inches. It means 1 feet for one side can be increased the length of the wall, and then 1 feet for the other side. Is it clear? So it means 2 feet should be added for the foundation length. And if you see, as you can see, we have actually, this is the, you can say, the weight of the foundation, which, if I'm not wrong, is actually something like 2 feet and 9 inches. What we do actually, we subtract the wall thickness from the foundation weight, okay? Now, if you subtract 9 inches from this weight, it becomes 2 feet only. And then, of course, then we add the length of the wall. So 2 feet plus 10 feet, it becomes 12 feet. Okay, and of course the length of the foundation is 12 feet. If you see, okay, let me just confirm it. As you can see, this is 12 feet. So this is actually the basic concept. The length of the foundation can be little bit more from the length of the actual wall. Now, what should be the width? As you can see, it's already known, which is 3 feet. So I'm gonna put 3 over there, okay, is the breadth. The height of the foundation, that can be just, as you can see, we have the ground level over here. And what we do, we excavate below the ground level. So 9 inches plus 6 inches plus 9 inches. That becomes actually 24 or maybe 2 feet. Now we have the quantity, which is actually the product of this thing, which is height, then the breadth, then the length, and then the number, and press enter. So we have 500.22 CFT is the foundation work. Now for the long wall 2, we have to actually look for the length of the wall. So for the same thing, the length can be now actually, like if I say the length is actually something, okay, let's say the length, that can be the length of the wall, which is 13.125. Okay, and we will actually add with this something which is actually the thickness of the wall. We will subtract the thickness of the, or the weight of the foundation. We will subtract the thickness of the wall, which is 0.75. So this is going to be something which is actually the length of the foundation for the same wall. So 13.125 plus actually 3 minus 0.75, that becomes something which is 15.375. Okay, 15.735. This is in remarks. You can write that over here. Okay, 375. So this is the length of the long wall 2. You can put that over here, 375. Now the weight of foundation is just the same for both. And we will drag the formula below so we can have the quantity. So we are done with the long wall. Now we will have calculation for the short wall. And the short walls are actually different in number. You can say we have short wall 1, and these are 3. Okay, like 1, 2, and 3. And then we have short wall 2, and these are 2 in number, like this one, maybe, and over here, this one. And then we have short wall 4, which is only 1 over here, this one. And then, of course, we have short wall 3, which are 2 in number, this one and this one. So we have up to 4 short walls. So it means let's calculate excavation for the short walls. And as you can see, we have short wall 1, and then we have short wall 2, and then short wall 3, and then the fourth one, of course, short wall 4. Very simple. Now we have to confirm the numbers. Okay, short wall 1, that is actually 3 in number. So we will have 3 over here. Short wall 2, they are actually 2 in number. So putting 2 over here. And then short wall 3, they are 2 in number. Okay, short wall 3 is 2 in number, and 4 is 1 in number. Now we will have their lengths for the foundation. Okay, so the lengths, and we will actually follow the same process, but this time we will subtract that from the length of the wall. Okay, I mean the foundation. If you determine the length of the foundation, okay, this time, as you can see, we have a plus sign over here. However, for the short walls, we will subtract, okay, this difference. Very simple. Now, the length will be calculated, and let's just see it, how it works, okay? And we will have actually some annotation, okay? And these can be given in drawings. As you can see, this is the short wall 1, and the length of short wall, let's just see, this is actually the length, which is 11 feet and 3 inches. Now, how do we calculate the length for the short wall 1? And we will have actually, let's just say if we have some text, so you guys can clearly just learn about this thing, okay? Let me just switch on the text so you guys can see it. If I just have some copy over here, now the length of the short wall foundation actually, and that can be actually something like, if I have, just making sure that you guys can understand it better. And we will just not explain these things again and again, okay? I'm just gonna explain this only for one wall, okay? The length of the short wall 1, okay, that is 11 feet and 3 inches, okay? As you can see over here, I'm gonna have 11 feet and 3 inches. 3 inches means 0.25. Now, we will actually subtract the difference of the foundation's width and the wall width. And we can say like maybe minus, we will have the width of foundation, which is 3 feet, and we will actually subtract the width of the wall, which is 0.75. So this is going to be the foundation length for the short wall 1. And you can just calculate it very simple, like maybe 11.25. You have to subtract 3 minus 0.75. But remember, for the long wall, it was just like addition over here, okay? Okay, this becomes actually 9. So for the short wall 1, the length of foundation can be 9. Okay, their weight is just the same thing, like maybe 3, and the foundation height, that is actually 2. Okay, now how 9 becomes, so I'm gonna write that in the description. Like maybe we have the length of the wall, which is 11.25, if you guys remember that. Okay, and we have subtracted actually the weight of the foundation and minus 0.75, which is the thickness or weight of the wall. I'm not gonna repeat all these things for the remaining walls, okay? Now we have only one thing which is remaining, short wall 4, and let's just see if its length is, okay, that is 5 feet and 7.5 inches. So 7.5 inches, that is almost, if you divide that by 12, that becomes 0.625, okay? So foundation length can be like maybe you can say 5.625, which is the actual length of the wall, and we will subtract the same thing like 3 minus 0.75. Very simple, okay? 3 minus 0.75, that becomes actually 3.375, okay? So equal, and we have actually 3.375. So this is the length of the foundation, 3.375. Okay, now the weight is just the same, the height is just the same, the quantity will be, you can say the formula can be applied, and that is in CFT. Okay, okay, so this is actually the foundation, you can say the excavation, and I'm gonna write something over here like maybe total excavation. However, we have not yet calculated the columns foundation, so let's just do that. Okay, let me just say columns foundation. So for the column excavation, let's see, as you can see, we have the column, which is actually 3 by 3. You can say the columns footing. Okay, so it means that is only one n number, and that is 3 by 3. Okay, and the height, let's see, we have actually, as you can see, this is the ground level, and we have 1 feet and 6 inches, and then 6 inches. Okay, so it means that becomes 2 feet, and that is actually the same thing. So we're gonna drag the formula, and of course the CFT over here. So we have this is the total excavation now. Yes.
सर ये कॉलम की एक्सकेवेशन जो आपने ऐड की इसमें, तो वो दूसरे एक्सकेवेशन में नहीं लग सकते सर ये कॉलम, क्योंकि इसका तो अगर हाइट देखे तो हाइट भी सेम है, ऐसा नहीं है कि हाइट ज्यादा है, इसका एक्सकेवेशन थोड़ा सा ज्यादा है।
और सिगरेट तो रखा हुआ ही है, हमने ऑलरेडी देखे, यहाँ पे हमने डिस्क्रिप्शन में लिखा है ना कि कॉलम एक्सकेवेशन है ये 18 CFT।
जी सर, समझ गया।
तो अब इसको सम करेंगे हम, ठीक है, ये जितना भी ओके। सो नाउ वी हैव, एज यू कैन सी, वी हैव कैलकुलेटेड ऑल द एक्सकेवेशंस। नाउ लेट्स जस्ट auto sum them. Okay, we're here from this summation. So we have 961 CFT as excavation. Very simple. Okay, you can even just share these rows, so it can be clear for you. And this is number first, and let's actually, let me just save that like this color. So excavation is done. Now number 2, we might have, if you just see the foundation, there is actually concrete work, and that is of course 136. Okay, you can see that from specifications, and it is 9 inches. So very simple, we're gonna actually calculate the PCC work now. PCC work, and you have to write actually 136 because there can be different PCC work in the same project. And that PCC can be applied for the same things, like maybe for all these things. Okay, so I'm gonna copy them over here and paste them over here. Now in number, they are just the same. Okay, for the PCC as well. So I'm gonna just copy and paste them over here. Okay, however, the length, width is just the same again, but the height is just different, which is 9 inches. Okay, so why not I copy these things, Control C and Control V over here. This is very easy because, as you can see, the width is just the same. It means the length must be the same. Only the thickness is just different, which is 9 inches, okay? So instead of 2, I'm gonna put 0.75 for all, okay? And we will actually drag this thing over here like that, and let me just remove that one. And I'm gonna actually have, let's just copy the formula, Control C, and we will paste it over here. So we have the formula. By double click, you can confirm that. And we will drag the formula like that and remove the that raw, which is actually, you can say, empty. Okay. Now, the PCC work, that's also in CFT. So we can drag, and this is actually why I love Excel, because it does the work very in short time, you can say. We have the total excavation, and then this time we have the total PCC work. I'm gonna write that over here. Total PCC 136, and this is actually in foundation, okay? In foundation, and you can even write the details for that over here in foundation. Now we will auto sum them. You can see that, select with extra cell and click the summation. So you can see that again, that's in CFT. Let's just have some shade for that, the yellow one, and then maybe some shade over here like the green one, because these are then easy. Okay, I think that is like this, because they are just then easy to be read. Okay, so we have number 1, that is excavation, then number 2, that is PCC work, and the total over here. Very simple. If you consider the, as you can see, we have brickwork, and these are 2 steps. Okay, one step this one, and then the brickwork in the walls. Okay, so we will do this tomorrow, inshallah. If there is any question, you may ask. All right, so if you guys remember in the previous session, we have actually calculated the abstract of excavation and then the PCC work in the foundation, okay? But over there, as you can see, for the column, it is never excavation, okay? It's columns PCC, you can say. And then the columns PCC, its height is, you can say, 6 inches or 0.5, okay? It was just a correction you guys have to make. You can see, because it is 6 inches, but in the walls foundations, you can see we have 9 inches PCC work, okay? So it was just a correction. Now, next, we will have to determine the brickwork and the foundation, where we have actually 2 steps, okay? You can say this is step 1, and let me just see its dimensions. You can see this is 2 feet and 6 inches, okay? Step 1's width. And then we have step 2, whose width is, you can say, 2 feet, okay? So we will actually calculate the brickwork, okay? And this is number 3, and I'm gonna say brickwork in foundation, okay? And that is of course 1:3 mortar, okay, in the same brickwork. Now, the brickwork can be different for the long walls, for the short walls. I'm not gonna copy the columns because there is no brickwork for the columns, okay? So long walls, short walls. And again, remember, the numbering can be the same, okay? Very simple. Because we have the same number of long walls, the same number of short walls, and there is a brickwork for each, okay? Wait a minute, what's wrong over here? Okay, column, that is 1, so I'm gonna remove the 1 for the column. The length can be different, okay, because these lengths, like you can say 27.79, it was for the long walls 1 length, but for the excavation, okay, the excavation length can be more lengthy, you can say. However, for the step 1, you can see this is step 1. Its length can be little bit, you can say, smaller, or maybe the foundation was lengthy, okay, with respect to this step, okay. So step 1, you can say, let me just have some annotation so you guys can see it, okay? And I'm gonna just do it a little bit quick, like you can say we have step 1, I'm gonna call it, okay, step 1. This is step 1, and then we have the other one, that is step 2. And above this we have DPC, okay? So we're gonna also look into that. Now, if I can separate it, like let's say here is a line, okay? So this is the separation for step 1 and 2. And there is, let me just annotate them so it can be very clear for us, okay? This is 2 feet and 6 inches in width, okay? Step 1. So let's just see For each wall, we have 2 steps. This is now the problem, okay? There is 2 steps for each wall, and that's the problem. Now, you can see long wall 1, we're gonna insert some rows for that. Like maybe insert 1 row and insert another row because we have 2 steps. Like we can say step 1 and then brickwork step 2. Very clear, okay? And similarly, we will apply the same process for all, but let's just look into the same thing, okay? Like you can say long wall. Now, in number, there are only 3, okay? But I'm going to remove that one because we are calculating the things for the steps. Step 1, that is 3 in number. Step 2, that is 3 in number. But in the length, let me just, you can say, lock this view so we can have actually data on the top. Oops, just a minute. I'm gonna lock this one. I mean freeze, okay? Now we can see that, it's clear. So we will have to determine the brickworks, and as you can see, step 1 for the long wall 1. The length, what should be the length? We will apply the same formula, okay? Now, the length for each wall, of course, they are over here. You can see them, it's from the drawing. We have already separated them, you can see in the previous session, okay, long walls, short walls. Okay, we have split the same 2D plan into long wall, short wall. But we will actually determine the length by the same way as we did for the excavation. Like we will subtract the thickness of the wall from the width of the foundation, which is actually the width of the step 1. So it means step 1's width minus the thickness of the wall. And then we will, of course, add the length of the wall, which is just, you can say, in the plinth level. Now, the step 1, that is 2 feet and 6 inches. Okay, if I'm not wrong, let me just confirm it again. It is 2 feet and 6 inches. Okay, that is step 1. We will actually subtract 9 inches from it. Very simple. Like you can say 2.5 minus 9 inches, which is 0.75. Okay, that is, oops, we have taken 25. Okay, it is 2.5. And we will actually subtract 0.75, which is 9 inches. Okay, so it is 1.75. Now we will add the length of the wall, okay, and that is actually the length of the long wall 1, which is 25.291. Okay, so 25 plus 25.291. So this is actually the total length for step 1, which is 27.01. Okay, so you can say we're here, I'm gonna write 27.041. 041. This is the length. Now the width, that is known, okay, 2.5. If you see from the section, the height, let's just see what's the height. It is 6 inches. You can see it over here. Okay, so this is 6 inches, and I'm gonna put it over here like maybe 0.5. Very simple. And we will apply the same formula over here, copy from the above, and you can confirm it by double click. As you can see, it is just indicating that the formula is okay. Now the as you can see, long wall 1, okay, and these things are actually in step 1 and step 2. Okay, again, let me just remove this thing, and actually I'm gonna copy these. Are you can even move them because okay, so this is going to be in CFT. Okay, and similarly, we will determine the length for the step 2, and we will follow the same process. Okay, how? Let's just see it. Okay, for this, let me just erase this of it, and as you can see, for the step 2, that is, I think, 2 feet, if I'm not wrong. Okay, let's just confirm it. It's 2 feet. Okay, the width of the foundation, or maybe the width of the step 2, that is 2 feet. We will subtract the thickness of the wall. Very simple. Okay, so it means 2 minus, where is it? 2 minus the thickness of the wall, which is 0.75, and then of course we will add the length of the wall 1, which is, you can see it over here. Okay, and that is 25.22 minus 0.75, and then we will actually add this length, okay, which is plus 25.291. So this is the length for the step 2, which is 26.54. Okay, very simple. So we have the length, and that is, where is it? Over here, 26.541. Okay. Now the width, that is actually 2 feet for the same step, for the step 2. The height is, let's just confirm the height. It is, you can see, 9 inches. So we have 0.75. Clear? Now we will actually drag the formula below, and of course this is gonna be in CFT. Very simple. Now we will apply the same process for the long wall 2. Okay, and let me just insert some 2 rows because we have 2 steps. Okay, and similarly we will have actually like step 1 and then step 2. Let me just copy them and paste them over here. Now the thing, as you can see, the width and the height for both can be the same. Okay, so I'm gonna copy them over here, and of course the numbering can be the same. Okay, not the same because we have long wall 2, and we will actually confirm that from the long wall 2 because their numbers are only 1. Okay, you can see it from the other you can say examples, like maybe from the PCC we have long wall 2 and that is 1 n number. It means their steps are 1 1. Okay, the thing which is actually important is the length of long wall 2. Okay, and we will apply the same process. And let's just jump into the AutoCAD again. Now we will actually have to subtract the thickness of the wall from the thickness of this step 1, and we will add the length of the long wall 2. Very simple. Okay, it is the same process. I'm gonna do it for the all, right? So the step 1, it was 2 feet and I guess 6 inches. Yes, 2 feet and 6 inches. Okay, so 2.5 minus 9 inches, which is the thickness of the wall, and we will add the length of the wall. Okay, and that is of course 13.125, and even you can confirm it from the drawing. Okay, which is 13.5. Where is it? Yes, it's over here, 13.125. Okay, plus we will add 13.125, and that is 14.875. 14.875. Okay, now for the step 2 we will apply the same process. Okay, like maybe you can say the step 2's width, that is 2 feet. We will subtract the thickness of the wall, which is 0.75. Okay, and then of course we will add length of the wall, which is of course 13.125. So 14.375. 14.375. That's very clear. Now we will apply the same formula. You can even drag them and remove the 0 because there we don't have videos. And of course the CFT work. Now we have done actually the long walls, like long wall 2, long wall 1. Okay, they are done. Now we will actually calculate the brickwork quantity for the short walls. Okay, and here is only just a simple trick. If you see, we are adding the length of the wall over here. Okay, and even you can see in the description, as you can see for the long walls, we are subtracting the foundation width. Okay, I mean we are subtracting the thickness of the wall from the foundation width, and then we are adding the length of the wall, as you can see. But this time this ratio will be subtracted from the length of the wall. Okay, for the short walls. So let's just see, and we will actually have the same process. We will insert some rows because we have 2 steps. Okay, like step 1 and step 2, and step 1, and then of course step 2, and we are applying this for the all. Okay, and similarly for the short wall 4, you can say step 1 and step 2. And this is actually to make it easy for all. Okay, and of course step 1 can be 3 because we have short walls in number, those are 3. Very simple. Okay, and they are 2, and of course the short wall 3, those are 2 in number, so their steps must be 2 2, and here we have 1 1. Very simple. What matters is actually their lengths. However, their widths or maybe the heights remain the same for all because we have only one section for long wall and short walls as well. It's very clear. Now let's just calculate the length of step 1. Okay, for the short wall 1. And this is going to be very simple. We will only subtract actually the thickness of the wall from the width of the step 1. And then, of course, we will subtract that ratio from the length of the wall. Very simple. Like, let me just switch this thing in such a way so we can see it, okay? Now, we're here. Let me just zoom in this portion. The step 1, that is actually 2.5 in width. And let me just have some remarks over here. The length should be, for step 1, that should be actually the length of the wall, which if you see, that is, if I can see it, where is it? Okay, short wall 1, that is 11.25. Okay, so that is actually 11.25. We will actually subtract one thing, which is actually the step 1's width, okay, and that is 2.5, and subtracting the thickness of the wall, which is 0.75. And this is actually the same formula, okay? We are applying, and you can have calculator, or maybe you can even enter those things in the same Excel, okay, to calculate the formula. Very simple, okay? And just by doing the equal, like maybe if there is equal sign over there, and it will calculate that for you, which is 9.5, okay? So this is the process, okay? By Control Z, it means this is 9.5. And we can actually put this video in the same cell for the length, okay? We're here. This is the length, which is 9.5. Is it clear? And let's just calculate that for step 2, okay? Again, in the remarks, the length should be, let's say the length for step 2 should be, we will have actually the length of the wall, which is 11.25, okay, and we will subtract 2.5, which is 2, which is the width of the step 2, and subtracting the thickness of the wall, which is 0.75. Very clear, okay? So this is going to be the length, and by applying the same formula, Excel will do that for you, which is going to be 10. Okay, very simple. So we can use 10 over here, and that is in remarks. Okay, the length should be 10. All right, we will have actually their beds, and they are known, which is 2.5. And then for the step 2, that is 2. The heights are different, that is 0.5. And this one is 0.75. And actually for the quantity, we will drag the formula below so you guys can see it. Okay, and of course, the CFT, they are going to be in CFT. All right, we have actually done short wall 1. Now we will cover short wall 2. Okay, and this is going to be the same process. Let's just copy these things because these are just the same for all. So we can have much time in order to solve these things. Okay, okay. Can be copied over here, and maybe for wall 3, and maybe for wall 4 over here. Okay, so what we have to do is actually to determine the length, and the formula will work actually the same thing for you. Step 2 length, we will have to just do it over here, let's say, okay, over here. Now, what should be the length? Of course, for the wall 2, we will actually look for the length over here, okay, for the short wall 2. That is 12.375. 12.375, okay? So 12.375, this is the length of the wall. We will actually subtract for the step 1, okay? And that is 2.5. We will subtract its width, and of course 0.75 for the thickness of the wall, okay? And even we can actually put the formula over here, okay? So this is going to be the length. So equal, and this is going to be 10 point something, right? Very simple. Now we will apply the same process for the remaining, okay? 10.625, okay? I'm going to remove the formula, and I'm going to say 10.625. So the formula remains the same, okay? And this is very simple, okay? And let's just say, again, we will have equal, and we have the total length is 12.375, and we are subtracting actually the width of step 2, which is 2 this time, and 0.75. And this is going to be 11.125. So let's say 11.125. Now we will put these videos in the same thing over here, like, okay. So we have the length for the step 2 for the short wall 2, that is going to be 10.625, and over here it should be 11.125. And as you can see, this is actually the same quantity. Now I'm gonna switch the video so I can apply the same thing for the remaining, because the video can be then longer. Okay, so I'm gonna pause the video and then we will start when I'm done with it. Okay, now I have calculated the lengths for step 1 and step 2 and that for the short wall 3 and short wall 4. Now I'm gonna copy actually the same CFT work, okay, just like that, okay. And let's just remove this thing and this one, of course, these zeros. Okay, so this is actually the total brickwork. Now we're gonna add them over here, okay. So we can, let's say, we'll select these things with extra cell, and then by this sum over here, we will click there. As you can see, let me just say we have the total brickwork over here, total brickwork, okay. Very simple. But however, we will actually deduct some quantities for the doors, for the windows, etc. So it means this is not the net work, this is the total brickwork. We will have to subtract the deduction, and then of course we may get the net brickwork. And this is of course 1, 3, okay? And that is the ratio for the mortar in the same brickwork. Now let's just have some deduction, okay? Deduction of our brickwork and foundation. You should include foundation over here, okay? In foundation. Okay, the thing, as you can see, we have foundation. It means there is no deduction, because in foundation, we may not have, you can say, the brickwork deduction, because there is no door, there is no window in the foundation, okay? So it means that's okay, we're here. I'm not gonna count it. And even, let me just remove the total. So it's better to actually calculate or maybe include the walls, and then maybe we should add them all. What do you say? Okay. Now we have actually done the short wall 4. Now we will have to determine the quantity actually for the walls. Okay. And then we will actually calculate no matter the DPC. Okay. For the walls, as you can see, the lengths must be the same, only the thickness is just different. And of course, the height, that is 11 feet. All right, so let's just say the brickwork in walls. Brickwork in superstructure, you can say, or maybe in walls, okay? And that is also in 1:3. Now, remember, these are the same thing, long walls, short walls. They never change. However, and in number, let's say one thing, that is number 3, and over here we have number 4, okay, in serial number. Okay, these things remain the same, okay, and I'm even gonna copy their numbers, okay, over here, their numbers like this. Now, their length matters, of course. If you see, we have these lengths, and let me just place them over here so we can see them directly. As you can see, we have long wall 1, and they are 3 in number, and their length is actually 25.291. For the long wall 2, its length is 13.125. For the short walls, their length is, of course, you can see 11.25, okay, 11.25. And for the short wall 2, that is 12.375. For the short wall 3, that is 6.158. And then lastly, we have 5.625. So these are the lengths, and they are actually taken from the same drawing, okay? You can just watch the session 1 in order to learn these things and how these lengths are there in Excel, okay? So as you can see, we have long wall 1, just for the example, long wall 1, and they are 3 in number because we have 1, over here this is 2, and this is 3, because they are same in length. And their length is just given over here, 25 feet and 3.5 inches, okay? Which is, of course, total in feet, and that is 25.291 feet. Very simple, okay? Now, the width can be actually the same, like maybe a thickness of the wall, which is 0.75. That is known, okay? You can see it from the same drawing over here. The wall thickness, that is 9 inches. Okay, so I'm gonna just apply that to all. And another thing, which is the height, and that is 11 feet, the height of the wall. Okay, let's just provide that to the all. Now let's just copy one formula from this point, and here I'm gonna paste the formula, and let's just drag the formula applied to the all. And this work is of course in CFD. Now we will actually add all the brickwork to have the total brickwork quantity, you can say. Okay, so select with extra sheet and sill, I mean, okay. Select with extra sill, and as you can see, we have 1800 and 3.5 something CFT brickwork. Okay, so this is the total brickwork, and that is in 1:3. Very simple. Now, another thing is actually to have deduction for the doors, windows, and ventilators, you can say. Now, there can be number of doors, windows, and ventilators, and we have to actually look for that in the same legends over here. We have some legends. Okay, so we have different windows, like maybe window 1, and its size is 5 times 5, and they are 5 in number. So I think I should let's just take its screenshot so we can see it then. Okay, let's just take a screenshot. Very simple. From this, I'm gonna take a screenshot, and as you can see, they are now over here with us. Okay, so we can have the detection process in short time. Now zoom in. Okay, we're here. Now, as you can see, we have W1, then we have V1, then we have D1, like maybe door 1, there is door 2, we have door 3. Okay, this is detection we have to do. Now, in number, they are 5, then 1 and 1, and then of course 2 and then 1. Okay, for door 3. It means window 1, that is 5 in number. And let me just confirm it if it's good or not, if it's working or not. Okay, from the layer, I'm gonna switch the thing, which is of course the long wall and short walls. Okay, so you guys can see it. This is short wall, and here is long wall, and this is long wall. Okay, and now let me just see the doors and windows. As you can see, let me just have text over here, and text is already over there. Okay, as you can see, this is the window. Okay, so we have 1, there is 2, okay, and here 3, this one is 4, and this one is 5. It means we have 5 doors, windows 1, sorry, this is window. Okay, and they are actually 5 by 5. The size is just 5 by 5. Okay, you can just confirm it from the drawing. Let me just confirm it from the elevation. Okay, just like that. Okay, this is 5, its width is 5, and then the height, that is also 5. Okay, so it means the data is just fine, and we have to actually put a size. Okay, like maybe the in front, the area is just 5 by 5. Okay, so 5 by 5, and we will take the thickness, and that is actually the thickness of the wall, the same thing. Okay, and this is going to be the same for all. The size for V1, that is actually 1.5 times 1.5, and then of course for D1, that is 4 times 7. For D2, that is 3.5 times 7, and then of course for D3, that is 2.5 and 7. Now this screenshot is no more needed. I'm gonna delete it. Okay, let's just apply the same formula for the all. Okay, just multiplying these 4 columns and apply that, and that they can be in CFT because it is just brickwork, or you can say the volume. And now let's say detection for lentils, and I'm gonna do this brickwork today, and then we will end the session, and of course we will start from the same point tomorrow. So deduction for lentils. Now it depends how many lentils do we have. There should be lentil on the doors and windows only. Very simple. Now I think I should need the same screenshot again, so we can do the work very easy, okay, in short time. So let me just have the same screenshot, just over here. And one another thing is, let me just decrease its size. Now, lentil can be actually in different size, and let me just jump into the same AutoCAD. As you can see, let's say if we have this window, okay? Now, we will have lentil, which is, of course, let me change the color. let's say the lintel can be in this form, okay? Maybe some bearing, okay? And the length of the window can be added, okay? So this is called the bearing over here, okay? The overlap on the window. So bearing can be added to both sides. It means this is going to be the length of the lintel. And however, the thickness of the lintel can be taken from over here. That is 9 inches. And of course, its width is 9 inches. Okay, very simple. I guess there is something which is needed over here, like maybe lintel for W1 or window 1. And there we have lintel for D1, door 1. There should be lintel for D2. There should be lintel for D3. Now, in number, they should be the same thing as this one. Window 1, that is 5 in number. Door 1, I have just I were there. So door 1, that is 1 in number. Door 2, those are 2. And door 3, those are only 1 in number. Now, the length of the lintel can be actually something we will calculate actually from the size of these windows, you can say, in doors. Like, let's say for the window 1, the size is 5 by 5. It means 5 is the length of the window. So we will add 6 inches for bearing for one side and another side. It becomes actually then 6 feet. Like 5 feet plus 6 inches plus 6 inches. That means 6 feet is going to be the length. Now for the D1 or door 1, as you can see, the length is just 4 feet. 1 feet can be added for the bearings for one side and another side. So this becomes actually 5. Now for the door 2, the size is 3.5. So it becomes 4.5 after adding the bearings. So 4.5. Now for D3, that is 2.5. Adding 1 feet for the bearings, it becomes actually 3.5. Now the lintel is just 9 by 9 inches. You can say 0.75, then 0.75. Drag the formula for all because it is the same lintel for all. It is never changed. I'm gonna delete the screenshot now, and we will actually apply the same formula for all, okay? And let me remove the zeros. And this is actually in CFT, going to be in CFT, you can say, okay? And now deduction for lintel is actually the same thing. You can just say the quantity of RCC work, okay? If there is RCC work, and let me just include one thing, okay? This is deduction, but this is RCC, lintel is just RCC. And I'm going to include the ratio as well, 1:4. You can say this is from the specification, okay? Now we will add the total deduction. This is the point, okay? So let's say we have total deduction, that is 193 CFT. And now let's calculate the net brickwork. It's going to be very simple, okay? So the net, now the formula is actually equal, and we had the total brickwork. It's over here, and we will actually subtract a deduction for the doors, windows, ventilators, and then for the lintels, okay? And enter. So this is the total brickwork, okay, in CFT. All right, is it clear? And I think it's okay for today. See you tomorrow. Allah Hafiz. All right, so let's get started. And if you remember, we have done up to serial number 4, which is the brickwork and superstructure. And then we have some deduction you can see for lintels, and then for door, window, and ventilations, okay? And then finally, we got the net brickwork. Now, serial number 5, and that's gonna be the DPC work, okay, which is 1 to 4. You can see it in the section over here, okay? This is DPC. And this is, I think, if I'm not wrong, 1 inches or maybe 2 inches, okay, thickness. Let's just see it from the annotation, and I'm gonna specify, okay, it is 2 inches DPC, okay? So, and if you see the width of the DPC, that is just the same thing as the width of the step 2. It means the length of DPC must be the length of the step 2. Very simple, okay? And we have already calculated that, okay, the length of the step 2. So it's better just to copy the things which are actually the long walls and short walls. And let me just copy them with the number and then the length. And then we will actually just remove the extra, okay, for the which are not included in DPC. So if you see, we have wall 1, and step 1. So step 1 is not required because we need the step 2, because the weight of the step 2 is just the same thing as the weight of the DPC. Okay, now for the long wall 2 we don't need step number 1, so that means we will just remove step number 1 for each wall. Very simple. Okay, just do it, very simple. And for short wall 2 we have step number 2 and I think this is step number 1. Okay, let's just confirm it. We have short wall 2, this is step number 1. Okay, renamed it, does not matter. Okay, so let me just remove the first one, and then for short wall 3 step number 1 can be removed, and for short wall 4 step number 1 can be removed. It means we have the length for step number 2. Okay, it means the DPC's length for each step, which means for each wall you can say. Okay, because we had different walls over here, long wall, short walls. So it's very simple. Now the weight of DPC is just the same thing as the weight of the step number 2. Okay, and that is, if I'm not wrong, 2 feet only. Okay, I'm gonna confirm it from here till that point. That is 2 feet. Okay, the weight of the DPC, that is actually 2 feet. So we're gonna put it over here. Very simple. Okay, 2 for each. Okay, very simple. Now the height of the thickness of DPC, that is never included in abstract of materials. However, in analysis, then we may convert that over there. Okay, so the quantity can be actually in terms of area now, like the breadth times the length times the number of the walls. Okay, so this is going to be the quantity of DPC. This is gonna be in SFT or in area. Okay, and let's just apply the same formula to all, and I'm gonna remove the 0 because there are no values in rows. Okay, so even you can copy SFT to both. You can say to each row. Okay, and then remove the extra. Very simple. Okay, so that means let's just select extra cell and then the sum, and so we can get actually the total DPC work over here. Okay, I'm gonna merge and center the raw and cells over here, and we have, let's say, total DPC work. Okay, very simple, which is 124 and 1 inch thick DPC. So it's very clear, and let me just color this thing so you guys can see it clear. Okay, and the DPC work is in another color like this one. Okay, now number 5. Sorry, number 6, and let's just see the section. Okay, we have calculated the you can say brickwork in superstructure all you can say before. Okay, and let's say if it weren't we have the column, so we will calculate the quantity of RCC work, it means. Okay, and we will include the column as well. Okay, so let's just calculate RCC work, which is going to be 1, 2, 4. The RCC work can be in different places. Okay, it is in staircase, it is in column, and then in slab, you can say. And we're here, this is not RCC work, that is just PCC 136. We have already covered it. This portion is already covered. Okay, however, this portion is RCC. In RCC, let's just cover like maybe the lentils. Okay, lentils are RCC, and we have already calculated them, so we will actually copy them. Okay, so the RCC actually are lentils, right? And let me just copy them. So we have in separate place, does not matter. Okay, copy them and paste them over there. Okay, it means lentil for window 1, lentil for window door 1, for door 2, for door 3. Okay, very simple. Now we will actually add them all. Let's not add them, okay, because we don't need to add them all over here. We will just add the total RCC work, okay, at the end, no problem. So it was just for the lentils. Now let's say the RCC work for columns, okay, and we have only one column. And if you see, the column is something very different. You can see it is isolated footing, okay, you can say Frustum of cone at this section. And if you remember, we have already used a very simple formula in the very first or maybe second session, okay? So for the column, I'm gonna say column foundation, and then just the column, okay? And then the columns here, okay? So we have three things over here. Foundation is one, column is one by itself, the cape is just one. In the columns foundation, if you see, this is isolated footing, so we will do it little bit later. However, look at the column. The section is just 1 by 1 feet, okay? It means the area that is just 1 by 1, okay, column. However, we'll take actually the height, and let's see if the height is just 11 feet or something more, okay? So I'm gonna confirm it from here. Make sure it is known in the drawings, okay? So it is 10 feet and 6 inches, because 6 inches may be the cape, okay? So 10.5. Now the cape, let's see, this is the cape. You can see it over here, okay? And it is 1 feet and 6 inches. Of course, 6 inches is thickness, okay? Thickness is just 6 inches or 0.5, and 1 feet and 6 inches. It means 1.5 is the length, okay? It is just square, so the sides can be the same. Very simple. We can just apply the same formula, but before, let's just apply it, does not matter, okay? 10.5 for the column, and for the cape 1.125. However, the columns foundation, that is something very tricky, you can see. Okay, and if you remember, there is a nice plug-in chicken formula for that, for Frustum of pyramide. And let me just have its coffee so you guys can see it then, okay? And okay, let me just move it a little bit above, so then we can see it in Excel. I'm gonna take a screenshot so we can see it, okay? All right, let me just take a screenshot so I can import it over here, and then you guys can understand it very clearly, okay? Now, okay, here's the screenshot. This is in isolated footing, and in isolated footing, if I can decrease the size, you can see it, okay? Now, over here, the length, width, and height, I'm gonna ignore all those things. However, we will just apply a simple formula over here, okay? So let me just merge in center. Now, the thing is actually to, let's take equal, and then the depth of the footing, you can say, which is 1 feet and 6 inches. You can see that it is 1.5, okay? However, it's good to start it with the bracket 1.5, and then we will multiply this with the top area, which is 1 by 1, okay? So 1 by 1 is just 1. However, if there is different, you have to multiply that. Like that is 1 by 1, so it means 1 by 1. If that is 2 by 2, it means 2 by 2, or just 4 square feet, okay? Very simple. And we will add actually the bottoms area, which is 3 by 3. You can see it, okay? 3 by 3. That is just the dimension. No, 3. So 3 by 3, that is just 9. And again, we will add it, and we will apply a square roots formula, because we have square root top area and then bottom area. So top area is just 1. Multiply it with the bottom area, which is 9, okay, and close the bracket. However, if you see, we might have a bracket over here, okay, it start, because this is Excel, and then we will actually, let's close it over here, okay, like this. And even we will just divide this by 3, because the formula is like d by 3 into a1 plus a2 plus square root a1 and a2, okay? Press enter, okay, let's, they will rearrange, because this is, there we have actually the multiplication, so multiplication sign must be provided over there, okay? So the volume of this prism pyramid portion, yes, prism of pyramid portion, that is 6.5, okay? So it means the quantity is going to be the same thing as 6.5. It must be in CFT, because this is concrete, okay? And of course, CFT for the others. So I'm gonna remove the screenshot now. We are done with the column. Now, I think we should move to the slab, okay? Because there is slab, and then we have staircase. So it means the RCC work then might be completed. However, over here we have another thing, which is actually the veranda. We might take that as well. which is maybe in terms of feelings, okay? Because the ground level, if you see, the ground level is just over here, okay? And if you see the ground level in the column, it is just, you can say, 1 feet above the, I mean, the excavation is just 2 feet, okay? So if that is different, however, they are not different because 9 that is just 18 and plus 6 that is 24. So it means the surface is just level. However, if there is any beam, okay, in another project, you might need refilling per date, okay? So you have to then calculate that things are included in the abstract of materials. Okay, let's just see. We have slab then, and in slab is just 1. However, the size, that is, if you see, we have 27 feet and 6 inches, so 27.5 one side, and another side, let's see, that is 34 feet and 9.4 inches. So you're gonna convert that 9.4 inches into feet, which is 0.7 almost, and then add 34 with it, so you can get 34.7, okay, like 34.78 almost. All right, the thickness is just the same as the thickness of the column scape, which is 6 inches or 0.5 inches. Okay, just drag the formula. However, there is a hole for the staircase. Okay, we have staircase over here. So for the first floor, there is hole over there. You can see that. Okay, so we will subtract this, or you can say, let's say we have deduction. The deduction for stairs hole, you can say, or empty portion, you can say, it does not matter, whatever you call that. In number, that is 1. The length is 11 feet 3 inches, so 11.25. The width is 6 inches, if I'm not wrong. Yes, that is 6 inches. So we have 6 inches over feet, that is feet, not inches. Okay, and height must be the same. Let's drag the formula, and the units are just in CFT. Okay, so before calculating the deduction, it is really important just to calculate the total RCC work. Okay, so let's say we have total RCC work, and we will just add them all by the summation. And of course, now we can subtract the deduction. So it means we can say there is, oops, just a minute. We can say that there is net RCC work now, okay? So net RCC work. And this is going to be equal the total, and we will actually subtract the deduction, okay? And press enter, and let's just drag the CFT. So this is actually the net RCC work, which is actually the quantity, okay? And let's say we're gonna color them as well. Almost. But however, in RCC work, stair is still remaining, okay? You have to count stair as well. All right, so stair is just remaining, and then I think our quantity is completed, and then we will just move to the chajja. Okay, let's just calculate chajja, and then of course we will add stair over here, okay? Maybe in the next video, okay? So the total is not yet completed. I'm gonna insert one another thing. Let's say for the stairs, okay, we're here, insert, and let's say RCC stairs. And then we will just calculate it tomorrow, okay? And then add them over here with this thing. It is not now a total work, and the net RCC work is not available, like you can say that, okay? So the thing which I'm gonna calculate is actually serial number 7, because stair is little bit complex thing, so we will cover that tomorrow, okay? Now we have already spent enough time in the same session. Okay, number 7, we have, you can say, chajja or parapet walls, okay? That should be actually the perimeter of the slab, very simple. You can see this is parapet wall, okay? This, and it is, you can say, the perimeter of this slab. You can even just confirm it by control 1. Okay, it is over here. If you see, the length is 124 feet. Okay, and we will just you can say confirm it over here again. Like you can say this is 34 feet 9.4 inches, but we have two sides of the rectangles. We will multiply it with 2, which may become actually almost 70 feet. Okay, and then we will add this side, which is 27.5, and then the other side like this one, which is again the same because this is a rectangle. So this is going to be 27.5 again. So the perimeter is 124 feet and almost 6 or 7 inches. Okay, this is a number. The length is 24 and 6 inches means 0.5. Okay, now this is going to be in a running feet. Okay, RFT, because Chaja is never calculated in terms of area or maybe volume. Okay, it is just in terms of RFT, very simple. We have done today actually the TPC, then the RCC work, okay, and then the Chaja work. Tomorrow is going to be like the final day for the abstract of materials, and then another day we will just calculate the cost of different materials, okay, from the MRS. Okay, so tomorrow we have actually the RCC work for the stair, and then we will have DPC, okay, like number 7, and then number 8 can be the plaster work, not TPC, the plaster work, and then number 10 can be the whitewashing or maybe paint, you can say anything, because this is surfacing. So we will cover these things tomorrow, inshallah. Allah Hafiz.
चज्जा का एस्टिमेशन कैसे निकालेंगे?
चज्जा रनिंग फीट,
इसका ये तो रनिंग फीट में है।
रनिंग फीट में है ना ये। अच्छा, छज्जा कंक्रीट का भी हो सकता है और फिर ब्रिक का भी हो सकता है ना। तो रनिंग फीट का मतलब क्या है कि कुछ क्वांटिटीज को हम वॉल्यूम में कैलकुलेट करते हैं, कुछ को एरियाज में, ठीक है, कुछ को नंबर में, कुछ को रनिंग फीट मतलब इन फीट्स, मतलब लेंथ सिर्फ हम काउंट करते हैं छज्जा की। अब पाइप को देखे ना, पाइप का भी हम लेंथ काउंट करते हैं ना, जिस तरह पाइप का लेंथ काउंट करते हैं, इस तरह छज्जा का भी लेंथ काउंट करते हैं हम।
यस सर।
फिर एनालिसिस में बेशक इसका रेट डिफरेंट होगा एमआरएस में। अस्सलाम वालेकुम। Alright, so we will continue the same project, yes, project 1, and we have done some work like this. Okay, some things are remaining, such as RCC stair, and then of course the Chaja carpet, plaster and whitewash work. Okay, let me just open the same project. It is just tour here. Okay, let's just determine. Okay, let's say if we have plaster work, okay, we will take the stair at the end, no problem. Okay, so let's just see, we have the plaster work, and the plaster work that can be internal and external as well. So let's just focus on the external first. Okay, we have external, you can see, and we will just take the parameter of the wall, and then we will multiply that with the height of the wall. Even you can do that with the long wall, short wall method. Okay, if you have long wall, short wall, you can just apply that method as well, no problem. But over there, we may have some things such as, let's say if we take the long wall, which is just this external one, okay, there can be actually some deduction then for this place, okay, because we don't have plaster over here, okay, on both sides of the wall. So it's better to have the parameters and then multiply the parameters with the height. So there, that can be then very easy. Okay, so let's see. The first thing, let me just draw a line, and so we can see it, okay, better. Let's say if we have a red line, and I'm gonna have just a, you have to actually, you may have this drawing in a hard form, okay, then you have to just add the sides like 25, then this side, okay, which is 32, then you have to add this one, and which is like, and this one as well, okay. So these can be added, but for the sake of easiness, I'm going to draw a polyline so you guys can see it, okay. The plaster can be on this surface, you can see the red line, okay. Then on the same surface up to this point then, okay, and then of course up to this point, and so on up to this point and till the end. So this is external plaster. Okay, we might have plaster on this external surface. So let's say, I'm gonna say external plaster, okay? And let me just remove this, the serial 10, so we can complete the serial 8. So in plaster, let's say external plaster, okay? Now external plaster, I'll take that one and the length, okay? So you have to just count this parameter, okay? I'm gonna just use AutoCAD so I can do it very quickly without wasting much time. You can see the length is 116 and 6 inches, okay? So 116 feet and 6 inches means 0.5. Now, what should be the width? There is no width for that. The technician just ignore, you can say, because the plaster work is taken in terms of area, and we have already discussed these things before. So the height can be the wall height. If you see, where here we have the wall height, which is 10 feet and 3 inches, okay? So that is 10.25, okay? Now we have the quantity like equal. We will multiply the height with the length, and then of course, and this length is actually, you can say the parameter, okay, and then the number. You can see this is the area which is in SFT. Very simple, okay? Now, in remarks, you can even include like this thing. You can say this is, let's say, the external parameter, okay? This is number one. Now, we will have internal plaster. Internal plaster. And internal plaster, we have different rooms, you can say. Okay, let me just open this thing. Okay, so as you can see, we have 2 rooms and their size is different. The lounge size is different, okay? And even we have plaster on the staircase and the kitchen size is different, okay? And over here, we may have plaster, okay, on this column. But this is RCC column. We don't need plaster over here. There can be only whitewash or maybe the tile work, okay? However, you can check these things in the specifications, okay? The bill of quantities that is just asked for. You have to just calculate the things according to that, okay? No problem. All right. Now, next, as you can see, we have to determine the area, the parameter. Okay, let's say if I can draw a line, okay, from this point till this, okay, this can be actually the internal plaster. Okay, you can see the red line. Okay, this can be the internal plaster. So as you can see, we have to determine its parameter, and the parameter, as you can see, we're here in the properties, that is 45 feet and 9 inches. Okay, we have just added all the sides. Now, as you can see, these 2 rooms have the same dimensions. It means we will multiply this with 2. Okay, so as you can see in the internal plaster, I'll say bedroom, and they are 2 in number, and the length is 45 feet and 6 inches. Okay, let's confirm it again. That is 9 inches, sorry. Okay, so 0.75 can be added. And then, of course, the height is just the same for each plaster work, okay? So we will drag the formula, and as you can see, I'm going to remove the 0, and this is going to be in SFT as well. So this is actually for the bedrooms. Now, for the bath, we will take the same thing, okay? You can just draw a polyline, and I'm not going to delete the old one, so we can just say that that is already done, okay? So as you can see, this is 24 feet and 5 inches. So the length is like 24 feet and 5 inches means approximately 0.4 something, okay? 435 or maybe 0.45, and that is only 1 n number, and the length is just the same as the height is just the same. This is the parameter, okay? The quantity can be applied, and this is going to be an SFT as well. Now, next we have the kitchen. So let's say if we have the kitchen, I'm gonna just apply the polyline from this point over here. This can be the length, okay, this way. And this is actually something, we don't have wall over here, and the wall is the same thing up to this point. We'll ignore the thickness of the you can say slab for the landing, no problem, okay? And up to this point, it can be, you can say, okay? And even let me just include the lounge, okay, up to this point, okay? You have to add the parameters, okay? And these can be just determined from the drawing, no problem, okay? I'm just going to include all the lounge so we can have that thing in short time. Okay. Okay, the plaster can be up to this point. You can see this red line. Okay, this is the plaster perimeter. And let's say that is 96 feet and 7 inches. Okay, 96 feet and 7 inches is almost 0.59 something. Okay, or maybe 0.6. Okay, no problem. I'm taking approximate value. In number that is 1, and it means the kitchen plus lounge. And the height is just the same, of course. And we have the quantity and then the perimeter. I mean the unit, okay? That's done. We have actually the veranda is taken, okay, in the external plaster, no problem. Okay, what we have remaining is actually the stair, okay? And the stair, of course, I can even just, there is thread and then the rises, okay? So we have to plaster both, okay? Now for the threads, I can just take this rectangular portion. So as you can see, we have already covered those all threads, okay? And this rectangle is just 34 feet and 6 inches in length, okay? So you can say stair and stair, I'm gonna say the threads, okay? And they are different in number, I'm not gonna include, so I'm gonna say 1 because we have already taken all of them in one rectangle, okay? You can see that this is just a one rectangle. Now for the stair, we have the rise, you can say, and that can be 1 in number because I'm gonna take the whole at the same time, okay? The rise for 1, that is 6 inches, you can say. So 6 inches is the height of 1, and it's, of course, if you see, it is 3 feet wide, okay? The stair is just 3 feet wide. So the total height is 10 feet in 3 inches. Okay, you can see that from the section. So we will take this height and then, of course, the width, okay, which is 6 feet, okay, because 3 feet plus 3 feet for the other side. So it means the length is now 6 feet, and I'll take the height is the same thing because this is gonna cover all the rises. We are not doing each separately. That's gonna take much time, okay? Like counting the number of steps, etc. So this is the best way to do it. What's remaining now is actually in the drawing they have not provided headroom, balcony, etc. Okay, so we are not discussing all those things. The things which we should discuss is actually the deduction, you can say. So let's just cover deduction. And in the deduction, we have different doors, windows, etc. Okay, so deduction for doors, from windows, and ventilators. Now in deduction, if you see, we have already calculated deduction for the brickwork, so I'm gonna copy that. However, something will be little bit changed. Okay, as you can see, we have deduction for doors, window, and this is for the brickwork. Okay, let me just copy these things, and then we will have some measurements. However, one another thing which is really important, and we have just forgot that the slab plaster work. Okay, slab is just forgotten. Okay, so we have slab. Now slab can be 1 in number. However, we're gonna take actually these red areas. Okay, these are actually the areas of slab. You can see that. It's very simple. Okay. Again, we will just copy those things, and as you can see, these are actually the top areas. And for the veranda, even we will include this area because this is slab, right? However, externally, we have this slab, you can say this is treasure, but we will just ignore the thickness of the walls. We are not subtracting the thickness of the walls, okay? That's just included, no problem. That can be a small video. However, if you're gonna calculate each thing very like 99%, then you have to take the top area of each layer, like these red squares, you can say, are rectangles, are these red parameters you can see, okay? So these are the parameters of this layer. Like if you see, if you need to determine the slab plaster for the same bedroom, okay, you have to take the same area, which is actually this area, okay? that is just 130 square feet. But I think calculating these things take much time. So it's better to take the external slab, okay, and see its area, it's 956, okay. So I'm gonna take that one, very simple, 956. And let me just include that, okay, and that's just an SFT. Because the slab, okay, you can just see the parameter, okay, one side of the slab that is 27.6 and another side that is approximately 34 and 9, okay. So it means the width that is 34 feet and 9 inches, and of course the length, of course, 27 and 6, so 27.5. In number, that's gonna be 1. Now in quantity, we have actually the formula, which is the width times the length times the number. That's almost that video, 955.6, okay. So very simple. It's good to take them. Okay, AutoCAD is just helping for the quantity surveyor, okay. All right, now the deduction for doors, window, etc. I'm gonna copy those things. Okay, where is it? It's over here without the units. Okay, copy them and paste them over here. Because these things are just unknown, but the things which are just we have to remove is actually the thickness of the wall, okay? And we will take actually both sides. That's why we're gonna multiply these things with 2, because this is the surface area now of one side, okay? We have 2 sides plaster work, so that's why we're gonna take 2 over here again, right? Very simple. Like if we see we have window 1, okay, and the size is 5 by 5. Now 5 by 5 can be internal or external plaster. We have to subtract both sides plaster for the same window, okay? So that's mean I have to multiply this area with 2. However, window 1, that is 5 in number. It means we should have another column, but placing another column is just time wastage. We should just multiply the whole thing with 2. That's gonna be very simple then. Okay, so it means I'm gonna have 2 over here, okay, for 2 sides. Now this is the total area now for the deduction. Okay, we don't have deduction if there is, however, headroom over here for the slabs, which is not just asked, okay, in the same project. So, and there is no drawing available for that. So you can then just subtract that whole for the stair, okay? We have the total deduction. So let's say we're gonna select one extra cell. As you can see, this is going to be in SFT. This is the total deduction. It means now we can calculate the net plaster work, okay? So we can say the net plaster work. What should be net plaster work? We will subtract the deduction from the total plaster work, okay? Now total plaster work, I'm gonna insert another thing over here, and let's say the total plaster work over here, okay? Total plaster work, and we will add actually them, okay? Now the plaster just started from here, from this point. We're gonna add them all, okay, up to this point, and then just click this summation, okay? So this is the total plaster work. You can see it. This is going to be an SFT. Now we will actually subtract that, okay? So in net means we will subtract this deduction from the total. Total is that one, and minus the deduction, which is this one, okay? So this is now the plaster work, SFT. The chacha, or you can say the parapet, that is just remaining over here, okay? So let's just check that. And we're gonna take actually the same thing, which is, you can say, the perimeter of the slab, okay? You can see this slab. So the perimeter can be taken like in the properties. If you see the length, that is 124 feet, okay? So 124 can be taken for the chacha's length. That's 120, and that's already taken, you can see. So in quantity, I can say 124.5. That is in RFT, or running feet. Now let's just calculate whitewash for the same project, and that's gonna be number 9. Okay, I'm gonna say whitewash, and whitewash can be external or internal, and I'm gonna say is per the item number 8. Okay, so I'm gonna say is per item number 8. Because the place we have plastered, that can be just whitewashed. Okay, so it means the whitewashing is 4,299.91, and that's going to be an SFT. However, the column can be included over here. Okay, we can just add the column because column can be whitewashed, and that is 2 by 2, and of course the height is just 11. Okay, so that's 2 by 2. Very simple, and you can just include that maybe above or below that, so you can have the total. Okay, like maybe you can say column whitewash, that is 1n number, and that is 12 by 12 inches. The height is just 11, so the quantity can be 11 times 1 times 1, 1, that means 11. Okay, we can add the total by the summation, so we can have the total over here in SFT. It means total whitewash. All right, what next? We have something that is remaining. Just a minute. Is actually the RCC work for the staircase. Now, as you can see, we have this staircase. Okay, I'm just gonna copy this. Make sure you have just the plan and then the section. Okay, we have this simple one which is not that completed yet. Okay, because we have not that much detailing, but it does not matter because it is just a small project and we can use AutoCAD over here. Okay, so let's say we have this thing. Okay, where we may have different elements such as the landing, the waist, and then these steps. Okay, so we'll be just determining 3 things over here. Okay, let's just jump over here. You can say we have staircase. Where is it? I'm gonna insert 3 rows just for the landing, for the waist, and then for the steps. Okay, so I'll say steps, landing, and then lastly, of course, the waist. Okay, now a number there should be 1, 1, and 1. And of course we have just a minute, we have RCC stair, the landing, the waist, and then of course the steps. Okay, and that should be 1 again. Now as you can see, the first thing which I'm going to calculate is the landing. Okay, let's just jump into the AutoCAD. As you can see, the landing that can be of course 6 feet, which is actually you can see this is 6 feet wide staircase. And of course, landing is going to be 3, I guess, because this is just a narrow stair. Okay, so this is 3 by 6, and now the thickness, that is I think 6 inches. Okay, that's good. So we will have landing, and that's the length is, let's say 3, its width is 6, and then of course its thickness, that is 0.5 inches. I mean feet. Okay, because it is 6 inches, which is of course 0.5 feet. Now we apply the same formula to the same cell over here, and this is of course 9, and that must be CFT. Okay, then we have the waist, but before waist, let me just calculate the steps. Now steps can be different in numbers. That's not 1. Okay, we will count them. You can see it. Okay, like maybe I'm gonna ignore this one because it is, you can say, a rectangular step. I can even calculate this separately, but does not matter. Okay, here it may have some foundation as well. Okay, let's say we have foundation of 6 inches, and then of course like this. Okay, something like this. So the steps, we will just count them. Okay, and you can even count them from the section and then from the 2D plan. Okay, and that's of course 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, 20. So we have actually 20 steps over here. The steps are 20, not only 1. The size, the rise is just 6 inches and straight is just 12 inches. It means the step is just triangular, and remember the area of a triangle, we just determine its cross-sectional area, and then we will multiply it with the length of the step, you can say, which is of course 3. Okay, so here this is taken as 11 inches. However, it means it is some kind of mistake over here. Okay, it should be 12 inches, but does not matter. In the section we have 11, so let's rename this one. Okay, it means it is 6 by 11 inches step. 11 inches can be converted into feet. Very simple, and you can just divide that by 12 to convert it. Okay, which is almost 0.91 something. Okay, so we'll have just a formula, you can say. Okay, for the steps,
these two columns can be cross-sectional area. Remember, the length is just 3 feet, and the cross-sectional area can be, of course, these two cells. Okay, now it is a right angle triangle, so we can take 1/2 base times its perpendicular. Okay, so you can say equal, and 1/2, that is just something like 0.5. Very simple. Okay, we'll multiply this with the width or the perpendicular, which is of course 6 inches the perpendicular, and you can say 0.5 feet, and we will multiply this with the thread, which is of course 11 inches or maybe 0.91 feet. This is the area. And now just apply the same formula. You can say this thing, the height times the cross-sectional area times the number of steps. This is going to be the quantity, and which is of course 13 CFT. Now I'm going to insert another thing. You can say the stairs foundation, or you can say base. I'm going to say base, and there is of course only one over here, and in the section you can see we have this base, okay, which is of course if I'm not wrong, that is 1 feet and 0.4 inches, almost 1 feet. We'll take 1 feet, okay, does not matter, and the height is just 1. It means it's 1 by 1. Okay, so the base is just 1 by 1, and its length must be 3, because the stair is just 3 feet wide. Okay, you can see it is total 6, but one flight's width, it is just of course 3 feet. You can see it. So the quantity can be we just drag that formula over here. You can see that must be 3, right, CFT. One thing that is remaining is of course just the waist. Okay, the waist of the staircase. And remember, as you can see in the same thing, this is going to be the waist. You can see this. Okay, the slab, you can say below the steps. We'll actually have to determine the length of the waist, and we have already learned that using the Pythagoras theorem. Okay, like if you have the height, maybe this is the height, okay, and then maybe we have the base. Okay, so when we have the height and then the base, then of course we can determine the Pythagoras theorem. I mean, by the Pythagoras theorem, its length. Okay, but I'll not use Pythagoras theorem because we have already discussed those things. Okay, in the previous few videos. So I'll just use AutoCAD over here, and as you can see, this is 8 feet and 3.5 inches. And for the second flight, you can say I'm gonna have the waist, which is of course 10 feet and 6 inches almost. Okay, I can even take the length is total, so 18 feet plus 9 inches, it means 18.75. okay, this is going to be the length of the landing. Very simple. Sorry, the length of the waist. Okay, so 18.75 is the length of the waist. Then of course we have its width, which is of course the one flight breadth or width, you can say, and there's of course 3, and the thickness must be of course 3 inches, which is of course 0.25. okay, let's just confirm if it's 3 inches or not. Very simple. Okay, I'll just annotate that and let's confirm it. It's of course 3. Okay, very simple. We'll just drag the formula so we can have the quantity, and that must be in CFT. Now, as you can see, we have now calculated the overall, you can say the total RCC work. We'll just select one extra cell and then click this summation, which is of course 562. Now, we'll have some deduction. Okay, and then we have already calculated the deduction, if you remember from the previous video. Okay, and this is the deduction for the stairs hole. If you see, we have this hole, okay, in the same drawing, like maybe this hole. Okay, so we'll just subtract that thing, does not matter. So we have the net RCC work, like maybe you can say the total RCC work, which is this thing, and we will subtract the deduction, which is 33. Okay, press enter. We have 529.03 something. Okay, CFT is the net RCC work. Okay, so these are the materials which were asked by the client. Okay, for the same project, just a simple project having 2 bedrooms. And let's just now determine the abstract of cost. Okay, from the MRS, we'll use MRS, and I guess it's enough for today, and we will of course just end the session. End the project tomorrow. Okay, I guess tomorrow is going to be the last day for the same course. Okay, So we'll see you tomorrow, inshallah, and we will just complete this project by determining the abstract of cost from the MRS. So see you tomorrow, inshallah. Allah Hafiz. Okay, so this is going to be the last session, and let me just share the screen so you guys can see it. And if you remember previously, okay, in the last few sessions, we have just determined different quantities related to the same project. Okay, this is just a small project, and this is the abstract of different materials. Okay, and we have just determined these things up to maybe the serial number 9. Okay, and this is of course the last thing or the last item, which is whitewash. Now, in the same session, which is the last session, we will be just determining the abstract of cost from the MRS, or you can say market rate schedule. If you don't have MRS, you can download it, okay, from the website. And what you have to do is actually just to open the Google and then just type MRS pre-download, anything, okay, related. You can even just type MRS and let's say for KVK. The MRS can be different depending on the country, depending on the location, okay, and even depending on the province. Okay, you can see market rate system MRS 2022 data is just available, okay, on the website of Finance Department, Government of Khyber Pakhtunkhwa, and this can even be just found, you can say, on the CNW website maybe. So you can just download this. I have already one MRS, which is old, but does not matter. We are just learning the method, okay? You can say there is MRS of 2020. I'll be just using this thing. 2020 does not matter. For the same MRS, let me just have some, you can say, extra Excel sheet. I'm just gonna create new and then Microsoft Excel worksheet. And let's say the abstract of cost. Now, I'm just gonna open this thing and then the QS project that's already been opened over there. And let me just you can say show both on one screen so we can have data exchange. And let's say this is the abstract of cost. And remember, I'll be just using the MRS, maybe 2020. Okay, if you have the new version, you can just use date, does not matter. Okay, we will be just learning the same method. For the abstract of cost, the first thing I should have is actually the serial number. And then I'll be just providing the description related to the work that has just been determined. And then we must have the quantity, and then the rate from the MRS. And of course, we'll be just including the unit, and then finally the amount. Okay, so this is going to be the abstract of, you can say, cost. And let me just add some border, like you can say all border. And let's just zoom in a little bit so you can see it. And let's just increase the width of the same cell. And some you can make some, you can say, formats related to the font, the style, okay, something such. If you see, we have different materials up to serial number 9, like maybe you can say the excavation, which is serial number 1. So I have to write all those things. You can just even copy and paste them from the same Excel sheet, okay? Now its quantity, if you see the total quantity data is 962 approximately. You can see it is 61.1 something, okay? I have just written that 62, no problem. Now serial number 2, that is of course just the PCC work, okay? PCC work, and that is 136. So you have to write the same things in the abstract of cost because we are determining the cost, okay? Now serial number 3, that is of course the brickwork in the foundation, okay? So serial number 3, and that is the brickwork in foundation, and of course that is 1:3 mortar. Then we have serial number 4, and that, let's see what that is. That is of course the brickwork and superstructure, okay? And these things are separate because their rates can be separated. Maybe different rates may be available, okay, in the MRS. That's why we are writing these things, okay, separately. You can say brickwork in the superstructure. SS means superstructure does not matter. Number 5, and that is the DPC 1 to 4, and number 6, let's see, that is RCC work, which is 1, 2, 4. Okay, number 7, we have up to 9. Okay, so let's say number 7, that is parapet wall, or maybe you can say chajja. I'll just write chajja, does not matter. And then number 8, that is plaster work. Finally, we have the whitewash, which is number 9. I'll also include one thing, which is actually number 10, and let's say that's openings. Okay, such as doors, windows, ventilators, etc. Okay, so I'll just take approximate value per dead. I'm not gonna include each separately. That's gonna be just the wastage of time. Okay, you can even include that separately if that's required, no problem. Now, there are quantities which I just forgot and did not include it yet. Okay, so the whitewash that is just known, which is of course 43 and 11. You can see that, okay, SFT, and the, of course, plaster work, which is also known, and that is, let's say, 4,299.9 something. Okay, and there is, of course, the chajja. If you see, that is just 124, and that's in running feet. Okay, so we have 124, or let's say 125. We'll just you can say take a round video. Now the RCC work, if you see, that is of course net RCC work 529. So we have 529 CFT, and then let's see the DPC, which is of course 320. Okay, 320. That is also of course SFT, because we don't include the thickness. Now the brickwork and superstructure, that is going to be of course the inner brickwork, which is 1515, and then brickwork and the foundation. Of course, this is going to be over here, which I guess we have not yet added, is the overall work. Okay, you can see it over here. Okay, this is the brickwork and the foundation. So let's just add them all, and I'm gonna just insert one raw, so we can have the total brickwork. Okay, work in foundation, and I'm gonna just include or maybe select one extra cell for the summation, and just click that summation over there. Okay, so we have 438.7 CFT. So I'll just include that over here, 437.7. Now the PCC work, which is the last work, we have excavation, and then PCC, which is over here, that is 360.4. So we have 360.4. And this is what we have. Now I'm gonna close this thing and let's just save it, does not matter. Okay, we have this thing now. And you can say some materials. Okay, let me just wrap the text so we can see it. Okay, all the text in the same column or cell. Now openings of doors, etc., you can include that in terms of area, does not matter, but I'll take this is overall. Okay, like maybe unit. Okay, or you can say let's just see what we do actually locally over here. If we have one room, bath, and maybe they may include one door, okay, and then window and some ventilation stuffs. Okay, so I'll just consider this thing is a maybe 3 rooms work. Okay, so let's say I'm gonna take 3 unit. Now in the rates, I'll just assume the rate like maybe for one room or for one bedroom, that's actually almost over here, and in local area, that is actually 55,000 rupees. Okay, let's just take the other things from the MRS, and I'll just run MRS, or you can say open MRS. Over here I have MRS 2020. You can double click it or just download it from the Google. Okay, a new one. Now as you can see, this is MRS. At the very start, as you can see, it is market rate system, and this can be actually, we have some detailing or maybe some notifications related to this guy. There are some area factors, of course, and some location factors, because rates may be different according to the location, according to the province, according to the district. Okay, and we have some conversion tables which we don't need, of course, over here in the same session. So we have these informations, and here, as you can see, we have table of content. If you need to determine something quickly, as you can see, let's say the earthwork, okay? And the earthwork, we may have excavation and embankment, and that is on page 9, okay? If you just type earthwork over here, that's also gonna work for you, no problem, okay? Just search that over there and click the arrow. As you can see, in the same abstract of cost, we have excavation, and that's of course in the soft or maybe earthen soil. So let's just look for the excavation, okay? As you can see, we have excavation in hard rocks requiring blasting, okay? This is just a small project, does not have any blasting, okay? Let's just look for the same earthwork, okay? As you can see, we have the excavation in shingle or gravel formation. However, our soil that is just soft. So we may have excavation over here, okay? Just you can say a very simple excavation, earth excavation, undress up to single throw up KC porch, etc. Okay, excavation, undress up to single throw. Okay, so these things can be taken. Very simple, okay, because they are not that huge work. You can say hard strata, maybe there is no rock in the same work. Okay, as you can see, we have earthwork and ashes, sand and soft soil or cell clearance. Okay, so this is good. You can see. But this is up to 15 meter, okay? Our work is just in the same, you can say, limit. So I'll take this guy, and as you can see, there are actually systems. You can see the British system and then the metric system. Our work that is actually in the FPS system or maybe in the British system, because we have determined everything, okay, in CFT, in SFT, or maybe in running feet. Okay, we don't have anything in the metric system. So let's just see the excavation over here. We have the unit, which is of course 1000. Okay, so the unit that is actually 1000 for the same work, like maybe you can say 1000 CFT, right? Very simple. And then just a minute, I'm just gonna close this thing. We don't need that, okay? I mean the AutoCAD file. That is 1000, and the rate, if you see the labor, if you need only labor, you can take this value, but I'll take the composite because we need the abstract of overall cost, maybe the cost of construction, okay? So that is just 4057.2. 4057. This is just, you can say the rate, and this is RS. But 4057.2, this excavation can be done, or you can say this is the cost of 1000 CFT work. Our work is not that much. As you can see, this is not even 1000, okay? So what should be the amount? Now, if you see, we have actually this rate, you can say, and this is per 1000 CFT work. So you can even divide that by 1000, okay? But first, let's just multiply this with the quantity. And then we will just divide the same thing by the unit. You can say this one, okay? Like divide it by 1000 and then press enter. So this is going to be just the excavation rate for the same project, okay? 3,903 rupees, you can say. The amount, you can just say, let's include one bracket, like maybe RS or PKR. Your countries, you can say unit or maybe the currency can be different, okay? Over here, this is a Pakistani currency or maybe PKR. So we can include anything, okay? You can say you can include any unit, okay, according to the MRS that is available in your country, does not matter. Now, PCC work, which is 136. And as you can see, we have a concrete, okay, on page 28. Okay, let's just type 28 over here that can access to the same place or not. 20, yes, this is concrete. You can see it over here, okay, chapter number 6. Now, mud concrete and foundation, okay, our work is concrete, but that's not mud concrete. We have cement concrete, and that's of course in the foundation. So cement concrete, you can see it, we can use any of these, you can say description, okay, like you can say cement concrete brick / stone blast 1.5 inches to 2 inches, okay, and shingle well graded foundation, cement concrete brick stone blast, etc. Okay, you can just look for the same work that's just I mean, that's just suitable for the same description, okay, which you have. Now, plain cement concrete, including placing, compaction, finishing, and curing, which is a ratio is that is actually 1:4. Our ratio that is actually 1:36. Okay, so you have to even consider the ratio, which is 1:36. And I guess I should take this guy, okay, which is you can say this guy that has just been selected. You can see that, okay. So the unit is actually 100 CFT. So I'm gonna take the unit is 100 CFT and the rate. Let's see the rate that is actually the composite rate, which is 16,769. Okay, so we have 16,769 point something, if I can remember that, 0.17, that's of course. So we have this rate. This is the same formula, just drag it below, and as you can see, we have this total amount. Okay, like maybe you can say D4, that is of course the rate, and we're gonna multiply that with the quantity, which is C4, you can see that, and then we will divide that by the unit, which is of course 100. So this is it. Now the brickwork and the foundation. Let's just see. Okay, we have brickwork. It's over here, brick masonry, okay? And as you can see, first class brickwork and mud, mortar, building and foundation and plan. First class brick in mud, this is in mud, okay? And we will actually look for the cement mortar. As you can see, this is first class brickwork in the foundation and plinth in the cement. And of course, that is 1:3. The work is 100 CFT. And the composite rate, that is of course 26,867. Okay, so you can say the rate, that is 667.13. The unit is of course 100, and we will just drag the formula below. Now the brickwork and superstructure, it is the same thing, I guess. Okay, but however, we will see it in the superstructure or maybe in the ground floor, you can say. Okay, so there must be brickwork in the ground floor. Let's just see if we have that. So first class brickwork in the ground floor, cement and sand mortar, 1:3. Okay, it's just over here, you can see it, okay. And the rate is actually 28,748, 28,748 approximately. And the unit is of course per 100 CFT. I'll just drag the formula below. Now let's see. Let's just look for the DPC, if that work or not. Okay, we have dam proof course. Let's see if we have 1:4 concrete. We're here. I'll take anything. Okay, no problem. Like this one, and that is 9,000, which I'll take approximately 10,000. Okay, so let's say the rate is 10,000, and the unit is of course 100 SFT, and that's of course 32,000 rupees. Similarly, you can just do the other remaining things, okay, by yourself. Look that in the MRS, okay, very simple work. And let's just provide, I'll just provide videos over here, very simple videos maybe, okay, 50,000, okay. And then for the chaja, let's say we have 5,000. And for the plaster, let's say we have 5,500. Okay, whitewash, let's say we have 4,000, and so on. Okay, and let's say for the RCC work, we have 100 CFT. For the chaja, let's say we have, and that's actually in running feet. Okay, so I'll take per feet maybe 1, like, okay. And similarly, for the plaster work, I'll say 100 SFT. For the whitewash, 100 SFT, no problem. And for the opening, I'll say 1 unit, right? So as you can see, we have all this information, and then of course the cost. Now I'll make this guy total, okay? So we have the total, as you can see by the summation, and this is actually the total cost. Okay, let me just have that. We have the total cost. Okay, so it was just a last session, and I guess we have nothing left over here, and you guys are just good to leave the class, no problem, okay?